Hello and welcome to the Complete JavaScript course. I'm really happy to welcome you to this huge course, which will take you from knowing nothing about JavaScript to an expert JavaScript developer. And learning JavaScript is a great choice, not only because it's the most popular programming language in the world, but also because it basically powers the entire modern web. And this course is, in my opinion, the very best way of learning JavaScript that you will find. And so you have come to the right place. Now, before we start learning, let's take a couple of minutes to get a quick overview of how the course is organized and the projects that we're going to build together, so that you know exactly what to expect. So the course contains about 20 sections with over 60 hours of video content. And we're gonna kick off the course in section 2 and 3 with the very basics of the JavaScript language, to give you a solid foundation for the rest of the course. Then you will learn some general skills that you will need as a developer, like problem solving, fixing errors, and setting up a development environment. After that, we built our very first project with the user interface. So this section is about DOM manipulation, and we will build not one, but actually 3 beautiful but simple applications. Then in section 8, we will take a detailed look behind the scenes of JavaScript to learn how the language actually works. And this will give you valuable knowledge that many other developers simply don't have. Then in sections 9 and 10, we will keep working on our JavaScript fundamentals, but now with a focus on more modern ES6 topics, such as maps and destructuring, and also strings, functions, closures, and more. Then, throughout sections 11 and 12, we will build our next beautiful project, which will teach you all you need to know about array methods, numbers, dates, and timers. And after that, we jump right into our next project, which is gonna be this beautiful website, full packed with visual effects and components such as lazy image loading, a tabbed component, a slider, and so much more. In section 14, we finally reach the pretty advanced, but also very important topic of object-oriented programming with constructor functions and ES6 classes, which will then, in the next section, allow us to build this stunning real-world project. And besides object-oriented programming, this project will also teach you how to incorporate a map and how to actually plan and structure a project, which is also super important. After that, you're gonna learn all about asynchronous JavaScript, which is used for things like loading data from external web servers with Ajax. Then in sections 17 and 18, we will learn how modern JavaScript applications are actually built using cutting-edge technologies like NPM, Babel, Parcel, and ES6 modules. We then take these modern tools and everything that we have learned up until this point to build this biggest and coolest project in the course. And we then even finish this project by deploying it to the internet using Netlify and Git in section 19. So as you see, I included everything you need to know about JavaScript in this course, along with a ton of real-world projects and challenges. Now, your next step is to watch the next lecture, which is super important to set you up for success in this course, with instructions for many things like how to ask questions. Now, if you already know the fundamentals of JavaScript, then after the next lecture, please move ahead to the section called How to Navigate this course, where you will then find your perfect learning path to navigate this huge course. But if you're new to JavaScript, then of course just move on to the next section. Alright, so I hope that you're gonna have a ton of fun with this course, that you become a really advanced JavaScript developer, and that you will take your web development career to the next level. And with that being said, let's finally get started. Now, before you start, here are 10 quick considerations on how to take this course. And I promise they are super short and super important. So please don't skip this video. And first of all, there are many different types of students in this course. Some have never programmed in their life. Others have experience with other languages, but not with JavaScript. And even others have some experience with JavaScript, but want to become even more advanced. And this course is for all of you. Everyone is welcome. So please don't write a bad review right away if the course is too easy or too hard or progressing too slow or too fast for you. I built this course with everyone in mind. Now, to make the course perfect for you, you can always rewatch lectures, jump to other more advanced sections, watch the course with slower or faster playback speed, or ask questions in the Q&A section. Of course, you can give a 1-star review if the course is absolutely terrible, but please at least wait a couple of sections to get a good idea of the course. Now, about actually taking the course, you need to code along with me. And this is crucial. You will learn exactly 0 JavaScript skills by just sitting and watching me code. So you have to code yourself, even if you're just typing the same code as I am typing in the video. It doesn't matter as long as you're coding. Next, try all the coding challenges. Do the best that you can, but if you get stuck for too long, then simply watch the solution. And I can't stress this enough. You have to try the coding challenges, because otherwise you will miss half of the learning opportunity in this course. And please don't beat yourself up if you can't figure out the solution. This is completely normal, trust me. And figuring out the solution is actually not even the main point of these challenges. So if that happens, just rewatch the lectures that were covered, try to understand them better, and move on. If you want the course material to stick, then take notes. Notes on code syntax, notes on theory concepts, and really notes on everything. You can't take too many notes. And everyone has their own style, so just find yours. Now, if this is your first time ever programming, then please don't get overwhelmed. It's 100% normal that you will not understand everything at the beginning. Just keep going through the first few sections, even if you don't understand everything at first. You soon will, believe me. But please just don't think, I guess coding is not for me. That thought is simply not allowed here, okay? So keep in mind that everyone has different learning speeds. I have seen tens of thousands of students progressing through my courses. So believe me, this is completely normal. In the first couple of sections of the course, don't bother understanding exactly why things work the way they do in JavaScript. Also, in the beginning, don't stress about efficient code or fast code or clean code. That's all super important, don't get me wrong, but in the first few sections, while still learning, we just want to make things work. We will understand the why later in the course, and of course, make the code clean as well. The sections in the course build on one another. So before moving on from a section, make sure that you understand exactly what was covered. So take a break, review the code that we wrote, review your notes, and review the projects that we built. And maybe even write some code yourself in order to practice. Only then you're ready to move on. If you ever have an error in your code or a question, always start by trying to solve it yourself, because this is absolutely essential for your progress. Now, if you cannot solve the problem, then check the Q&A section, because someone probably already had the same problem before. And if that doesn't help either, then just ask a new question. And to do that, use a short description, post your code on codepen.io, and share the link in the Q&A. Because without the code, we will not be able to help you. I built and recorded this course on a Mac, but everything works the exact same way on Windows or Linux. So if something doesn't work on your computer, it's not because you're using a different operating system. Okay? And now, finally, and most importantly, have fun. Coding is a lot of fun, and it's so rewarding to see something that you have built yourself. So if you're feeling frustrated for some reason, stop whatever you're doing and come back later. Always have fun while coding. Okay? And with that being said, let's now get started. Now, before we can write any code, we need to install and configure a code editor. So, a code editor is the main tool for any developer, and we use it, as the name says, to write our actual code. And so let's now go download a code editor. And the one that I advise everyone to use is Visual Studio Code, or VS Code for short. So this is, in my opinion, the best code editor by far that exists. And that's not just my own opinion. So VS Code is right now by far the most popular and most widely used code editor. And that is for a reason. It simply is the best and easiest to use, and of course, it is completely free. Now, there are alternatives if you don't like VS Code for some reason. So you can use Atom, or you can use something like Brackets as well, which is the code editor that I used to teach a previous version of this course. But again, I'm going to use VS Code in this course, and so I really advise you to follow this course using the exact same code editor to make everything easier for you to follow. So again, this code editor is completely free and it works on every platform. So just download whatever installer that you need for your own platform, then install, of course, that code editor on your computer. And once you're done, come back to this video so that we can together set it up a little bit, just so that we can get started in the next section. Okay, so I hope that you managed to install VS Code on your system, and as you open it up, it should look something like this. Now, the colors should probably all be different, but we will fix that in a second. And maybe this welcome screen also looks different, and maybe these icons here, because you might have installed the editor sometime after I recorded this video. But anyway, the main things should still work the same. And so let's actually start by installing a theme. So a theme is basically all the colors that you see here on the screen, and also the colors in the actual code that you're going to write. Okay? Now you don't need to install a theme, so you can simply change one of the themes that is already included in VS Code. So just click down here on this icon and then color theme, and then here you can try one of these out. And so if you like one of them, you can simply keep that one. But as you see, the theme that I have is this Monokai Pro. And this one was not included by default by VS Code. And so if you want to install the same theme as I have, then simply come here to this Extensions tab and then search for Monokai Pro. Okay, then it's this first one here. And then you can simply, probably somewhere here, click on download. Now, this theme is actually a paid theme that you can buy for about $10 or so. However, you can actually also use the theme for free forever. It will then just ask you every couple of days for you to buy it. But for me, that has never been a big problem. Now, I just wanted to quickly mention that I'm not in any way affiliated with the theme and that this is not an advertisement. So this is simply the theme that I love and that I use every single day. But of course, you can use a different theme or a theme that you have already been using yourself. But if you like the theme, then you can support the creator, or you can use the theme for free, or you can of course also use another theme. And one other theme that is very similar and which actually already comes with VS Code is Monokai Classic. So it's this one. So the colors here look a little bit different, but the Monokai Pro theme that I use is actually based on this one. And so therefore colors are quite similar. And so therefore this one is also a good pick in case you want to use a very similar theme to mine, but don't want to use Monokai Pro. But I'm gonna set it back to Monokai Pro now. And so that's it about the theme. And so let's now move on and also talk about VS Code settings. And so here I'm going to show you a couple of settings that I'm using in the course videos and that you should probably use as well to make it easier for you to follow the videos and also to code on your own later on. So the first setting is this autosave setting that you should set to on focus change. Okay? And so what this will do is that whenever you leave the code editor or you go to some other file, then it will automatically save that file without you having to do anything. And so that's very helpful. Now, if this isn't showing up here for you, up here you can simply search for everything. So you can simply search autosave like this. And then again, change it to on focus change. Then you could also change the font size, but that's not really important for you. Then another one is this multi-cursor modifier. And this one sounds a bit weird, but you can simply set it to Control-Command, or you can leave it at Alt. So just when you need it, just know which of the two you selected. But for now, again, this is not important. I will only start using it a bit later. Then I also have the word wrap turned on, but again, that's not that important. Okay, so I think those are actually the most important ones. There's just another one that you need to change, and that is called format on save. All right, so just turn this one here on, which says that a formatter must be available, and by now it is not. But in one of the next sections, we will actually install a formatter to automatically format our code. And by then, this setting here must be turned on. Okay, and that's actually it for this lecture already. Now, just notice that I'm working on a Mac here, but everything will work exactly the same on Windows and on Linux. So this VS Code editor, as I mentioned earlier, works just the same on all the platforms. Now, just one final and small adjustment that we can make, which I just remembered, is that besides changing the main color theme, we can also change the theme of the file icons. And so again, if you want your VS Code to look exactly the same as mine, then you can select these SETI icons here. So by default, I think it should be this minimal, but I prefer these ones here. And so by selecting this one here, then your code editor will probably look exactly the same as mine. All right, and with that, we are actually ready to move on. Just make sure that you also have the latest version of Google Chrome installed on your computer, because that is going to be the browser in which we will be testing our code. All right, but with that, we are now really done with this video, and so I see you in the next one. Welcome to the first section of the course. In this section, you will start learning the very basics of the JavaScript language. So things like variables, data types, operators, if-else statements, and more. So in this part, we will not yet start building beautiful user interfaces. We will do that later, of course, but first we need to focus on the language fundamentals. And so these lectures are designed for you to learn these fundamentals and to give you an overview of the language before we actually dive deeper in later sections. Okay, so let's go start this journey right now. So let's now write our very first line of JavaScript code. And for now, we will do that in the browser developer tools. So just to get started as quick as possible. We will then switch to the code editor that we just installed before in the next video. So make sure to open up Google Chrome, and then there are 3 ways in which we can open up the Chrome developer tools. First, we can hit Command-Option-J on the keyboard, and that's on Mac. So on Windows, that's going to be Control-Alt-J. And so this will then open up this console that we see here. So all of these tabs here are basically the developer tools, but we are just interested in the console. Okay. Now another way of opening the developer tools is by right-clicking and then inspect, which will bring us here to the Elements tab. And then from there we can go to the console. And the third way, and I'm showing you all of them because I know that different people like to do it in different ways. So the third way is to come here to the Chrome menu, and then in there we go to View, Developer, and then JavaScript Console. Okay, and so we're back to the JavaScript console. And I'm increasing the font here a little bit by hitting Command+, and give it some more space. Now this JavaScript developer console allows us to write and test JavaScript code. So it's very useful during development, for example, to fix errors. Now we don't write real applications, of course, using this console, but now just to get started, let's use the console because it's a good and easy way to just write some JavaScript here. So let's write alert, which is a so-called JavaScript function, then open up parentheses and without a space between alert and the parentheses, and then we write a so-called string, so which is basically text, and let's write hello world. So that's the standard way of learning programming in any programming language. Then we write the closing parentheses, and then let's hit return or enter. And you see that JavaScript gave us this pop-up window here, which says hello world, just as we typed here in our string in our code. Great, so that's your very first line of JavaScript code right there. So any code that we write here and then hit return will immediately get evaluated. Okay, but of course we can do a lot more. So let's write some more JavaScript code, which of course you do not need to understand yet. I just want you to show some stuff that we can do. We will go into how everything works as we progress through this section, okay? So just to experiment a little bit, let's write a so-called variable. So let's say let JS equals amazing. And so once more, we are basically writing a string here, so text, and then we will do if and open parentheses JS is equal to amazing. Then we want an alert window, like we saw before, saying JavaScript is fun. And if I hit now return, we get this window which says JavaScript is fun. Okay? So again, I will explain all these concepts and how all of this works here as we go through this section. But for now, I hope that you can see the logic that we basically defined JS as being amazing, and then here in the next line, we said that if JS is equal to amazing, then JavaScript should show us this alert window with this text. Okay, and now we can also change JS to boring, hit return again, and now let's copy this text here again. So we want to run it again. So I'm just copying it and pasting it here. Okay, so let's try that again. And this time nothing happened. And so that's because JS is now no longer amazing. It is boring. And so in this case, if JavaScript is amazing is not actually true, right? Because it's boring now. And so in this case, the alert window is not shown. Now there's also another way of going to the previous command, which is by hitting the up arrow on the keyboard. So just like this. And so we can see all the previous commands that we used before. Great. Now another thing that we can do is to do simple math operations. Let's say just 40 plus 8 plus 23 minus 10, let's say. Hit return, and then here we get the result. So basically we can use this as a calculator. And I hope that you can see how useful this is going to become later down the road. Okay, and that's it for now. So I hope that this gave you a nice first taste of the language and of everything that is ahead. So if you want, you can experiment a little bit more with this, or you can move on right to the next lecture where we will learn what JavaScript actually is. So see you there. So you've already written a line or two of JavaScript. But what exactly is JavaScript? And what can we do with it? Well, that's exactly what we're going to find out in this video. And so in this lecture, we will set the stage for the rest of the course. And so it's really important that you follow this one until the end. So we can define JavaScript in many different ways. But my definition is that it's a high-level, object-oriented, multi-paradigm programming language. And with that being said, can we move on to the next lecture now? Well, probably not. Because what does any of that actually mean? So let's deconstruct this just a little bit to at least make some sense out of this. And starting with programming language itself, a programming language is basically just a tool that allows us to write code that will instruct a computer to do something. And of course, that's our main goal of using JavaScript, right? Then I go on and say that JavaScript is a high-level language, which means that we don't have to think about a lot of complex stuff, such as managing the computer's memory while it runs our program. So in JavaScript, there are a lot of so-called abstractions over all these small details that we don't want to worry about. And this makes the language a lot easier to write and to learn. Next, I say that JavaScript is object-oriented. And all that means is that the language is mostly based on the concept of objects for storing most kinds of data. And of course, we will learn all about object-oriented programming throughout this course. Finally, JavaScript is also a multi-paradigm language, meaning that it's so flexible and versatile that we can use all kinds of different programming styles, such as imperative and declarative programming. And these different styles are just different ways of structuring our code, basically. Again, you will learn all about this throughout the course. This is just the first, very high-level overview, but I hope it's been making sense so far. Anyway, now that we know what JavaScript actually is, at least kind of, what is the role that it plays in web development? Or in other words, what do we actually use it for? And to answer that question, let's actually look at the three core technologies of the web: HTML, CSS, and of course, JavaScript. So these three technologies all work together to create beautiful, interactive, and dynamic websites or web applications. Now, the HTML is responsible for the content of the page. So the text, the images, the buttons, and all the content that you see on a web page is always written in HTML. Then the CSS is responsible for the presentation of that content. So basically for styling and for laying out the elements on a web page. And then finally, JavaScript is the real programming language of the internet, and it allows developers to add dynamic and interactive effects to any web page. We also use it to manipulate the content or the CSS, load data from remote servers, and really build entire applications in the browser, which we then call web applications. Now we can also use the analogy of nouns, adjectives, and verbs to make this separation of roles a bit easier to understand. So in this analogy, HTML represents the nouns, for example, saying that the P element is a paragraph. And so paragraph is the noun here. The CSS then is the adjective because it describes the noun. Like this piece of CSS saying the paragraph text is red. And so here red is the adjective describing the noun. And finally, JavaScript is of course the verb, like saying hide the paragraph. And so here we are doing something. And so we have a verb. Okay? Does that make sense? Now, since we've been talking a lot about dynamic effects and web applications here, let's now actually take a look at a real example to make it even more clear what JavaScript is capable of. And so this is the Twitter web application on twitter.com. And there is a lot happening as we open a profile page like this one. And so I thought that this was a very cool example. So right off the bat, you see that there are these two rotating spinners on the page, meaning that JavaScript is probably loading some data from the Twitter service in the background. Then, as the data arrives, JavaScript hides these spinners and instead shows the loaded content. So this is a very cool example of manipulating styles and content, right? But there's also some simpler dynamic effects on this page, like JavaScript showing the tweet box whenever we hit the tweet button, and then hides it as we click outside of that box. And finally, JavaScript also displays this really nice user information as we hover our mouse over any user on Twitter. And it probably also loads this data on the fly. So a lot of cool stuff going on here, and it's all powered by JavaScript. How cool is that? And in fact, by the end of the course, you will actually know how to use all of these techniques that we just saw here. And so I hope that this makes you even more excited about all the content ahead. All right, now that we saw what JavaScript is really capable of, let's quickly recap and also look at other cool stuff that we can build with the power of JavaScript. So as you already know, JavaScript allows us to add dynamic effects to pages. And in fact, to build entire web applications in the browser. And these applications feel almost like the apps that we use on our computers and phones every single day. So we can say that JavaScript is what made modern web development and really the whole modern web itself possible in the first place. Now, if you're already somewhat familiar with the web development industry, you probably heard of modern JavaScript libraries and frameworks such as React, Angular, or Vue, right? And if you didn't, that's absolutely no problem. All you need to know is that these are basically tools that make writing modern, large-scale web applications a lot easier and faster. Now, what matters here is that all these frameworks and libraries are still 100% based on JavaScript. And what this means is that you should become really good at JavaScript before learning and using any of these frameworks, and not just jump into your first framework after you know how to write like 10 lines of JavaScript, okay? Also, your library of choice might not always be as popular as it is today. And the best way to be prepared is, you guessed it, becoming really good at JavaScript. Because then you can easily learn whatever is popular next. So no matter what anyone tells you, learning JavaScript properly is the single best investment that you can make in your web development career right now. Now, the JavaScript language and the web browser are actually two separate things. And what that means is that JavaScript can also run outside of web browsers. For example, it's possible to use JavaScript on a web server using a very popular technology called Node.js, which doesn't need any browser at all. And this allows us to create so-called back-end applications, which are simply applications that run on a web server and interact with databases and stuff like that. On the other hand, when we use JavaScript in the browser, we create so-called front-end applications. So in this course, we will learn the ins and outs of the JavaScript language itself, and of course also how to use it in the browser in order to create all these amazing effects that we've been talking about. So basically, we're going to be building front-end web applications. And in the future, I might also add a section about Node.js at the end of this course, so that you can get a sense of how we can use JavaScript outside of the browser environment as well. All right, and now just to finish, I want to mention that we can actually also use JavaScript to build kind of native mobile applications, as well as native desktop applications for any phone and computer operating system out there. That's because of modern tools like React Native, the Ionic framework, and tools like Electron. These have completely changed the whole development industry over the last couple of years, making things possible that were never possible before. So as you can see, there's almost nothing that you can't build after becoming really good at JavaScript, which, if you think about it, is really kind of mind-blowing. It's just amazing because the possibilities are so endless. Okay, and now to finish this lecture, I want to briefly talk about JavaScript releases, or versions as you might call them. We will come back to this topic by the end of the section because it's super important, but it's also a good idea to get a first overview of JavaScript releases at this point. Anyway, to make a long story short, there has been a huge update to the language in 2015, which is officially called ES 2015. But most people just call it ES6, simply because it was the release after ES5. And by the way, ES stands for ECMAScript. Now, after ES 2015, there is now a yearly new release with a couple new JavaScript features. In all of these new releases, or versions, starting from ES 2015, is what we call modern JavaScript. But why am I telling you all this? Well, it's simply because in this course, I'm going to teach you modern JavaScript right from the beginning. And I wanted to make that very clear right from the start. However, I'm also convinced that you need to understand what came before ES 2015, so ES5. And so I will also show you what's important of ES5. The reason for that is in a complete video about JavaScript releases at the end of this section. Because now I no longer want to bore you with theory. So instead, let's now finally get started. Alright, now that we know what JavaScript actually is, let's now learn how to write code in a special JavaScript file and then how to run the code in the browser. Now, to get started with this section and with this course, you need to start by downloading the starter code from this GitHub repository that I created for this course. So this repository is at this URL here, which, in case you missed it, is at the very beginning of the course. So in the first text lecture of the first section. And in order to now actually download all of the starter code, all you need to do is to click on this green button here and then download zip. Okay? Now, by the time you're watching this video, GitHub, which is this website where developers basically host code, so later this website might look a little bit different, but just watch probably for a green button, which then says download zip. All right. Now, if you're on a smaller screen, or maybe on mobile, then this green button will actually not be visible here. So in that case, just scroll down a little bit here to the FAQ section, and then here you have this link. So you can also download all the code by simply clicking this link here. And by the way, since we're already here in the FAQs, please make sure to also read all of them before you actually move on in the course. So you will probably have one of these questions at some point, and so it's easier to then simply find the answer right here. Okay, but that's it here for GitHub. Now let's go ahead and extract all of this data that we just downloaded. And so here we go. So this is the starter code. And here you have basically one folder for each section or each project that we're building in the course. Then inside of each of these folders, you will always have one final folder and one starter folder. So you see that happens in all of these folders here. Now, the final folder is basically the final version of the code as it looks by the end of the section or by the end of the project. And so in case something goes wrong in your code while you're following the section, please then compare your code with the final code that is included for each of these sections. And that will then allow you to find and fix any mistake that you might have made in your code so that you can keep going in the section. But anyway, what we're most interested in the beginning is the starter code. So each of these folders has the starter code, and that's basically the starting point of each of these sections or projects. So let's now actually drag this folder here onto the desktop. And then I'm going to open it up here separately. And in my case here, since I'm actually the one writing the code first, it doesn't make a lot of sense to have these two folders here. So I will actually go ahead and take the index out, but you should not do that. So you should use this starter folder here as your project folder in VS Code. Okay, but again, I will now delete these two because I don't need them here to build this course, basically. But anyway, let's now open up a new VS Code window. So new window, and then here we click on open folder. And then we are already in the desktop. Let's just make the window a bit bigger here. And then I will select my project folder here. So in my case, that's going to be this folder. But again, you should now use that starter folder that's in here as your project folder. So I think that's the best way for you to approach this. So with that project folder selected, hit open. And then here we see the index.html file that we already had in our starter code. And this is an HTML file because usually JavaScript is attached to web pages, at least when we're building front-end applications, as we learned in the last video. So to start, we always need an HTML document like this, because our JavaScript needs to be attached to an HTML document. Now in HTML, there is a script tag where we can write JavaScript. So let's do that here in the head, right beneath this style. And if you're completely new to HTML and have no idea how it works, there is a very short crash course on HTML and CSS in section 5 of this course, I believe. So if you want, you can take that just to learn about the very basics of HTML and CSS in like 30 minutes or so. Anyway, let's now create this script tag here in which we will write our JavaScript now. Because in the first video, we wrote JavaScript in the console, remember? But that's not how real development works. So instead, of course, we write the code in files. So let's just write for now the same code that we wrote in the first video. So let JS equal amazing. And then in JavaScript, we usually add a semicolon to the end of each line. And this will then let JavaScript know that we are done with this line. And it's actually not really mandatory. And you will see some people omit the semicolons, but I still consider it a good coding practice. And I believe it makes the code a bit cleaner. So just like before, we are then saying if JavaScript is amazing, then alert that JavaScript is fun. And once again, don't worry yet about how this code here works, okay? Just type it for now and just have a general idea of what it does. Now, to actually execute this code, so in this example, to show this alert window, all we have to do is to open up index.html in the browser, because again, this is where our JavaScript is now attached to, right? So let's do that. And so I'm going back to my desktop and then open this file with Google Chrome. And indeed, right away, we get this alert saying JavaScript is fun. And so that is coming from our index.html. We can click OK, and then it finishes. And we see our starter file, which is actually this text. So if you see in VS Code, JavaScript Fundamentals Part 1 in this H1 tag is exactly what we see here. And so we opened up the right page, and also our JavaScript is working. So if we reload this page now, we should see that alert window again. And indeed, here it is. Okay, let's push this to the side here. Here's the code from our previous lecture, VS Code, and push it to the other side. Okay, we can then get rid of this sidebar here that we don't need by hitting Command or Control B, or by clicking this file icon. And with this, we have enough space to see the editor and the browser here on the other side. So let me show you something very important now, which is how to see results from our code back in the browser. So let's take this math operations that we did in the previous lecture. So that was 40 plus 8 plus 23 minus 10. Let's give it a save. And you see that JavaScript actually automatically formatted this code. And I will show you later how you can set that up for yourself. Anyway, if we now reload this page here, where do you think this result will appear? So clearly it's not in this alert, and it's also nowhere on this page, because we didn't tell JavaScript to put it on the page. So let's open up the inspector here, and I will do inspect, and then the console, and then again increase the text, command plus, plus, and plus again. And you see that the result is also not in the console. So why is that? Why is this result not in the console like it was before? Well, it's because the console is just an environment that was built to execute small pieces of code and then show results immediately. So just like we did in the previous lecture. But it doesn't show results of our operations in code by default. Now, if we still want to display results, for example, from a calculation like this here in the console, we need to tell JavaScript to explicitly output that result to the console. And we can do that using a special function called console.log. Okay? And then if we take this code here and copy and paste it, and then save it, and then reload, then we need to click OK so that JavaScript can move on to the next line. And then we actually get the result printed to the console here. And it actually says that it's coming from index.html at line 31. And so that's exactly the line where we did do this computation. Okay, but let's recap here, because I know that this is confusing for many beginners. So in the last lecture, we were already in the console. And so then there was no need for using console.log. We also needed no script tag when we were in the console, right? But now we are actually in a script and no longer in the console. And so now we need to explicitly say console.log whenever we want to access the developer console like we did here. Okay? So basically, this is like building a bridge between our script here and the developer console on the other side that lives in the browser. And now to finish this lecture, let's actually take this JavaScript code out of the HTML file and put it into its own separate JavaScript file. So what we have right now, this script here, is called an inline script. And the only advantage of an inline script is that we don't have to load another file. But on the other hand, it's pretty bad for separating the website content from the JavaScript logic. And so usually we use external JavaScript files, as I just mentioned. Okay, so let's come back to the sidebar here and create a new file, which I'm going to call script.js. And that's a pretty standard name for a JavaScript script. Okay, so let's take that back. Come here, copy this code, and paste it here. And then once more, VS Code actually formatted the code here nicely. If it didn't on your computer, then just do that manually, and I will show you later how to set that up. Okay, and now we can get rid of this script here. Great, now we have a better separation of concerns between presentation and logic, and this also makes it easier to maintain code in the long run. All there is to do now is to link this JavaScript file to the HTML file, because right now our HTML has no way of knowing where the code is actually located. So if we execute this code by reloading the browser, now nothing will happen. Again, because this HTML file right now does not know where to find the JavaScript code. So let's do that connection, and we usually do that at the end of the body tag, okay? And actually we will use script again. All right, but now this time we're not gonna put any code inside this script element, but instead we are gonna specify the source attribute. So here, all we need to do is to then specify the name of the script and the location. Now in this case, this script, so this script.js file is in the same folder as index.html. So all we have to do here is to just write the file name like this. We don't have to specify the entire path to the file. Okay, so if we save this now and reload, then you see that it's back to working. So we have this pop-up here again, and then our result of this computation. Now, if you didn't get the alert window or this output here, then that means that your script file is probably not correctly linked to the HTML file. So in that case, please make 100% sure that the script file is in the exact same folder as the HTML file. Also make sure that you correctly spelled script src, just as I have it here in my HTML. And finally, also make sure that you have no errors in your JavaScript code. So these are some common mistakes that I see people make, which then leads to their script not being correctly linked. Okay, but anyway, at this point, we no longer need index.html open here. And here we have only our code logic. The rest of the presentation is gone. And so this is much cleaner and much easier to work with. Great. So now you know how to link a JavaScript file to an HTML file and then how to run it all in the browser. And that means that you're now finally able to really start learning the JavaScript language. So see you in the next lecture where we're going to start doing just that. Welcome back. Let's now start to really learn the JavaScript language, starting with values and variables. And let's start by getting rid of some of the code that we have here. So this one here isn't doing anything. And let's also delete this one so that we don't get that annoying pop-up all the time. So in this section, I will be using persons as examples. For example, a person's name, a person's age, or a job. All right. But anyway, let's talk about values now. So a value is basically a piece of data. So it's the most fundamental unit of information that we have in programming. For example, this text, Jonas, is a value. All right, so this here is a value. And again, if we want to actually see this in the console, let's say console.log, and then open up the parentheses, and then close them here, and then the semicolons. So if I save and reload, then of course we get Jonas. Okay, and so Jonas here is the value. Or we can of course have different values. For example, here 23 is the value, right? And so now we see 23 in the console. And the same is true up here. So in this line of code, where the values are actually 40 and 8 and 23 and 10. So all these four are different values. And then these mathematical operators here join them together to form just one value. And that value is then 61. Okay? And so a value is basically the smallest unit of information that we have in JavaScript. Now, one extremely useful thing that we can do with values is to store them into variables. And so this way, we can reuse them over and over again. For example, we can say let, and then the name of the variable, and then assign a value like Jonas to this variable. Okay? And so what we did here is called declaring a variable. Okay? And so this will actually create a real variable in your computer's memory and will store this value inside of that variable. And actually, that is exactly what we did up here right in the beginning. So here we declared a variable called JS and assigned the value of amazing to that variable, right? And so now it hopefully makes sense to you what we did back then. So I like to imagine a variable like being a box. So in the real world, a box can hold some object, for example, a book, and we can then write a label on the box to describe what's in it. And then we can find the object later when we need it by using that label. And variables actually work in the exact same way. So here, basically, we have a box called first name. And into that box, we put the value of Jonas. And now if we want to use this value, all we have to do is to basically use this label, or in other words, this variable name. So first name in this case. And so let's use it actually. And for that, once again, I will use console.log. And you will see me using console.log throughout this entire course, actually. So whenever we need to output something from our code to the browser, we always use console.log like this. And so here, now, instead of passing a literal value like we did here and here and here, now we can pass in, so we can write here the variable name. So first name. Okay? And if I save it and reload it, let's see what happens. Indeed, we get Jonas. So from line number 8, and so that's right here. And that means that indeed our variable declaration up here worked. And if we now change this to Bob, let's say, then here we should get Bob, right? And indeed, now it's Bob. Let's put it back. And of course, we can now use this variable name many times. So let's just copy and paste this here a couple of times and give it a save. And so now we have it 3 times. And that means that whenever JavaScript sees this variable name here, it will basically replace it with the original value that we assigned to the variable. So again, that's Jonas. And this is extremely useful because now if I want to change the first name to something else, I only have to do it in one place. So just here. So let's change it here to Matilda. And if I save it now and reload, of course, it will change in all the 3 places. So this is one of the big advantages of variables. Without variables, I would now have to manually change the value everywhere to Matilda. But like this, everywhere where I reference this variable, it will automatically get changed to Matilda. So that's one of the most important things to keep in mind about variables. Great. And now that we know what a variable is, let's just very quickly talk about conventions and rules for naming variables, because we shouldn't just give random names to variables. So first, the way that I named this variable here is called camel case. Camel case means that whenever I have multiple words in a variable name, I write the first word with a lowercase and then all the next words with uppercase, like this. So if it was just first, we would write it like this. But if we had more than one word, like first name, person, then you see that all the subsequent words are written with this uppercase letter. And this is kind of a standard in the JavaScript world. But of course, there are other ways of naming variables. For example, we could write first name with an underscore like this. And this is very popular in other languages like Ruby. Or like this, okay? And you can use whatever you like most. Just keep in mind that it's kind of a standard in JavaScript to write variable names like this. So usually whenever you see other people's code, the variables will usually be written using the camel case notation. So that's kind of a convention of how to name variables in JavaScript, but there are also some actual hard rules in JavaScript about how we can name variables. For example, we cannot write something like this, like 3 years, and set it to the value of 3. So this is an illegal variable name, and VS Code actually warns us right away here. And again, that's because this variable name starts with a number. And if we tried to load this in JavaScript, we would get this error. So that's an invalid or unexpected token here. And it's important to actually start reading these error messages right from the beginning of the course. So we see that this is a so-called syntax error, which means that we did a mistake in writing our code. So that's a mistake in the code's syntax. And we can also see the line where the error occurred, so line 13, so that we can then go ahead and fix it. And notice how this error was shown in the console, even though we didn't use console.log in this case. Okay, so we don't need to use console.log for the console to show errors. All the errors that we make will always end up in the console, and also here with this, error icon. Now anyway, back to our naming conventions here. So we already learned that variable names cannot start with a number. And in fact, variable names can only contain numbers, letters, underscores, or the $sign. So for example, if we try to write Jonas and Matilda equals JM, we would once again get a syntax error, right? And this time it's telling us unexpected token end. And again, that's because this symbol here is illegal in variable names. They can only contain numbers, letters, underscores, or the $sign. So this here, for example, would be allowed. So if we reload now, we get no more errors here. Another error might occur when we try to name a variable using a reserved JavaScript keyword. For example, if we did this, so new, for example, set it to 27, then this would also not be allowed. So you see unexpected token new. And that's because new is a reserved keyword in JavaScript, as we will see a little bit later. And the same goes for something like function. So again, unexpected token here. If we wanted to fix that, we could, for example, start this variable name with an underscore or with the $sign. So that's the only two symbols that are allowed besides letters and numbers. Another variable name that's kind of reserved but still actually allowed to use is the word name. So we could do this, and it would actually work, but in some cases, this creates some problems. Because again, this is kind of a reserved keyword, but it's still legal to use. But since it is a keyword, never call your variables just name. Okay? That's why I always call them first name like this. Let's actually get rid of this one because we already have first name up there. Now, another convention is that we should not start a variable name with an uppercase letter. So we should not do this. So let person Jonas. Now, again, it's a convention, so that's not illegal. It's just that we use this kind of variable names with an uppercase letter for a specific use case in JavaScript, which is object-oriented programming, as we will see later in the course. So for now, never do this, but instead, you should write it like this, with a lowercase letter starting. On the same note, variables that are all in uppercase are reserved for constants that we know will never change. For example, the number pi, which is like 3.1415 and so on and so forth. So we know that this number is never going to change, and so that's a constant, and for that we have a convention of writing it in all uppercase. And VS Code actually marks this variable name with a different color, because it knows about this convention that we use. Of course, you could also write it like this, but then this would be kind of weird actually. So if it's a real constant, write it in uppercase like this. So that's a pretty normal convention there in programming as a whole. Finally, to finish this lecture, let's talk about one final convention, which is to make sure that our variable names are descriptive. And that's very important to write cleaner code. So when you name your variables, it should be really easy to understand exactly what value the variable is holding, just by reading the name of the variable. And that's kind of what we did up here by calling this one first name. But let me show you another example. For example, let's say my first job, programmer, and then my current job, teacher. So this is much, much better than writing this. So job 1, programmer, and job 2, teacher. So which set of variables do you think is more descriptive? Is it these ones or these ones? And I hope that you agree with me that it's much easier to understand what programmer and teacher are in this case here by simply looking at the variable name. So we know that my first job was programmer and that my current job is teacher. While down here, well, we would simply know that these are two different jobs. We don't know anything about them. And so this approach up here is a lot better. So keep that in mind whenever you write your own variable names. And actually keep all of this in mind that we just talked about for naming your variables. Okay? So just to quickly recap what a variable actually is, it is basically a box into which we can store a value. So we give that box a name, which in this case here is first name, or in this case here, it's my first job, for example. And then into that box with that label, we can store a value, which in this case is this programmer string here. Then later in the code, we can reference that variable over and over again. For example, like this. My first job. And if I save this, then of course, here we see programmer. Once again, you probably saw my code changing here automatically from the single quotes to double quotes, but that is just my automatic formatting doing its work. And now if we wanted to change this here, let's say coder, then it would change across the entire program, and now we get coder here. And that's what variables are all about. They're one of the most important things of programming, and so make sure to really understand them before you move on. So in the last lecture, we talked about values and variables. Now, in every programming language, values can have different types, depending on the type of data that we want them to hold. And we already saw strings and numbers, but there are actually more data types. So let's now take a look at all the types that we have in JavaScript. And first of all, in JavaScript, every value is either an object, which looks something like this, or a primitive value. So a value is only a primitive when it's not an object. And we will learn all about objects later, but for now, let's really focus on primitive data types. So there are 7 primitive data types: number, string, boolean, undefined, null, symbol, and big int. So let's look at them one by one. First, we have the number data type. And numbers are always so-called floating point numbers, which means that they always have decimals, even if we don't see them or don't define them. For example, the 23 value that we have here is exactly like having 23.0, but they are both simply the number data type. In many other programming languages, you will find different data types for integers and for decimals, but not in JavaScript. All numbers are simply of the type number. Okay? Next up, we have strings, which are simply a sequence of characters. And so they're just used for text, as we already learned. And always put them in quotes, no matter if double quotes or single quotes. Otherwise, JavaScript will actually confuse them with variable names. The Boolean data type is essentially a logical type that can only take one of the logical values true or false. In other words, a Boolean is always either true or false. Alright? We use Boolean values to take decisions with code, as we will see later. And these are the 3 most important data types that we will deal with the most. But there are still 4 more, which might be a bit more confusing. So first, undefined is the value taken by a variable that is not yet defined. And the variable that's not yet defined is simply just a variable that we declared, but without assigning a value. For example, like this children variable here. So basically, we can say that undefined means empty value. Then there's also null, which is actually pretty similar because it also means empty value, but it's used in different circumstances. But for now, don't worry about the details. I just want you to know that null also exists for now, okay? Anyway, next we have symbol, which was introduced in ES 2015. And this data type is not really useful for us. It simply defines a value that is unique and cannot be changed. And we will talk about this briefly by the end of the course. Finally, starting in ES 2020, there is also big int, which is for integers that are too large to be represented by the number type. So basically, it's another type for numbers, and we will talk about this one in another section. So these are the 7 primitive data types in JavaScript. But there is another fundamental thing to know about types, which is the fact that JavaScript has a feature called dynamic typing. This means that when you create a new variable, you do not have to manually define the data type of the value that it contains. In many other programming languages, you actually have to do that, but not in JavaScript. Instead, JavaScript automatically determines the data type of a value when it's stored into a variable. And this distinction between value and variable is pretty important, because in JavaScript, it's the value that has a type, not the variable. So variables simply store values that have a type. Many people don't know about this detail or just don't care, but this is how it actually works. Now, another important implication of dynamic typing is that later in our code, we can assign a new value with a different data type to the same variable without a problem. For example, variable x can initially be a number and then later a string. That's not a problem at all. And this can of course be very useful, but it can also be the source of some difficult to find bugs, which means errors in our code. Alright, so let's now actually see these things in action. But before we talk about data types, let's quickly talk about code commenting. So in programming, we use comments to literally comment code or to deactivate code without deleting it. For example, here, I could write a single line comment using // and then I can describe what this code is doing. For example, here I can say variable name conventions. And JavaScript will completely ignore anything that is a comment. So anything that comes after // like this. Okay? And this can be really useful to kind of divide our code into different sections and to explain what different pieces of code are actually doing in our code. So that's a very useful application of comments, but another one is to simply comment out code that we don't want to be executed for some reason. For example, let's say we don't want this code here to be executed, but we also don't want to delete it. So we can simply comment it out like this. And so if I save it, and then when I reload, this 61 should be gone. So you see, that's because JavaScript is now ignoring this code. It's just a comment. But since we didn't delete it, we can of course bring it back. So we can just delete it, and then it's back to normal. Now in VS Code, we can also automatically create comments using the command / shortcut. So that's command or control / to turn on and then again to turn off. So that's single line comments, but we can go even further and also create multi-line comments. And to do that, we do it like this. We start a multi-line comment using / and then asterisk, and then we end it with the asterisk or star and then the /. And whatever comes here is then normal code. Okay? And with this, I effectively got rid of this first code that we typed in the first lecture, but without deleting it. And so I can keep it here basically as a reference. All right? And so that's what I'm going to do in every lecture now. I will always kind of get rid of the previous code by using a multi-line comment like this. But now let's get back to the topic of this lecture, which is data types. So in the previous lecture, we already saw numbers and strings, right? So here we have a value, which is a number, and here we have a value, which is a string. So nothing new, right? That's what we learned at the beginning of the video. But we also talked about Booleans, right? And so a Boolean is a value that can only be true or false. And so if I write true, that is then automatically a Boolean value, which is in this case true. Okay? And actually I can also log that to the console. And then here you get true. And you can see that it's not a string because strings are printed in white. And this value is printed in this pink. And so it's actually really a Boolean value. And of course, we can also store Booleans in variables. So let's say JavaScript is fun using the camel case notation that we learned about before, and then set it to true. And now we can log JavaScript is fun instead. But of course, the variable declaration here needs to happen before the log. And that's because JavaScript programs are executed from top to bottom like this. And more about that a bit later. Okay? What matters is that this needs to be at the end. So let's cut it and put it here. You can also get rid of this one, save it, and here we still get true. And so here we created a nice and descriptive variable name holding a Boolean value. And remember that it's actually the value that holds the data type and not the variable, because I could now actually go ahead and change this to a value with another type. And actually I will do that in a second, but for now let's take a look at a special operator called typeOf. So typeOf is an operator just like the plus or the minus operator that we can use to show the type of a value. So let me show you how. So again, we use console.log because we actually want to see the result of this operator in the console. So typeOf, and then let's say just true. Okay? And more about how operators actually work and what they are a bit later in this section. For now, let's just see what happens when we reload this. And we see that it's a Boolean. So just as I said, the result of using this operator here on a value will be a new value, which is a string with the type of this value here. Okay, so let's do that again here. I will copy it just a couple of times, just like this, to make it a bit faster. And so here, let's use JavaScript is fun. And so this should also be a Boolean, but just to make sure. Here, let's now use a number, and finally a string. So just to prove you that these are actually numbers and strings. All right. And indeed, we see that JavaScript is fun is a Boolean, 23 is a number, and Jonas is a string. And speaking about strings, I just want to quickly emphasize that we really always need to use quotes in order to create a string. Okay, let's actually show that here in the console. So we can use double quotes or single quotes, but we really do need quotes in order to create a string. So Jonas, for example, is a string. Okay, and so is Jonas with single quotes. But if we do it like this, then it's not gonna work. So it needs to be the same at the beginning and the end. But without any quotes at all, JavaScript will see this as a variable. And so then we get this reference error, which is saying that Jonas is not defined. And that's because it's looking for a variable that does not exist. We never declared a variable called Jonas, right? And so that's why we get this error here. So when you need a string, don't forget the quotes. This is a mistake that I see beginners make all the time, and so really be careful about that. Now, moving on, let's actually see dynamic typing in action. And remember that dynamic typing simply means that we can easily change the type of a value that is held by a variable. So that sounds a bit fancy, but it's really as simple as this. So we already have a variable called JavaScript is fun. And so let's now reassign that variable. So we do that like this. So we write the name of the variable, then equal, and then a new value. And what matters is that we do not write the let here again. So this let keyword. So the first time that we declare a new variable, we need to do it using let. But then when we want to change the value of the variable, we simply write it again like this, but without the let. So we simply assign a new value here to this already existing variable. And this is actually the first time that we did that. And so it's important to understand what happened here. Okay. So again, we first declared a new variable with this name and assigned it this true value. And then down here, we changed the value that is in the variable. So using the box analogy from before, it's like initially putting a book in a box and then later taking the book out of the box and instead putting a phone in the box. And so just like here, we changed the content of the box. In our example here, we changed from true to the string of yes. Okay, and now let's just grab this piece of code here. so that we can see that dynamic typing actually works. So if I reload now, then let's see, well, we get here from line 34. Let's actually simplify this here a little bit. So commenting out this code, and I'm using command or control slash. Let's reload again. And so you see that initially the type of JavaScript is fun is a Boolean, right? But then we change it to a string down here. And so indeed, when we then test the type of the variable again in line 39, then we get the result of a string. All right? And that basically is dynamic typing. Great. And now let's see an example of undefined. So remember that number, string, and Boolean are the most used data types. But there are more, like undefined and null, and also symbol and big int. But in this lecture, I'm only going to talk about the three most important ones, and then also undefined and null. So remember that undefined is the value taken by a variable that is not yet defined. So basically, undefined means an empty value. So it's perfectly legal in JavaScript to do this. So to define a variable without a value. And if we now take a look at this variable, then we should see undefined. And actually, let's also check the type so that I can show you something. Year. Okay. And so you get both undefined. What this means is that whenever we declare an empty variable, the value of the variable will be undefined and the type of the variable is also undefined. Now that maybe sounds a bit confusing, but it's really not. So simply put, undefined is both the value and the type of the value. And undefined is different than other types in this way. But this detail is not really important. What matters is that when you declare an empty variable like this, it will automatically hold the value of undefined. And that's why we get undefined here. Then, just like before, we can also reassign this variable basically. So we can now go ahead and say year 1991. And once more, without the let, because we are not creating a new variable. We are simply assigning a new value to year. So it used to be undefined, right? As we just discussed. And now I'm changing it to 1991. And so if I test for the type now again, it should now be a number, right? So let's check that. And indeed, we can again see the effect of dynamic typing. Great. And now finally, just to quickly finish, I want to show you an error that exists in the typeof operator. So all I'm going to do here is to quickly say console.log typeof null. So remember that null is just another data type and it's similar to undefined. And it's also similar in the fact that both the value and the type of the value are null. Okay? Now about this bug, JavaScript says that the type of null is an object. And this doesn't make any sense at all. And so this is regarded as a bug or an error in JavaScript. However, this bug is never corrected for legacy reasons. But null is of course not an object. This should return null just as type of undefined returns undefined. So just keep that in mind when working with typeof, but we will also come back to this later in the course to make sure that you don't create any accidental bugs because of this weird behavior. Okay, and that's all I had to tell you about data types in JavaScript. Let's now take a look at the 3 different ways of declaring variables in JavaScript. So up until this point, we have always used the let keyword to declare variables. However, there are also const and var. Now, let and const were introduced in ES6, And so they are modern JavaScript, while the var keyword is the old way of declaring variables. So let's learn how they are different and which one to use in which situations. And let's again start by getting rid of this code. Actually, all I will do is move this to the end. And in the future, I will just do this before recording the next video. So anyway, we use the let keyword to declare variables that can change later. So basically during the execution of our program. And that's exactly what we did here. So we used let to declare JavaScript is fun, and then we changed that later from true to yes. Right? For example, or another example I would say is, let's set the age to 30 at one point of the program, and then in another point of the program, we can change it to something else. For example, when the person turns 31. And then the age, of course, changes from 30 to 31. And so it's perfectly okay to declare a variable with let at one point in the program and then later assign a new value to it. In technical terms, we call this reassigning a value to a variable, or also we say that we mutate the age variable in this case. So it was 30 and now it's 31. And so we mutated the variable. Okay, so that's a term that you will hear all the time in the JavaScript world. So when we need to mutate a variable, that's the perfect use case for using let. And that also counts for the case that we want to declare empty variables. So for example, as we did here, where we declared an empty year and then later reassigned that variable to 1991. And sometimes we actually do this in practice. For example, when we want to declare all the variables at the top of a file, but only assign actual values to them later in the program, for example, based on some condition. Now, on the other hand, we use the const keyword to declare variables that are not supposed to change at any point in the future. So the value in a const variable cannot be changed. For example, let's say the birth year, 1991, for example. If we then tried to reassign that, let's say to 1990, it should not work. So let's test that. And indeed, we get a type error. So assignment to constant variable. And so that's exactly what the const keyword does. It creates a variable that we cannot reassign, or in technical terms, an immutable variable. So a variable that cannot be mutated. Okay? And the birth year is a perfect example for that, because in fact, the birth year of a person can never change, while the age, of course, can change. And so that's why we used let for the age and const for the birth year. Okay? That makes sense? Now, the fact that variables created with const are immutable also means that we cannot declare empty const variables. For example, this is not legal. So let's comment out this one here, again with command or control slash, so that it doesn't get in our way here. And then reload. And then we get an error, missing initializer in const declaration. And so this error message means that when using const, we need basically an initial value. All right, so just like here. Now, with these two different ways of declaring variables, you will probably ask, should I use let or should I use const to declare a new variable? Well, as a best practice for writing clean code, I always recommend to use const by default and let only when you are really sure that the variable needs to change at some point in the future. For example, when you have a variable that's really never supposed to change, like this birth year, you should always use const. Also, if you are sure that the age variable is never changing inside your program, you should declare it using const as well. The reason for this is that it's a good practice to have as little variable mutations or variable changes as possible, Because changing variables introduces a potential to create bugs. So basically errors in your code. So again, by default, always just use const and let when you're sure that the value of the variable needs to change at some point in your code. And so from now on, I will probably use the const way of declaring variables as much as possible. Now, there's also a third way in JavaScript of declaring variables, which is the var keyword. But this one should actually be completely avoided, okay? However, we should still know how it works for legacy reasons, because you will see this maybe in older code bases or some older tutorials that you find online. So let's take a look at how it works. So var is basically the old way of defining variables prior to ES6. And at first sight, it works actually pretty much the same as let. So we can write var job equals programmer, and then just like with let, we can change the value of the variable later. Just like this. Let's take this one out and let's just reload. And we didn't get any errors, which means that it's basically allowed to mutate this job variable when we use var, right? Now, although it looks like var and let are very similar, below the surface they're actually pretty different. And actually there are also many differences between let, const, and var. So between all three of them. And you will learn all about these differences later in section 7, because this is actually really important stuff. And I know that I keep saying that you will learn some topics later in the course, but the truth is that learning is really not linear. It cannot happen in a linear way. So you sometimes need more advanced things right now, even without understanding them. But that's no problem, because you will understand them eventually. So right now, it would really not be useful for you to know that let is block scoped and that var is function scoped, right? Because you don't even know what a block or what a function really is. And so we will learn about these differences in section 7. For now, what matters is that you should basically never use var, okay? Now, just to finish, some people will probably point out that we actually don't even have to declare variables at all, because it's actually not mandatory. We can just write something like this. Last name equals Schmettmann, in my case. And then we can just use this variable name, in this case by logging it to the console, and JavaScript will happily execute this script even without us declaring the variable, right? We didn't use let, nor const, nor var in this case, but it still worked. However, this is actually a pretty terrible idea, because this doesn't create the variable in the current so-called scope. Instead, JavaScript will create a property on the global object. And once again, you will understand a little bit later what all of this means. But what matters is that you should always properly declare variables, okay? Never just write a variable like this without really declaring it. Great, you're doing great progress here. Even though our code doesn't really do anything yet, and we're not really writing any real applications yet, right? But we still need to get some fundamentals down before we can do that. And so that's really important. And that's why I'm stressing all the little details about everything here. And I hope you see how important that is for your progress. Okay? And don't worry, we will get to the cool stuff even a bit later in this first section. Okay? But for now, in the next video, let's talk about operators in JavaScript. Let's now learn some more JavaScript fundamentals. And in this video, in particular, let's learn about some basic operators. And let's start by defining what an operator actually is. So an operator basically allows us to transform values or combine multiple values. and really do all kind of work with values. And there are many categories of operators, like mathematical operators, comparison operators, logical operators, assignment operators, and many more. So in this video, let's look at some of these types of operators, starting with mathematical or arithmetic operators. So we already used the plus and minus operators, but of course we can do all arithmetic operations. So we can also do multiplication, division, and many more. And let's use the minus operator to calculate ages based on a person's birth year. So let's say age Jonas equals, so the current year, and I will simply assume that right now it's 2037, so that's far in the future, but let's make this a bit fun. And then minus a birth year. So let's say 1991. Okay, and then let's just quickly log it to the console. So age Jonas, using the auto completion here. And so my age is 46, at least if we are currently in 2037. Okay. Now let's do the same for someone else. So let's say age Sarah. And notice how we're using nicely descriptive variable names here. So the age of Jonas and the age of Sarah, instead of, for example, saying age 1 and age 2. So again, right now it's 2037, and then let's say Sarah was born in 2018. So let's log her age to the console as well. And we could now write this same line as this. So again, console.log, but we can actually also log multiple values at the same time. So for that, we just write a comma like this, and then the second value. And we could do even more by adding more commas. So here we could then log something else. So give it a save. And so here we see now 46 and 19 years. Great. So that's how we used the minus operator to solve a very simple problem. In this case, simply to calculate an age. However, we can actually do better here. That's because we have this value here that is repeating itself. So this year, 2037, is appearing both here and here. And so that's not good because we are repeating this value. So if the year now changes, then we would have to change it in these both places. And we don't like that. And so that's why we have the concept of variables. So instead of having this value here, let's say now, and then we assign this value to the now variable. Okay? And notice how I'm always, by default, using const. Okay? And that's because I'm not changing any of these variables here anywhere in my code. Only if I needed to change them, I would switch to let. Okay, and now here I can replace this one with now and this one. And it should work the same, and it does. Great. So that's a very good use case for a variable right there. And of course, we can use all kinds of different math operations. So let's say console.log. And now we could go ahead and do age Jonas times 2. So using this asterisk or star. Or we could also do age Jonas and divide it by 2. And notice how these are two different calculations here. So one calculation and another one, or basically another operation. And that's because, as I mentioned before, we can log different values at the same time in one console.log. So here we are creating one value, and here we are creating a second value. Let's actually divide it by 10. And then let's also use the exponentiation operator. So for example, 2 to the power of 3. Okay, and here we can use a comment to explain what this means. So that's a nice use case. So 3 means 2 to the power of 3, which is equal to 2 times 2 times 2. So 3 times this. So this should be 8, right? Let's try that. And indeed, 46, which is Jonah's age times 2, is 92. Then divided by 6 is 4.6. So that's this. And then 2 to the power of 3 is indeed 8. Nice. Next, there is another use case that we didn't use yet for the plus operator. And that's because we can use the plus operator to join strings, or in other words, to concatenate different strings. So let's create two variables. First name equals Jonas, and the last name equals Schmedman. And now I can concatenate these two strings using plus. So let's log that to the console. So first name plus last name. And let's see. And indeed, we have now one big string with both of the names together. So both of the strings that we declared earlier. But what if we wanted a space in between there? Well, that's not too hard. All we need to do is to create another string, which is just a space, and then concatenate it here with these two. And we can actually do that right here. So we want this string, first name, which is just Jonas. Remember, the JavaScript engine will simply replace this string with this one. Then we create an empty string, or actually a string with a space, and then we add that one to last name. So that's going to be Jonas plus a space plus Schmedman. Let's see. And indeed, that's exactly the result that we were after. Now there's actually a better way of doing this kind of concatenation of strings, which is called template strings. But let's focus on operators now. Okay, so this is a very useful one that we actually use quite often. So another type of operator is actually the type of operator, which we already used up here. So I'm not going to do that again. So remember, here we had the type of operator. And that would then give us the type of the value. So we already know how that one works. So let's move on to the next category, which are assignment operators. And the most straightforward assignment operator is just the equal sign. So let's say let x equal 10 plus 5. And so this equal sign here is actually itself an operator. All right. So in this line of code, we do actually have two operators. We have the plus and then the equal. Now in this case, x will be assigned 15 because the plus operator is executed before the assignment operator. Okay, and that's based on a couple of rules about operator precedence that I'm going to show you in the next video. So let me actually show that to you so that it indeed works, as I told you. And yeah, so it's 15. So 10 plus 5 is done first, and then the result of this operation, which is 15, will then be assigned to x. And so that itself is another operator. But there are more assignment operators. So let me show one to you, which is this one, x plus equal 10. So we know that at this point, after this line, x is 15, right? So let's write that as a comment. And then we have this next line. So this weird x plus equal. So what does plus equal actually mean? Well, let's write that again as a comment. So what this means is x equal x plus 10. So instead of having to write all of this, we can simply write x plus equal 10. All right, and so x should now be 25. because this x here from the previous step is 15. So here we are basically reassigning the x value. That's why I used a let here. So again, x at this point here will be 15, and then 15 plus 10 should be 25. And indeed, it's now 25. So let's write that result here so that we can keep track as I show you more operators. Because as you might imagine, there are more operators like this. For example, there is x and then times equal 4. And I hope you can imagine that this will mean x is equal x times 4. And this should be, in this case, 25 times 4, so 100. Let's check. And yes, it works. The same operator also exists with divided here, but I'm not going to go into that one. So to finish, I will just show you the x plus plus operator. And what this will do is x equals x plus 1. So let's see. And yes, we have 101. And we also have x minus minus. So if we do that twice now, what do you think will happen here? And indeed, we get 99. So minus minus is basically just the opposite of plus plus. So this one will decrease the value by 1, and so we end up with 99. Okay, so let's actually write that these are assignment operators, and these are, let's say, math operators. And so now let's talk about comparison operators. And these are pretty great. So basically we use comparison operators to produce Boolean values. So let me show you how that works, and then I'm sure it will make sense that the result of a comparison operator should be a Boolean. So let's say we are trying to figure out if H Jonas is greater than H Sarah, right? So what could the result of this be if we think about this logically? So H Jonas can either be greater than Sarah or not. And so if it is greater, then the result of this should be true. And if it's not, then it should just be false. So indeed, the result of this one is true. That's because Jonas' age is 46 and Sarah is 19. So this is basically like asking the operator, is the age of Jonas greater than the age of Sarah? And the operator will then essentially reply with yes, it is, which means true, or no, it's not, which means false. And this can be very useful later when we start taking decisions with our code based on conditions like this. Okay? Now, of course, there's also the less than, so the opposite, and also there is greater equal or less than equal. So basically we have this one, then we have this one, then we have greater equal and less than or equal. So let's see a nice application of the greater than equal operator. So let's say we wanted to test if Sarah is of full age. So that means that she must be at least 18 years old. And at least means that she is greater than 18 or exactly 18. And so we can use the appropriate operator for that. So greater or equal 18. Okay, so 18 should already be included, and that's why we have this equal here. So this should be true. And yes, it is. So if we make her 1 year younger, so let's say she was born in 2019, then her age is 18, as you see here, and she is still of full age. So it's still true here, and that's because we included 18 here in the range, basically by using this equal sign. But now if we made her born in 2020, she would be 17 And then this should turn out to be false. So let's check that. And yes, now it's false. Great. Now keep in mind that in real development, we would actually store these results here. So for example, the result of this comparison operator or this one here, we would store these results in variables and not just always log their results to the console, okay? But in this case, I just want you to show how all of this works. And so we need the console because really all we want to do is to see the results because we're still learning, okay? We could also just do all of this right here in the console immediately, but then we would kind of lose the record of what we're learning and it would be not so easy to scroll up and down, okay? But of course, we could just do this, right? We could just write age Sarah greater or equal 18 and we would still get the same result. And this works because the console actually has access to all the variables that is running in the current browser tab, right? So all the variables that we have here, like first name, for example, they are all right here. We can even auto-complete them, okay? But then again, if we would reload this page now, then all we just did would be lost. And of course, we could also simply, as I said, just store these results if we needed them later in our code. So is full age, and then we could do this. And so this variable would be the one holding the Boolean value then. And actually, as you see here in this pop-up, VS Code is so smart that it figures out automatically that this variable here is going to be a Boolean because of the code that we wrote here, which of course has a Boolean as a result. Okay, so now just to finish, let's say that we don't want the intermediate age variables and do this kind of comparison here all in one go. So this here. So let me show that to you in the code. So again, imagine we have a lot of code and we don't want to calculate these ages here separately. So we could just do now minus 1991 and then test if it's greater than now minus 2020. Or let's actually put it back to 2019 as we had before, or actually 2018, I think. So this now is basically just the same as this here. We simply are doing it now all in one step. So this code is the same as this, as it's highlighted here, and this is the same as this one. And so this whole line of code is essentially the same as doing this. Now the big question here is, how does JavaScript know if it should do the math first or if it should do the comparison first, right? Because we could think that the first thing to do is to calculate this, so basically 46, and then JavaScript could compare that 46 to now right away, right? That's what would happen if the operation would simply proceed from left to right. But we will see that it doesn't. So we will see that this actually works just fine, right? And so JavaScript has some way of knowing that it should first do this operation, then this one, so that it has the two numbers, and then only at the end, once it has the two ages, it will compare them with this operator in the middle. So how does that work? Well, that's what we're going to talk about right in the next video. In this lecture, we're going to talk about the precedence of different operators. So I already commented out the code from the last lecture, but let's actually bring some of it back here. And in particular, the calculation of these ages. So like this, and then also this code that we discussed by the end of the last video. Remember that? So the question that I asked by the end of the last video was why these two subtractions here, so this one and this one, are executed before this comparison operator. So basically the question is, why does this work? Okay, because we see that it does actually work. So this number here is clearly going to be higher than this one. Well, it works this way because JavaScript has a well-defined order of operator precedence. So basically the order in which operators are executed. And to actually see the precedence of all the different operators, let's check out a very handy precedence table. So let's Google MDN, which stands for Mozilla Developer Network, and then operator precedence. And so the one you're looking for is this one. So the one that starts with developer.mozilla.org. So MDN is a very well-known and widely used documentation site, and we will actually use MDN a lot throughout the course. And in one of the future sections, I will show you a bit better how to use this site. But for now, we're looking for a table that is here on this page, and it's this one. So here we can see that grouping using parentheses here has the highest precedence of 21, and then we have all the operators that we already saw. So here plus, minus, plus, plus, so they have a precedence of 17. Then we have a bunch of other stuff here that we don't know yet, but here is also typeof that we already do know. We have the exponentiation operator that I showed you. We have all these math operators here. We have our comparison operators, right? We have some other equality operators here and a bunch of other operators. And this is actually a nice reference where you can see all the operators that exist in JavaScript in one handy table. But let's now stay in the context of our current example, which is this one here. And let's understand what exactly happens here in terms of operator precedence. So we already know that these two calculations here are done before the comparison. And so let's actually see that in the table. So here we have the comparison. So this greater than, and you see that it has a lower precedence than the subtraction here. So this has 14 and this has 12, right? And of course, you don't need to know any of these precedence numbers. Okay, don't worry about that. It doesn't matter. No one knows these. You just have to have a general idea of which operators are executed first. So usually all the math operators are executed before the comparison operators, for example, because that makes sense. And so with this, we explain why this kind of comparison that we have here works. Now in this table, we can also see which operators are executed from left to right and which one from right to left. Like, for example, the exponentiation operator is executed from right to left, while most operators, especially the mathematical ones, are executed left to right. For example, let's say we wanted to calculate 25 minus 10 minus 5. And so this one should be 10, right? So let's check that. And indeed, we get 10. But if it was right to left, then it would be 5 minus 10 minus 25, which would then be something completely different. So this is an example of left to right operation, but assignment, for example, is a good example of right to left execution. So let's see where we actually have assignment here. So it should be one of the lowest ones, and indeed it is. So it's number 3. And so, as I said, this one is right to left. And so let me show you a nice example of why this is important. So let's declare two variables, let x and y, and here is something new. So we can define two variables at the same time, like this. So now in one line, we declared two empty values. So two values which are going to hold for now the value of undefined, right? So that's x and y. And now we can do this. We can say that x should be equal to y should be equal to 25 minus 10 minus 5, which we already know is 10. And so let's now log both of these values to the console. And what do you think will happen? You can really try to think about this before checking the result. And so what is it going to be? And actually, let's delete this one first. So to avoid some confusion there. And so we see that x and y are both 10. And so let's analyze why that happens. So when JavaScript first finds this line of code here to execute, it will look at all the operators that are present, and it will see the minus operators. And so it will start with these because they have a higher precedence. Right? So assignment has only 3, but where is it? Here it is. So the subtraction has a 14. And so of course it's going to be executed first and left to right. And so as we already know, this here will turn out to be 10. And so let's just write that here. So after these minus operations, we end up with this code basically. So x equals y equals 10, right? Because again, 10 is the result of doing these operations. And so now we only have 2 operators left, which are the equal operators. And so now they are executed. But as I showed you before, they are executed right to left. So from this side here, starting from the 10 to this side. And so what happens is that we will have y equals 10. And so at this point, y is equal to 10. And so what we have then is x equal to 10. Okay? And then after that, we're only left with x equal 10. And so at the end, both x and y are gonna be 10. Okay, maybe that sounded a bit confusing, but that's just how it works when you evaluate from right to left. And actually, that's the way it has to be, because if it was the other way around, this wouldn't work. Just imagine if we had this assignment working from left to right. Then x would be equal to y. And y is undefined at this point, remember? Because we declared it here as an empty variable. And so again, if assignment would be from left to right, then first x would be equal to y, which would be undefined, and then y would be equal to 10. And so that's not the result that we expect here. And so once more, the way this works is actually very logical and makes a lot of sense. So I hope that made sense. And now to finish, let's just check out the one with the highest precedence, which is this grouping. So basically using parentheses. And that actually works just like in mathematics, where operations within parentheses are also executed first. So I hope you remember that from school. And a great example is to calculate the average of 2 values. So we have age Jonas and age Sarah. And so let's calculate the average age of these 2 people. So let's actually start by logging their ages to the console, just so we see. So age Jonas and age Sarah. And now I want to calculate the average. And actually, let's do that here above that. So let's say average age. And once more, don't forget the descriptive variable names. So average age describes exactly what this variable is going to hold. So to calculate an average, we need to add 2 values together and then divide them by 2. At least that's when we have just 2 values. So let's say age Jonas plus age Sarah. So that's the addition, and then divided by 2. But now what is going to happen? Well, according to our precedence table, we have the division here happening before the subtraction. So this is 15 and this is a 14. And so what happens first is age Sarah is going to be divided by 2, and then the age of Jonas is going to be added. So let's actually log that result here as well. And so here the average age is now 55.5, which really doesn't make any sense, because how can the average be larger than one of the 2 ages, right? And so that's where the parentheses come in. So by using parentheses, once more, just like in mathematics, we can make it so that this operation here is executed first. Okay, so basically everything that is within the parentheses which have the precedence of 21, right? So now this one is executed first and then the division. And so, yeah, now it makes sense. Okay, I hope that wasn't too confusing. And now you're actually ready for your first coding challenge. So I hope to see you soon in the next video for your first challenge. All right, I hope you managed to complete all the 3 points of this challenge. And so here is how I would have implemented it. So I'm starting with number 1, of course. And so let's say const mass mark equals 78. Okay, so that's just what is written here. And then height mark equals 169. And then the same for John. So mass John equals 92. And then height John equals 195. All right. And if you used different variable names, that's not a problem at all. As long as they are nicely descriptive, like these ones here, you're going to be fine. Also, you might have used let here instead of const, because you might assume that these are values that are susceptible to change, especially here the mass, right? However, I still decided to use const because I already know that I'm not going to change these values here throughout the program. And so just as we learned before, I prefer to always use const by default. And I advise you to actually do the same. Okay? Anyway, let's now calculate the actual BMIs. So const BMI mark equals mass mark divided, and let's check out the formula again, divided by the height squared. So that's going to be height mark squared. And then the BMI John, so that's mass John. And this time let's actually use the other formula. So this one here. So we're going to use height John times height John again. Okay, and now let's log both of them to the console here. So BMI mark and BMI John. And now we have an error here. Oh, of course, I missed the .log. Okay, try it again. And here we go. So we see that BMI mark is higher than John's BMI. Okay, so I hope you got the same numbers here than I did. And if not, I guess you should probably check your code, unless I have some mistake here. Let me check that actually. But I think everything is good. Okay, so if something is wrong, then please just let me know. All right. Now, if you implemented this in a different way, for example, you might not have created these separate variables here, then that's not a problem at all. Okay, you could have logged these calculations straight to the console. No problem at all. Again, what matters here is that you make this work and that in the end you get these same results here. Anyway, let's now also do step 3 and create a variable called mark higher BMI. So let's just grab this here and const. And so what we're trying to figure out is if the BMI of Mark is higher than the BMI of John, right? And so that's what comparison operators are for. Because remember that this one here will return either true or false. In our example, if BMI Mark is larger than the one of John, then the result of this whole operator here will be true. And otherwise, it's going to be false. Okay? So that's exactly what we did before in this example with the ages, if I remember correctly. So where's that? Ah, yeah, it's right here. In this case, it was the isFullAge variable, right? Okay. Anyway, let's log it here to the console as well. And so we expect this one to be true, right? Because Mark's BMI is 27 and John's is 24. And so Mark's is larger, and so the result of this should be true. So let's check that. And indeed, we get true. Nice. So we basically solved it. Now I just want to do the same here for test data too. So I will just copy this. So copy, and then I will simply comment out these first ones. So now I'm replacing these with 95, 188. And then here for John, we have 85 and 176. And the rest, of course, is the same. And that's the beauty of using variables, because now all we have to do is to change these values in one place, and then the changes will be propagated to the rest of the code here, which references these variables. Cool. So let's reload. And now BMI of John is 27, so it's larger than 26.8. It's actually very close, but still, BMI Mark is now lower than BMI John. So here we ask the question, basically, is BMI Mark larger than BMI John? And in this case, it's not, so it's false. And so that's exactly the result that we get here. All right, so this one is solved, and I hope you solved it as well. Again, it does not matter at all if you did it in a different way, as long as the results were the same. So basically, as long as you actually made it work. So hopefully that was a lot of fun and you could practice your skills a little bit, which is really something essential to learn programming properly. Without repetition and reinforcing your knowledge, it's impossible really to learn how to code. Anyway, see you now in the next video, where we're going to continue learning the fundamentals of the beautiful JavaScript language. Strings are a very important part of programming. And so let's now learn about an easy way to build strings using something called template literals. And let's start by creating some new variables here about a person, and in this case, about me, so that we can then concatenate them into one big string. And the birth year. Okay, and so let's now use these variables to build a string, something like, I'm Jonas, a 40 or 30-year-old teacher. So we're gonna then use this birth year to calculate the age, of course. So let's call that one simply Jonas. And as we already learned in one of the previous lectures, we can use the plus sign to concatenate strings. And so let's now start by doing that. So I want to write I'm, and here I'm seeing a problem. So when I want to use this single quote here for writing something like I'm or isn't, so basically when I need this symbol here, then I need to write the string itself using double quotes, okay? Because otherwise the single quote that I'm using here for I'm will finish the string. So I'm, and then I need a space, then the plus, and so here I'm saying I'm Jonas, and now I can actually use the single quotes. So what matters is that in each string, we start and finish with the same symbol, right? But both just create strings the same way. So right now we have I'm Jonas, comma, A, and now we want the age. So let's say a 30-year-old teacher. So we need another space here. And then let's actually calculate the age. So that's the current year. So let's put that here as well. And let's again say that the year is 2037. So plus year minus the birth year. Now, in order to make this work, we actually need to put this operation between parentheses. Like this. And so it will do the calculation first and then the concatenation. But you might be wondering, well, the result of this is going to be a number, right? But the rest of the things that we're adding here are strings. So how is this going to work? Well, this has to do with something called type coercion, which is something that we're going to talk about a little bit later in this section. But basically, JavaScript will simply convert this number to a string so that it can concatenate them, so that it can join them with the rest of the strings. So you will see that it's going to work just fine. Okay, years old. And then the job. And then we can finish with an exclamation mark or something like that. All right. And then let's also log this to the console so we can take a look at it. Okay. So I'm Jonas, a 46 years old teacher, and we're missing some spaces here. So that's around the years old. And you see that this is kind of a pain to manage these spaces and well, to keep track kind of how the sentence is structured. And so we will see a great solution to that in a second. So now it works, and yeah, just as expected. So as I was saying, for a complex string like this one, this can be kind of a pain. And so that's why, starting with ES6, we have a much better tool for doing this kind of stuff now, which is called template literals. So with template literals, we can write a string in a more normal way and then basically insert the variables directly into the string, and then they will simply be replaced. So basically, a template literal can assemble multiple pieces into one final string. So let me show you how that works. So let's call this one Jonas new. And now to write a template literal, we need to use backticks. So that's this symbol here. And on the English keyboard, you will find this one above the tab key. So again, we really need to use these backticks to tell JavaScript that we're writing a template string. The single quotes or the double quotes won't work for what we're going to do now. So now, as I said, we simply write a string and insert the variables in there. So I'm, and then we use the $, curly braces, and then the variable name. So I'm first name. And just to see if this actually works, let's log it to a console. So that's Jonas new. And indeed, I am Jonas. So you see that this is much easier because all we have is this one string, and then here we used this syntax to insert the first name variable. And now we can continue this, and it's going to be a lot easier. A, and then again a variable. Now in this case, we actually need a calculation, and that's no problem at all. We can basically write any JavaScript here inside of these curly braces. All right. Technically, we can write any expressions, but more about expressions in one of the later lectures. So year minus birth year, just as we did above. Year old, and then teacher. So no plus signs, no thinking where we should put the spaces like we did here. And so this is a lot easier. Let's reload. Oh, and indeed, there is a bug here. So of course, that's not teacher. That's actually the value of the variable job that we're interested in here. But once again, we found this bug because we simply read the error message. So get into this habit of always reading the error message to try to figure out where you are wrong. All right. And now, of course, it works. And I hope that you can see that this is a way easier way of writing this string. This really kind of assembles the string using the pieces that we give it. For example, this variable here, or this value that is produced by the minus operator. Great. So now you know how template strings work in JavaScript, and in particular in ES6. And actually, it's one of the most used ES6 features. It's really amazing and really useful in many situations. Now, I just wanted to let you know that we can actually also use backticks to write all strings. So strings where we do not insert any of these kind of placeholders here, like this. So let me just demonstrate that to you. So we can use backticks for any regular string. So you see that it works here just the same. And many developers actually started using backticks for all strings, because then you don't have to think about which quotation marks you should use. You just use backticks always. And then in case you need to insert a variable, then it's much easier than to go back and switch out the regular quotes. So that's a choice that you can make. I actually don't do that myself, but I can see that it actually makes sense. All right. Now, another great use case of template literals is to create multi-line strings. So that's something that before template strings was a bit cumbersome to write. So let me just show that to you. So if you wanted a multi-line string before ES6, you would have to write string with, and then you needed this \n, which in many programming languages means new line. All right. So basically this is like a special character in programming, which in strings always means that a new line should be created. And then in JavaScript, we would need another \, like this, and then we could move to the next line and continue here. Multiple, let's create a new one, and then lines. And this actually only works because of a bug that's in the language. But let's see. So we get string with multiple lines. And you see that it's all the same string, but yeah, spread across multiple lines. But indeed, now with template strings, there is an easier way of doing this. So all we have to do is simply hit return, and it will create a new line for us. And this is actually going to be immensely useful later when we start building HTML from JavaScript. So by then, we will be able to use these backticks to create multi-line HTML elements to insert them onto a page dynamically. So that's going to be a lot of fun. Let's just see if this works. And indeed, it does. So whenever you need a multi-line string, you always make sure to use this template literal, because it's a lot cleaner. All right, and that's actually it about template literals. In the next lecture, we will finally start to make our code a lot more fun and take it to the next level by taking decisions. Welcome back. Let's now make coding even more fun and actually take decisions with our code to make it look a lot more real. So let's say that we want to write a program which checks whether a person is allowed to start taking a driver's license or not. And if she is, then it will print that to the console, and if not, it will print how many years are left until the person can start taking the driver's license. So let's start with an age, and let's set it to 19. So we have this age, and we already know how to check if this age is at least 18. Which is the legal required age to start a driving license, at least here in Europe. So let's actually create a variable with that. And I think we actually already did that. Let's call this one is old enough. So again, with a variable name that describes exactly what we want here. So remember, to check if the age is at least 18, we need it to be greater or equal than 18. And so this will then include 18. So if the age is 18, the result of this operator here, or of this operation, will then be true. Only if the age is 17 or 16 or anything below, it will turn out to be false. Okay, so we have a Boolean value now, and we can use this to take decisions using an if statement. And the if statement works like this. All we have to do is write if, then open parentheses, and then in here goes a condition that is evaluated. And if this condition turns out to be true, then this block will be executed. So basically whatever code that we write into this block, which is denoted by these curly braces, will be executed whenever the condition that's here is true. So in this case, let's put the condition, and with condition I basically mean something that is a Boolean value. So let's use our isOldEnough variable here, because we already know that this will always be a Boolean. So again, whenever this value here is true, then the code that's in this block here will be executed. And if it's false, well, then it's not going to be executed. So let's log to the console. Sarah can start driving license. And let's just add a fun emoji here. And on the Mac, that's Command Control Space, and on Windows 10, the shortcut is Windows plus the period sign. But adding the emoji here is also not really important. So let's give it a save and try this out now. And indeed, we get Sarah can start her driving license. And that's because the age is 19, and so it's above 18. So this is true. And so if isOldEnough is true, then this block of code here will be executed, which in this case is just one line, but it could of course be multiple lines. So now let's put it to something else. So 15. And so now this is false. And so then this code block here should not be executed. So give it a save. Let's try. And indeed, we get no output this time. And so that means that it worked. So let's put it back to 19. And in practice, we always write this condition directly here. So let's do that. So what we want is just this part. So let's get rid of this. And so this is a lot more common. Let's actually get rid of this. And so we basically do this operation here. This will then return true or false. And depending on that, this code block will then be executed. And actually, let's put it back to 15, because now we can do something else, which is to actually add an else block. And we do that simply by writing else right after this first if block, and then we add another block. So what do you think this else block is for? Well, this else block will basically be executed whenever this condition here is false. So right now the age is below 18, and so this is false, and so as we already know, this block here will not be executed. Instead, the else block will be executed. So whatever code we have here. So let's write some code in here. And as I said in the beginning, we will calculate how many years are left for Sarah to start taking her license. So let's calculate that. Years left. And so that's simply 18 minus the age, right? And then we can log a nice string to the console which contains this variable. And as we learned in the last lecture, the best way of doing that is to use a template literal. So backticks, and then we say Sarah is too young. Wait another, and then we insert or placeholder here, basically. So years left, and then years. Okay. So the result of this should be 18 minus 15, which is 3. And so we should see wait another 3 years. So let's check that. And indeed, that's exactly what we got. And so again, since this condition here, so this operation basically turned out to be false, then this block of code was executed. Great. Just keep in mind that this else block is actually optional, right? So in the beginning, we didn't have this else block and it still did work. So when there is no else block, JavaScript will then simply move on to the next line after the if statement in case that the condition is false. Great. Now you know what an if-else statement is and how it works. And this is actually one of the most important things in programming. We take decisions with code all the time, which is essentially what we did here, so that we can execute certain parts of our program based on certain conditions. Okay? Now what we have here, this if-else statement, which is the official name of this kind of construction here, is called a control structure. So basically this structure here is called an if-else control structure. And it is called a control structure because this structure actually allows us to have more control over the way that our code is executed. For example, in this if-else statement, the whole code does not just execute in a linear way. So JavaScript does not execute all of this code here linearly. Instead, we can now control blocks of code that should execute and blocks that should not execute. And so again, that gives us a lot more control over how our code works, and that's why this is called a control structure. Okay, and there are other control structures that we're going to go into a bit later. All right, so I hope that you can see how this really takes our code to the next level. Now, just to make sure that you really understood this concept, let's create another very small and simple example here. And this time, let's actually create a variable conditionally and not just always use console.log. So let's create a birth year variable. I think we don't have it in this lecture yet. That's right. And so now what we want to do is to create a variable called century, which will basically contain the century in which this person was born. So in this case, it was the 20th century. But for example, if the person was born in let's say 2015, then it would be the 21st century. So to do that, we can of course write an if-else statement. So we can say if the birth year is below or equal to 2000, then let century equal 20. And so that then means the 20th century. And if not, then let century be 21. So we're assuming that the person is not born in the 19th century. So we're not accounting for something like this, for example. So instead, we always have the 20th or the 21st century. Now, to actually make this work, we need to define the century variable outside of the if or else blocks. We will go deeply into why that is, but for now, what you need to know is that this is because a variable that we define inside of any code block, which is what this here is. So this is a code block, and this is a code block. And any variable that we declare inside of one of these blocks will not be accessible outside of the block. So let me just show that to you very quickly. So if I try to read century now, then I will get an error here. You see, century is not defined. And so what we need to do is to define century outside and simply leave it empty. And then in here, we can then conditionally reassign it. Okay? And so now let's see how this works. And indeed, now we get the century 20. So 1998 is below 2000, and so this person was born in the 20th century. Now let's say 2012, And so that should now be 21st century. And indeed, that's exactly the result. So I hope that this example 2 made sense to you. Now, don't worry about the fact that we had to declare the century variable outside of the blocks. What matters here is that you understand the logic of the if-else statement. Okay? And I hope that was clear enough. But anyway, let's quickly recap. We can take decisions using code using the if-else statement. And for that, we write if, and then we open up parentheses, and in there we need a condition. And a condition is essentially any code that returns a true or a false value. And so this is a perfect example of that, because this operator here will return true or false, right? And so we can use this operator to create a condition, essentially. Then, if the condition is true, this block will be executed. So all the code that is in there, no matter how many lines of code there are. Now, if the condition turns out to be false, then this else block will be executed instead. So JavaScript will then skip this first block and go to the second block, which is this one. But the else block is actually optional. So if you don't have the else block, then simply no code will be executed. And this, in a nutshell, is how the if-else statement works. And remember that this is really powerful. So make sure that you really understand how this works. And when you do understand, then you can move on to the next video where there is a small challenge waiting for you. Again, I hope that you managed to do this. So let me show you how I did it. So let's start by getting this code from the other challenge. So coding challenge number 1, because of course we don't have to repeat the same code. So here we have the mass and the height of both John and Mark, and we already have their BMIs calculated. We also have this condition here basically already. So this operation here already tells us whether Mark has a higher BMI or not, right? So let's get rid of this. And so let's write or if else statement. So if BMI Mark is greater than BMI John, and here we could have just used this variable, right? So we could have written Mark higher BMI right here. But as I said in the previous lecture, it's actually more common to write the condition directly in here. So let's get rid of this variable here. And then let's come here and get this string that we want to then log to the console. So console.log. And so this makes sense, right? So if BMI Mark is greater than BMI John, then we log to the console, Mark's BMI is higher than John's. And if not, then we use the else statement. So let's copy this one here. So in this case, John's BMI is higher than Mark's. And actually, let's log both of them to the console here first, just so we see if our if-else statement is working as expected. So BMI Mark and BMI John. And as you see here, the VS Code auto-completion is pretty smart. Give it a save. Let's try that. And we see John's BMI is higher than Mark's. So this one is Mark's, this one is John's, and indeed, John's BMI is higher. And so basically, this condition here turned out to be false, and the else block was executed. So let's try the same now with this first set of data here. And I'm commenting them out again using command/ or control/ on Windows. So I need to comment out this one. Okay, give it a save. And now we should see the opposite. And indeed, now Mark's BMI is higher than John's. So that is part 1, right? And now part 2 is to actually write a template string, or this should be called a template literal. We just fixed that. So we should use a template literal to include the actual BMI values. So like this here between parentheses. So let's do that. And so we're going to transform this to backticks. So that's the first thing. And then let's see the template again. Okay, so after the BMI, we include the parentheses. And then in the parentheses is where we want the actual value. And so this is where we put essentially the placeholder. So here we will put BMI mark. And here BMI John. Right, and now let's just copy this to make it a bit faster. Mark, and then here John. Okay, let's see. And yeah, that works just fine. Cool. So with this, we solved the challenge. And again, if you did it in a slightly different way, don't worry at all. That's completely normal, and it's actually a good thing. It means that you're basically finding your own style of coding, which is really a good thing. So don't worry about that. What matters is that you actually used an if-else statement. That was, of course, mandatory. Otherwise, you couldn't have make this work at all. All right, so this was a lot of fun because we actually made our code do something now. I hope you can really feel that as well. In this video, we need to go back to value types. So types are one of the fundamental aspects in programming, and converting between types is something that we do in every programming language. For example, converting a string to a number or a number into a Boolean is something that we do all the time. And so it's important that we learn about this before being able to move on further in the course. That's especially true for a language like JavaScript, which sometimes behaves in a weird way, as we will see in this video. Now, in JavaScript, there is type conversion and type coercion. So they sound very similar, but are different. So type conversion is when we manually convert from one type to another. On the other hand, type coercion is when JavaScript automatically converts types behind the scenes for us. So that's necessary in some situation, but it happens implicitly, completely hidden from us. Okay, so let's start with type conversion, which, remember, is when we explicitly want to convert from one type to another. So let's say that we have an input field on a web page for the user to input their birth year. And these inputs from input fields usually come as strings. So let's say that the input year that we get from the user interface is a string with the value 1991. But now, if we want to do some calculations with this, this won't really work. So let me show that to you. So console.log, let's say input year, and now plus 18. And so like this, we can calculate in what year the person will become of full age. Now, remember that when we have a string and add something to the string, it will basically concatenate the strings. So we can't expect that this actually adds 18 to this number here, because it's a string. So let me show you what I mean with that. And so indeed, we now get a string, which basically contains the 1991 string and then the 18 as well. Okay, so we need a way of fixing this, which means that we need a way of converting this string to a number. So let me actually log that here first. So console.log. And then the way we convert this string to a number is by using the built-in number function. So we write number, then parentheses, and then input year. And we will learn exactly what a function is and why it works this way in the next section. For now, just know that we can basically convert strings to numbers by using this function, which we execute using these parentheses here. So we have these parentheses inside these parentheses now, but don't get confused by that. So doing this operation here will then return the string as a number. So let me show that to you. And so indeed, now we get 1991 here in this pink color, basically. And the colors might change throughout the time. By the time I record this video, numbers are pink and strings are just this white. Let me actually print them both. And so that should make it really visible that, yeah, the first one is a number, the second one is a string. Okay. But now one thing that's really important to note here is that the original value is actually not converted. So the input year variable itself, so this one is still a string, right? It still holds the variable 1991 as a string and not as a number. That's why down here in this log, where we do this calculation, the result is still this string. Because again, the original input year variable is still a string. Using this number function will simply give to us a converted version. So if we want to perform this calculation, we need to use number here as well. And so this will now convert the number, and then to that number, the 18 will be added. And so now we should end up with something like 2009, I guess. And indeed, that's right. But now, what if we're trying to convert something to a number that is impossible to convert? Let's try that with a string that doesn't really contain a number. So let's try to console log converting to a number the string Jonas. So JavaScript will look at the string, will try to convert it to a number, but it won't really work. So what do we get instead? We get this nan, which stands for not a number. So JavaScript gives us this not a number value whenever an operation that involves numbers fails to produce a new number. So basically not a number actually means invalid number. It's not really not a number. And let me actually prove that to you. So we can check the type of NaN, so not a number. And as we will see, the weird result of this is that the type of not a number is actually number. And so again, not a number actually means an invalid number. It's still a number somehow, but it's an invalid one. And so again, we get not a number whenever an operation involving numbers fails to give us a new number. Okay, so that is converting strings to numbers, but of course we can also do the opposite. It's a little bit less important, I would say, but I still want to show it to you. So to do it the other way around, we use this string function, and that's quite straightforward, right? Just keep in mind that we need to really start it with a capital S, just like here the number function needs to start with a capital N. Otherwise, it's not going to work. So we get 23. And remember that whenever the value here is white, then it means it is a string. So it looks kind of the same. Let's again log both just to make this point. So the pink one is the value that actually has the number type, and this one has the string type. Okay, so again, this one is not as important, but I still wanted to mention it. Now, JavaScript can only convert to 3 types. So we can convert to a number, to a string, or to a Boolean. But we cannot, for example, convert something to undefined or to null. That doesn't make a lot of sense. Now here we only converted to numbers and to strings, but not to Booleans. And that's because Booleans behave in a special way. And for that reason, there is a separate lecture coming up on so-called truthy and falsy values. Great, so that is type conversion, where we do manually convert from one type to another. However, in practice, we rarely have to do it manually, because JavaScript actually does type coercion automatically for us in many situations. So let's talk about that now. And let's just separate this here with some comments. So type conversion, and then type coercion. So basically, type coercion happens whenever an operator is dealing with two values that have different types. So in that case, JavaScript will then, behind the scenes, convert one of the values to match the other value, so that in the end, the operation can be executed. And actually, we already saw that happening, if you think about this. So let me show that to you. Starting with strings, remember how we did this. I am, and then a number, let's say 23, and then another plus years old. So we already know that this is going to produce a string that says I am 23 years old. But how does that actually work? Because 23 is a number, so we have different types here, right? We have a string, a number, and another string. So let's check, and indeed that is what happens. And it works this way because of type coercion. So in JavaScript, the plus operator that we used here triggers a coercion to strings. And so whenever there is an operation between a string and a number, the number will be converted to a string. So thanks to type coercion, writing this would be exactly the same as writing this. Right? Because again, the plus operator will convert numbers to strings. And the same actually happens in template literals. It also takes all the number values and also converts them to strings. Now, if JavaScript did not have automatic type coercion, like many other languages don't, then we would have to manually do this like we just learned before. Then we would have to do string 23, and then this would be the only way that this would work. But luckily for us, JavaScript has type coercion, and so this will happen completely automatically behind the scenes. Now, actually, not all the operators do type coercion to string. So let me show you something else. So if we do 23 the string minus 10 the string minus 3, what do you think will happen now? So let's actually check, and it gives us 10. So what happened here? It looks like this time JavaScript converted the strings to numbers. And indeed, that's why we get 10, because 23 minus 10 is 13, minus 3 is 10. And so what this means is that the minus operator actually triggers the opposite conversion. So in this case, strings are converted to numbers and not the other way around. So instead, if we use the plus, what do you think is going to happen? Then the 3 is converted to a string, and then the 3 strings are concatenated. Okay, so this is a very important distinction to keep in mind, because this actually confuses many JavaScript beginners when they don't know about this. So let's try another one here, and I'm again using 23 the string times 2 the string. And again, you will see that these values are going to be converted to numbers before. And indeed, that's why we get 46, because both of them are now converted to numbers, because that's the only way that the multiplier operator can work. And the same, of course, is true for dividing. Okay, so I hope that the distinction between type conversion and type coercion is now pretty clear. And now just to make sure that you actually got it, let's play a game called Guess the Output. So that's a game I just made up. So I want you to guess what happens here. So I'll write 1 plus 1 like this. And then we say n equals n minus 1 again. So what do you think n will look like when we log it to the console? So essentially we start with 1 the string, then we add 1, and then we subtract 1. So take a moment to think what this should look like, and then let's take a look at the solution. And it is 10. So that's a bit counterintuitive, but according to the rules that we just learned before, it actually makes sense. So here in the first line, 1 plus 1 will actually turn out to be 11 the string, because we have one string here, and then the plus operator will automatically convert the number to a string. And so the result of this one is the string 11. But then here we have the minus operator. And in the minus operator, whenever we have a string or more strings, it will then convert it to a number. And so here, the string 11 will be converted to 11 the number, and then 11 minus 1 is of course 10. Okay, let's do one or two more, and let's do it in the console here. And we can actually clear the console of all this clutter here by clicking on Clear Console. Okay, so let's do 2 plus 3 plus 4 plus 5 the string. And now you actually can't really guess because we can already see the solution there. Okay, so let's try to understand what happened here. So we start here with 2 plus 3, which makes 5. Then 5 plus 4 makes 9. And then we end up with 9 plus 5 the string. And then, as you already know, since we have a string, the plus operator will convert the other operand, which is 9, also to a string. And then we end up with 9, 5 as a string. Okay, and another one. 10 minus 4 minus 3. And keep in mind that these are strings. And then minus the real number 2. But then plus 5 the string. So again, this looks very weird, but the logic is kind of the same as before. So we have two values that are subtracted, and so JavaScript will convert them both to numbers. And so the result of this is 6. Then 6 minus 3 is 3. Then 3 minus 2 is 1. And then we end up with the same situation as before. So this 1 will be converted to a string, and then we end up with the string 15. Okay, and with that, I think this should be pretty clear now. And you might be wondering why we're talking so much about this, but it's really important that you know about this right from the start so that you can write your code with all of this in mind. Now, many people actually don't like type coercion and think that it's a bad practice to rely on type coercion. One reason for that is that type coercion can, in fact, introduce many unexpected bugs into our program. However, this only happens when we don't really know what we're doing. So when we don't know about the stuff that I just showed you. Because if you know, then it's way easier to avoid these errors. So in my opinion, coercion is actually a great mechanism that is going to allow us to write a lot less code and also to write more readable code. So really make sure to take some time to understand how type coercion works and then just embrace it in your code. So we talked about type conversion and coercion to numbers and to strings. But I didn't mention booleans yet, right? That's because we need to learn the concept of truthy and falsy values first. And so that's what we're going to do now. So let's get right into it. So falsy values are values that are not exactly false, but will become false when we try to convert them into a boolean. And in JavaScript, there are only 5 falsy values. And let me actually write them down here for you. So 5 falsy values. And they are 0, the empty string, undefined, null, and not a number. And that's it. Of course, false itself is already false. So we don't need to include it in the list of falsy values. So again, all of these 5 values will be converted to false when we attempt to convert them to a boolean. They're not exactly false initially, but they will become when converted to a Boolean. So that's the definition of falsy values. Everything else are so-called truthy values, so values that will be converted to true. For example, any number that is not 0 or any string that is not an empty string will be converted to true when we attempt to convert them to a Boolean. And so let's actually see that in practice. So just like with numbers and strings, we can use the Boolean function, Boolean, and then 0. And we know that this one is a falsy value, right? So let's copy this and do this a couple times for some different things. Let's do the same with undefined. Let's do it now with a string. And it's not an empty string. And now let's also do this with this empty object. And we will learn about objects in our next section. So this here is simply an empty object. So let's see what the result of this is going to be. And we see that indeed converting the 0 here to a Boolean resulted in false. And the same for undefined. It's also false. But then the string Jonas is true. And so that's why we say that any string that is not an empty string is a truthy value. And the same actually applies to this empty object here. It's also a truthy value. But if we tried to convert an empty string, well, I think then you can already know what the result will be. And it's going to be false. Again, because it's a falsy value, as we see up here in this list. So that's what truthy and falsy values are. And this is how we could convert them to Booleans. But in practice, I actually never did this in my life. I never used this function here in practice. This was just to show you the concept of truthy and falsy values. So in practice, the conversion to Boolean is always implicit, not explicit. Or in other words, is always type coercion that JavaScript does automatically behind the scenes. But when exactly does JavaScript do type coercion to Booleans? Well, it happens in two scenarios. First, when using logical operators, and second, in a logical context, like for example in the condition of an if-else statement. And we're going to talk about logical operators in a future lecture, so let's now go back to the if-else statement and see how type coercion works in the if-else condition. So, let's say that we have a money variable. And in the beginning, we don't have any money, so we set it to 0 here. And now we can use what we just learned to test if the person has currently any money or not, right? So let me actually write it first, and then I'm going to explain to you how it works. So if money, then let's log to the console something like don't spend it all. And notice how I used the double quotes because in here I have a single quote for the don't. And then we can also do an else block. So for the case that the person does not have any money, then I can just say you should get a job. Okay, so let's see if this works, and then I'm going to explain to you why it works. So indeed, we got the you should get a job, and so that's the else part here, right? So this here is the code that got executed. But why? Well, we know that money is a number right now, and this number is 0. But in the logical context of an if-else statement condition, so that's right here in these parentheses, here JavaScript will try to coerce any value into a Boolean. So no matter what we put here, if it's not a Boolean, JavaScript will try to convert it to a Boolean. And that happens using the truthy and falsy value rules that we just discussed in the beginning. So we know that money here is 0, but 0 is a falsy value, right? And so in this logical environment here, in this condition, this number 0 will be converted to false, just like it happened here when we converted manually the 0 to a Boolean, right? So here this conversion to Boolean returned false. And here the exact same thing happens. Money is 0, and so 0 is converted to false because it's a falsy value. And as a result, the else block here is executed, and so on the console we see you should get a job. Now if we change this to something else, and it doesn't matter what number, let's say 100, then 100 is a truthy value. And so this means that this condition will be true. And so the if block will be executed. Wanna see? Yes, indeed. Now it says don't spend it all. Great, I hope that made sense. And we can test this in another situation to make really sure that you understand it. So another use case for these truthy and falsy values is to check if a variable is actually defined or not. And this might seem like a weird use case, but you will see later in the course that it actually makes a lot of sense sometimes to test if something actually exists or not. So let's define a variable here as height, and then we can simply do this. If height, then let's run this code. Yay, height is defined. But if not, well, then just say height is undefined. Okay, so let's see the result, and again I will explain you why it works this way. And maybe you can already guess why it works this way. So can you try to explain it to yourself maybe? That would be a good idea to make sure you actually got the concept. But anyway, we know that height is undefined in this moment, right? Because we didn't assign it any value yet. And we know from our little list here that undefined is a falsy value. And therefore, just like before in the money here, this height variable here in this logical context will automatically be converted to a Boolean. And since height is undefined and undefined is a falsy value, height right here will be false. Therefore, this block here will be executed. But now if we assign something to it, no matter what it is, then we will get the other result. So now it's true, and so now this block here is executed. However, with this, we can actually run into a problem. So let's say that the height is 0 for some reason. And that's a perfectly valid number. But watch what happens when we run this code. Now we get again, height is undefined. So, why is that? And I hope you know the answer by now. Well, it's because 0 is also a falsy value. And so this one will also trigger this else block. But in this case, that's actually not what we want. So this is kind of a bug. It's an error in our application. Because here in this if-else statement, we didn't account for this scenario. We only accounted for the scenario that the height is either defined or not. But we didn't think of the height being 0, right? And so right now we get height is undefined, even though that's not true. So this is just to illustrate an example that there can be problems using this approach. However, we can fix this using logical operators, which is going to be very interesting, and we will talk about that a little bit later in this section. But first, in the next lecture, we need to talk about equality operators. So stay tuned for that. So far, we have only used comparison operators to take decisions with if-else statements, right? But let's suppose we want to check if two values are actually equal, instead of one being greater or less than the other. And for that, we have different equality operators. So let's start again with an age variable and set it equal to 18. And I'm using age all the time because it's so easy to make simple calculations with it. So let's now create an if statement which will log to the console that the person just became an adult only if the age is exactly 18. So we can use an if statement, as we already know. And now to check if the age is exactly 18, we use the triple equal. Okay, and that's it. Let's now write the block of this if statement and then execute it, and then I will explain what happened here a little bit better. Now, whenever our if block only has one line, we actually don't need the curly braces. Okay, so we don't need to create this block if we only have one line. So we can omit this and only write this one line of code. In this case, you just became an adult. So let's test this. And indeed, the result is that we see this string locked to the console. And if the value would be something else, for example 19, then age is no longer equal to 18, and so we shouldn't see this result. And indeed. But let's put it back to 18. Okay, so how does this equality operator here actually work? Well, just like the comparison operators, this operator will return a true or a false value, so a Boolean value. Only that in this case, true will only be the result of this operator in case that both sides are exactly the same. All right, let's actually show that result to you. And actually we can do that right here in the console. So if I say 18 equal to 18, this will be true. But if I say 18 equal to 19, it will be false. And so that's exactly what we used here as a condition in this if block. So don't confuse the assignment, which is just the single equal, with the comparison operator, which is this triple equal. Now, besides this triple equal, we also have a double equal. So the difference is that this one here with the 3 equals is called the strict equality operator. It's strict because it does not perform type coercion, and so it only returns true when both values are exactly the same. On the other hand, there's also the loose equality operator, which is only 2 equals, and the loose equality operator actually does type coercion. So let's see that here in the console again. So in this case, I can do 18, the string, equal 18, the number, and it will still give me true. So again, the double equal does type coercion. So what this means is that this string here, this 18, will be converted to a number. And then the number 18 is the same as this number 18. Now, as I mentioned, the triple equal does not perform type coercion. And so let me show that to you. And so it's false, because 18 the string is of course different than 18 the number. So it's not the same, and JavaScript does not convert them for us. So let's try that also here in our code. And I'm just going to copy this one. And then this. And let's say here loose and here strict. So if I run this now, both these conditions should be true. So 18 the number, which is the age right now, is equal to this 18 the number, right? It's strictly equal, but it's also loosely equal. So 18 the number is of course also loosely equal to this 18. So let's run that. And indeed, we get the strict and the loose string printed to the console. But now if we change this to 18 the string, well, what do you expect to happen then? And indeed, only this line of code here is executed. So this one which says loose here, as we see here. And so that's because of the result that I showed you earlier, which is that with the loose equality operator, 18 the string is the same as 18 the number, because 18 the string will be converted to 18 the number. So I hope that's not too confusing for you. It is actually quite a confusing topic in JavaScript, because this loose equality operator, so this one here, is full of really weird rules and behaviors. This means that if we use this one here, this can introduce many hard to find bugs into our code. So as a general rule for clean code, avoid the loose equality operator as much as you can. So when comparing values, always use strict equality with the 3 equal signs as I showed you here. And that's the reason why I showed you this one first. This is something that actually most JavaScript developers advise you to do. So it's a good rule for sure, even if we actually need type conversion. In that case, it's better to convert the value manually before the comparison than relying on the double equal operator. So always default to the triple equal operator and pretend that this one doesn't even exist. Okay, of course I still needed to show it to you, but from now on we will assume that it doesn't even exist. Great, so let's do another example here, because I actually have some more great stuff to show you. And the first thing that I want to show you is that there is a pretty simple way of getting a value from any web page. We can do that by using the prompt function. And again, we will learn what functions are in the next section, but this is how it works. So we just write prompt and then a string. And let's ask the user for his favorite number. So what's your favorite number? So let's see what happens when we load this now. So we get this prompt window. And here we can input something and then hit return. So basically all this here will create a value, in this case the number that I just inputted. But we need to store this value somewhere. So let's create a variable called favorite. And so it's in this favorite variable where the value that we put into that form will be stored. So let's take a look at that. Console.log favorite. So 23. And you see that it now logged the value. But it's printed here in white. So remember, that means that it is a string. Let me prove that to you by checking the type. So by now we know how to always check the type, right? It's pretty simple. And so now we should see string. Now, of course, we have to give the number again. So 23 is the result, and it is indeed a string. So now let's write some logic here to check if this is a great number, basically. So let's say if the favorite number is equal, and let's use this one first. So if the number is equal to 23, then let's log to the console. Cool. 23 is an amazing number. Okay? And so now this should actually work, shouldn't it? So 23, and we get this result. So again, why is that? Well, because we used the double equals here, which is the loose equality operator. And this one will do type coercion, right? So right now what we have here is basically 23, the string, which is this one here, equal 23. And so this one will be converted to a number, and then the number 23 is of course equal to 23. However, if we use the triple equals, so the strict operator, then it should not work. So 23 again, but we do not get that log. And by now you already understand why that is, right? So remember how I said that we should always use this one. And so we now have to convert this string to a number. And we can actually wrap all of this into that number function that we used to convert. So number, and then we put all of this here, which is the one that will generate the string 23, and then we wrap that into the parentheses to execute the number converter. And so right now, favorite is going to be a number, and so then this should be back to working, because then at this point we have 23 equal 23. And so that, of course, is true here, and so then this line of code will run. So 23, and indeed it does. And you see that it's also now pink, meaning that it's a number. And if I use something else, then of course this here is also false. So if I have 22 here, then this will of course be false because they are different. But this actually brings me to my next point, which is the next cool thing that I wanted to show you. And that is that we can actually add more condition to an if-else statement. So far we have only used if, else. However, we can also add an else if block. And that works like this. So else, and then a new if. So let's now do favorite equal to 7. And then let's say 7 is also a cool number. And so what this will do is to first check if the number is 23 here. Then if it's not, it will of course go to the next block, which is this one, and then it will check this condition. Well, if the number is 7 now, then run this code. And then at the end, we can also add an else block. So let's say number is not 23 or 7. So let's test that. So if I put 7 now, we get 7 is also a cool number. And so that's our else if block here. So this second one here running. But now if I do something else that is neither 23 nor 7, then we go to that last else block here. Okay, and we can actually keep adding more and more. So we can do this as long as we want. So we can do else if favorite triple equal 9, for example. Let's simply grab this one here. Say 9 is also a cool number. And then number is not 23 or 7 or 9, just to make it really complete. And so now if we use the 9, then 9 is also a cool number. So we now have a way of not going immediately into the else block once the initial condition is false. So if this one is false, it doesn't immediately go into the else block. There are now other conditions that can be checked one after the other. First, we check for 23, but if it's not 23, we check if it's 7. If it's not 7, we check if it's 9, and if it's not 9, well, then the final else block will be executed. Okay? I hope that makes sense. And we actually use this from time to time. Okay, and now to finish, there's also an operator for different. So we talked about equal, but of course, there must also be an operator which does the opposite. And so that's the different operator. And so let's now check if the favorite is different from 23. So we use the exclamation mark and then the double equal, which is the strict version. And then there's also the loose version, which is this one. So with just one equal. But just as before, always use the strict version. So if the number is not 23, we can log something like saying, why not the 23? Okay, let's try that. And let's use 9. So what do you think will happen when we use the number 9? So we get first this log here from this else if block, right? But then we also get this why not 23 message. And that's of course coming from this if block here. So 9 is of course different from 23. And so this code here is being executed. But now if we actually use the 23, then only this line of code is executed and this one here isn't, because the favorite number is now equal to 23. And so, of course, it doesn't make sense to then execute this one here. So sometimes we need the different operator and sometimes we need the equality operator. Just choose whatever you need to solve any particular problem. In both cases, just make sure to use the strict version of the operator. When we learn about if-else statements, comparison and equality operators, and Boolean values, we also need to learn about logic, and in particular about Boolean logic. So let's do that in this video. So basically, Boolean logic is a branch of computer science which uses true and false values to solve complex logical problems. And in order to do that, it uses several logical operators to combine true and false values. So much like we use arithmetic operators to combine numeric values. Now we're only going to scratch the surface here and talk about the most basic logical operators, which are the AND, OR, and NOT operators. And note that Boolean logic is actually not specific to JavaScript. This is all true for all programming. But anyway, let's now understand how these operators work and use an example to illustrate it. So here we have two Boolean variables that can either be true or false. So A is that Sarah has a driver's license, and B is that Sarah has good vision. So both of these are of course conditions that can be true or false, because Sarah could have no driver's license and she could have no good vision, right? And of course, on the other hand, she could also have a driver's license and could have good vision. Now, using the AND operator like A and B, we can combine these two Boolean variables like Sarah has a driver's license and good vision. Okay, but now what will be the result of this operation? Well, for that we use a so-called truth table, which looks something like this. Here we have the two possible values for each of the variables A and B, which gives us 4 possible combinations of results. And so then all we have to do is to plug in the value of our variables and get the result of the AND operation from this table. So what we can see from this table is that only if both A and B are true, the result of the operation will be true as well. And that makes sense, right? After all, it's called the AND operator. And so again, what the AND operator does is to return true only if both A and B are true. In all other situations, if either A or B are false, then A and B will also be false. And we can also generalize this to more operands, so to more than just two values. We could do A and B and C, and the result would be true only if all of them are true. And if one of them is false, then the result is immediately false as well. Now, I know that all of this might look a little bit confusing, but don't worry, we will have an example a little bit later in this lecture, and we will also use this in practice in the next one. And after some practice, you will internalize all of this, and you won't even need any truth tables. Now, moving on the other hand, we also have the OR operator, which kind of works in the opposite way. So with our current example, we could use the OR operator to determine whether Sarah has a driver's license or good vision. And just by thinking about this, we can already intuitively imagine that the OR operator will be true if just one of the variables is true. And in fact, a look at the truth table confirms exactly that. So unlike the AND operator and the OR operator, even if one of the variables is false, the outcome will still be true. Or in other words, if either A or B is true, then the OR operation becomes true as well. And that's why it's called the OR operator. And once more, if we have multiple variables, it's enough for one of them to be true to make the whole operation become true as well. Okay, I hope this makes sense. And once again, I can assure you that it will make sense once we start using this in practice. Anyway, we finally also have the NOT operator, which is a lot simpler because it doesn't combine multiple values. Instead, the NOT operator acts on only one Boolean value, and it basically just inverts it. So if A is true, it will become false, and if it's false, then not A will become true. Simple as that. And that's basically how these 3 most important logical operators work. But of course, the best way to understand it is to use a more practical example. So let's go again back to using the age, and this time we set it to 16. And then we have our 2 Boolean variables. The first one is age is greater or equal 20. And the second one is age is less than 30. So let's determine the value of each of them. So if age is 16, then age is greater or equal to any must be false, right? And of course it is. And age is less than 30 is true, because 16 obviously is less than 30, okay? So that's the baseline basically, and now we will start to combine these variables a and b using some logical operators. So the first exercise is the not operator, so not a. And we know right now that a is false, right? So the result of not a, as we just learned, is true, because all it does is to invert the logical value of the variable. Next one, we have a and b. And we already know that a is false and b is true. So I'm just putting these values here again to make it a bit easier to follow, okay? So we have basically false and true. So from a look at our truth table here at the right side, we can easily determine that the result of this must be false. And so that's exactly what we learned before. So when we have the AND operator, it's enough for one of the operands to be false to make the result of the operation also false. Now we have A or B, and so let's check out the truth table in this case. And so in this case, we actually get true. And so this shows that it is enough for one variable to be true for the whole expression to be true as well. Next up, let's check not A and B. And we already know that not A is true and B is true. And so this time, for the first time, we are combining multiple operators here. And yeah, we already know that true and true will of course be true as well. And now another one combining two operators. So A, or, and B. And just as a side note, the not operator actually has precedence over the or and operators. So basically the values are inverted first and only then they are combined using and or. So we know that A is false and B is true. So not B must be false, right? Then false or false is also false. And actually that's the only way in which the or operator can be false, if all of them are false, basically. So I hope that made sense to you. And so in the next lecture, we will actually use these operators in code. And then it will make even more sense to you. So by then, we probably won't even need the truth tables anymore, because it will become quite intuitive how both of these operators actually work. But anyway, let's now move on, and I see you in the next video. Let's now return to our code and learn how logical operators work in JavaScript. And let's actually use the Boolean variables from the last lecture. So the one about having a driver's license and having good vision. So we are going to create a variable for each of them. And the first one will be has driver's license. And let's start by setting it to true. And remember that this one was variable a. And then let's create has good vision. And also let's initialize it with true. So these were the two a and b variables that we used in the last lecture as an example. And so it's a good idea to use these here as well. Okay, but now let's get started with the and or operators. So let's log to the console of using the and operator on these two variables. So has driver's license, and now the and operator in JavaScript is this one. So with this we can combine two logical values. So has driver's license and has good vision. So let's see what the result will be. So this one is true, right? And this one is true as well. So the result of true and true should be true, right? So let's see. And yes, So that works. But now, of course, we will change one of them to false. So remember, the result of true and false will be false, because it's enough for one variable to be false for the result of the operation to be false. And so here we can now confirm that, and indeed, that is the result. But now let's see what it would look like with the OR operator. So I just copied this and paste it here. And now instead of AND, we use OR, and that looks like this. So again, true or false, what do you think it will be? Remember from the last lecture. And the result is true. So it's enough for one of the variables to be true for the whole operation to become true. So I hope that's nothing new at this point. And of course, finally, we can also use the NOT operator to basically invert one of the values. And the NOT operator in JavaScript is the exclamation mark. So NOT has driver's license will become, so it will change from true to false. All right. And now, since we know how all of this works, we can use these variables to take a decision. So let's say that we want to determine whether Sarah should drive or not. So let's create a new Boolean variable and use the others to determine that. So let's say should drive. And our model is that Sarah should drive if she has a driver's license and at the same time has good vision. Okay? And so, as I mentioned in the last lecture, we can now use these Boolean variables and this Boolean logic to model complex situations. And this one is actually pretty simple, but we will take it up a notch by the end of this lecture. So, remember, our model is that she has a driver's license and that she has good vision. Okay? And now we can use this variable to finally take the decision. So let's then use this Boolean variable here and say, if she should drive, then log to the console, Sarah is able to drive. And if not, just log someone else should drive. Okay, and actually, we can put the condition right here in the if condition. So this was just to show you a little bit the thought process. But as I mentioned earlier, we usually create the condition right here in the if statement. So give it a save, and now let's run it. And the result is someone else should drive. So that is because has good vision is false. And so our condition of has driver's license and has good vision is not true, because it's only true in case that both of them are true, as you already know by now. So this one is false right now, and so therefore the else block will be executed. But of course we can change it once more. And so right now, both of them are true. So has driver's license, true, and has good vision, true. So true and true is true. And so Sarah is able to drive. Let's check that. And indeed. Great. And with this one working now perfectly, let's take it to the next level and add another Boolean variable here. So let's now also add is tired. And let's set it to true as well. So we can say that this is our variable C. So to use more than two variables with, for example, the AND operator, let's just go ahead and copy this one. So if you want to say has driver's license or has good vision or is tired, all we have to do is to add another OR operator here, just like we would add another plus or another minus operator. And the result of this should, of course, be true because, well, all of them are true. And indeed, it is. And if we set them all to end, then it is also true because all of them are true. But if we set this one to false, then as you can guess, the result will be false. And that is because, as I explained in the last lecture, it's enough for one of the operands to be false to make the whole AND operation false as well. Okay, but let it set back to true. And now we can use this to improve our decision making whether Sarah should drive or not. So with this third variable now, we want Sarah to be able to drive if she has a driver's license, if she has good vision, and if she is not tired, right? So let's now translate that into a condition. And I will just copy this one and then comment all of it out using Command or Control/, just like many times before. And now we will improve this one. So this one, of course, is the same, that she needs to have a driver's license and good vision. But now additionally, we want her to be not tired. So right now she is tired, it's true. And that's, of course, not good for driving. So we want the opposite of being tired. And so, therefore, we need to invert it. So do you remember how that works? All we need to do is to use the not operator. So not is tired. All right. So let's read this again. Sarah is able to drive if she has a driver's license. So if this one is true, if she has good vision. So if this one is true, and if she is not tired. So if all of this is true here. So only in this condition, Sarah is able to drive. Now, how is this part here true? Well, it's true when is tired is false, right? So what do you think will happen in this situation right now? Well, let's test and then analyze. So we get the result, someone else should drive. So why is that? Well, this one is true, this one is true, as we see up here, and then is tired is also true. However, not is tired is false. So this part here is false. And so true and false is, of course, false. And so therefore we get the else block, someone else should drive. Now to fix this, we need to change is tired to false. All right. And so right now is tired is false, and therefore not is tired will become true. And then we have true and true and true. And then in this situation, Sarah will be able to drive. Yes, indeed, it works now. So as you see, with these three Boolean operators, we can model all kinds of complex decisions like this one. Now, I know that this was probably a bit confusing, but please don't worry too much because it's all very confusing for everyone when they first learn how to program. Okay? Just take some time after this video and analyze again exactly what happens here, maybe also together with the last video, to really make sure that you understand what is going on here. But of course, the best way to retain any knowledge is by practicing and reinforcing it. And so let's do that now in the next coding challenge. Okay, hopefully you managed to complete at least point 1 and point 2. And so let's start by solving these two. So number 1 is calculating the average of both teams. So let's create one variable for each. So score Dolphins. And so to calculate the average, we simply add up all the three scores and then divide it by 3. So we already did something similar before. So that's 96 plus 108 plus 89, and then divided by 3. And we need these parentheses so that these plus operations are executed first, because the grouping, so the parentheses, have a higher precedence. Okay, score koalas is 88 plus 91 plus 110. And again, divided by 3. And now let's quickly log both to the console here. Score dolphins and score koalas. Okay, so they're pretty close, but the dolphins have a little bit higher of an average. And so that's what we're working on in point 2, where we're going to compare the average of both teams. So we are going to use an if statement, or if else probably. So score dolphins, if it's greater than score koalas, then log to the console dolphins win the trophy. And we can get fancy here with some emoji. Let's see if we got one. Ah, that's the one I'm looking for. But of course, once more, you don't need to worry about this part. Let's just copy this for the next one. So else, and actually we are going to use an else if because of the draw. But let's talk about that one later. So if the score of the koalas is greater than score dolphins, then we're gonna print the opposite, so that koalas win the trophy. And finally, else if score dolphins is equal to score koalas, then we can simply say that no one wins the trophy, or actually both win the trophy. Okay, so let's test that. And indeed, we get that the dolphins win the trophy. And that's because, as we know, this value is greater. And so actually this first condition here turns out to be true right away. And so this block of code here gets executed. Now let's just quickly increase the score of the koalas here. Let's say 100, just to see if the second part also works. And indeed, now the koalas win the trophy. Okay, but let's put it back here. And here you could have actually done it in another way. So you could have done score dolphins less than score koalas. So basically write the same as here, but instead of the greater, you would have used the less than. So that's the exact same thing, and both are equally valid. Then here in the last part, actually we wouldn't even have needed this part, so that the score of dolphins is equal to score of koalas, because that's actually the only scenario that's left given these previous two conditions. So basically, if none of these here were true, really the only thing possible would be that they had the same score. And so a simple else block would have been enough here. But anyway, this works just fine too. And so again, what matters is that you made it work, even if you did some things differently. For example, you could have stored the conditions in separate Boolean variables, or you could have structured the if-else statement in some different way. But if you got the same result that we just saw here, then congratulations. That's a great work. Well done, really. So maybe you even made it to bonus number 1 and 2. And so let me solve them here now as well. So let's start by calculating the average. So this is going to be bonus 1. And yeah, let's copy this one too. Let's copy this one. Let's copy this one. So I should have done it all in one go, so that we can now comment out this first part. So for test number 1, this should be 97. Then the second one should be 112 and 101. And for the koalas, we have 109, 95, and 123. Let's just quickly test. And so right now the koalas win the trophy. So for now, everything works the same. But now we need to include this important condition here, which is that with this rule, a team only wins if it has a higher score than the other team, which we already have, and at the same time a score of at least 100 points. Okay, easy enough. So in this case, the Dolphins win. Okay, but now we also need to ensure that the Dolphins have a score higher or equal 100. So let's just say that. So Dolphins need to have a higher score than Koalas, and score Dolphins needs to be greater or equal 100. And that's it. That's all we need for this requirement. And then the same thing here. So this is the scenario where the Koalas win. So for the Koalas to win, they need to have a higher score than the Dolphins, and at the same time, they need to have at least 100 points. So just like before, greater or equal 100. And so once more, we used a logical operator here to model this situation, essentially. Okay, and actually, I think with this, we implemented this bonus number 1. So let's try that again. And right now, of course, it still works because both have a score higher than 100. But let's change that now here, according to test data 2 to 106. So 106. And now they both win the trophy. So let's actually decrease all of these points like by 20. So let's make it 81 and 86. So the average should still be the same now. Yeah, but they're both below 100 now. And so this brings us to bonus number 2 that says that the minimum score should also apply to a draw. So a draw only happens when both teams have the same score and both a score greater or equal 100 points. Okay, and otherwise no team wins the trophy. So that's important too. So let's translate that. So to be a draw, the score needs to be the same, which we already have, and the score of Dolphins needs to be greater or equal 100, and the score of Koalas needs to be greater or equal 100. Okay, and else, well, then we can say that no one wins the trophy. And let's just add some sad emoji here. Okay, let's try that. And now we get that no one wins the trophy. Okay. So that's because their scores are now below 100. And so we actually entered this last case here. But if we go back to the averages that we had before, so 106 and 101, let's see. And now both win the trophy because they have the same amount of points and they both have a number of points above 100. And so that's exactly what we have here. So same points, Dolphins have over or at least 100 points, and Koalas have at least 100 points. And so in this case, both win the trophy. Finally, let's also test the scenario in which both have below, but the Dolphins have a little bit more. Let's put this one here at 80. And so now we see that the Dolphins have 96 points, and the Koalas have 84, but still no one wins the trophy. And that's because the Dolphins have more than the Koalas, so this part of the requirement is true, but they do not have over 100. So this part here is false, okay? And so true, this first part here is true, and the second part is false. And true and false gives false. And so then all of these are skipped because they're also obviously false. And so we go straight to this last block. And so no one wins the trophy, which is exactly what we were expecting as a result here. Okay. Now, if you didn't manage to do this here, again, don't worry, because I know that this is a little bit complicated already. And so in case you managed to successfully complete this challenge, then a huge congratulations to you. Well done. But if for some reason you were not able to complete the challenge, then don't worry all too much about it. You can always go back to the lectures where we first learned about these topics, and you can, of course, after this video, also review the code a little bit more carefully to make sure 100% that you understand, especially this last example that we just worked on. Okay? But anyway, great job in completing this challenge, and now I see you in the next video. Let's learn about the switch statement, which is an alternative way of writing a complicated if-else statement when all we want to do is to compare one value to multiple different options, basically. So in this example, let's say we have a weekday variable, and for each day there is a different activity. So basically we're gonna map one activity to each day. So let's say day, and I'm setting it here to Monday. Now, maybe you're wondering why I'm basically hard coding all these variables and how this would work in the real world. Well, in a real application that's used by users in the browser, usually most of the data comes from user input. And so then we wouldn't be hard coding all of this stuff. Okay? But right now, well, we are just learning how to code. And so it's absolutely no problem at all to just hard code all of these values here. Okay? Now, anyway, going back to our example here, let's now essentially map one activity to each day. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And for that, we could use an if-else statement with multiple else-if blocks, but we can also use the easier to use switch statement. So let me just write how that works, and then I'm going to explain it in a bit more detail. So what we're switching is basically the day. So this is what we're going to compare to multiple options. Then we need the curly braces to define a block, and then we can define cases. So let's say case Monday. Then this colon, and notice how it's a colon and not a semicolon like this. Then another indentation, and then here comes the code that we want to do. So as always, we log something to the console. And once more, in a real-world app, we will of course not be logging stuff to the console all the time. This is once more just so that we can learn how all this different stuff works. So let's say on Monday, I plan my course structure. And here we can actually execute multiple lines of code. And we don't need curly braces for that. So after the case and the colon, all the lines are then executed. Okay, and the syntax of this switch statement is actually a little bit unusual. So it's unlike anything else in JavaScript, but well, that's just how it is implemented, I guess. So anyway, we will execute two console.logs here. So the second one is go to coding meetup. Okay, so basically what this will do is it will compare day to Monday here in a strict equality way. So this here is basically writing day equal Monday. And if this is true, then this code here will be executed. Okay? Now, after this, we actually need this break statement. And you will see why in a second. And now let's add the next case here. So case Tuesday. So basically we're going to do one for each day of the week here. So let's say prepare theory videos and then another break. And I wish that preparing theory videos would only take one day, but it doesn't. Okay, so Wednesday is the next one. And actually we can do a nice little trick, which is to run the same code for two different values. So all we have to do is specify this case, and then we can specify another case right after it. So let's say day here. And so whatever we write here will then be executed for both Wednesday and Thursday. So without needing any logical operators as we would need with an if-else statement. And actually, we're going to translate this into an if-else statement after we're done here so that we can analyze the difference. So let's say Wednesday and Thursday, I write code examples. On Friday, I record videos. And here's a small bug. So it's a colon, as I was saying you. And then let's do Saturday. And also the same for Sunday. So console.log, and then here, enjoy the weekend. Okay. And then, oh, I actually am forgetting the breaks here. So break. And I will show you in a second what happens without the break. But anyway, to finish, we can also set a default. And so the default is going to be executed if all the other cases fail. So default, just like this. And then here we can simply say console.log, not a valid day. So basically we're using this for an invalid weekdays. It's basically like an else block at the end of a long if-else statement. Okay, so let's now check out the result. And indeed, we get these two logs here from here. So from line 379 and 380, which are exactly these two lines of code. Then if I change it to, let's say, Wednesday, like that, we get write code example. And on Thursday, it should yield the same result because, yeah, we did this here for these 2 days. Now I guess I wrote something wrong. And actually it's here, Thursday, right? But so you saw that actually, since this option here was nowhere to be found, we actually got to the default block, which is then not a valid day. But now we should get the right code examples. Now without the break here, and let me comment it out just for demonstration. If we put this back to Monday, then let's see what happens if we load. And so now we get 3 outputs. We get this one, and this one, and this one. So that's the one immediately after Tuesday. And this happens because without the break, the code simply continues executing. And it stops here because here we have the break. But if I remove this break as well, then it would continue down this structure. And so after each block here, we need to tell it to stop, essentially. And so now it's fixed and it works just fine. Okay, great. That's how the switch statement works. And remember that this actually does a strict comparison. So it does it like this. Here it does, if the day is equal to Monday, then execute this. If the day is equal to Tuesday, execute this, and so on and so forth. So this was really designed for equality and not for like comparing stuff. It is technically possible to do that with some workarounds, but that's not the goal of the switch statement. Now, just as a fun exercise and to get a better idea of how this actually works and also how the if-else statement works, I want to challenge you to write this same logic, but this time as an if-else statement, okay? And to do that, you will have to use a logical operator to translate the case of the Wednesday and Thursday case. So think about what happens. So basically, write code examples should be executed if the day is Wednesday or Thursday, right? So whenever the day is one of these two. So it's impossible to be Wednesday and Thursday because, well, 2 days cannot occur at the same time. So keep that in mind. And yeah, pause the video here and really try to do this one on your own. Okay, did you do it? Well, let me just quickly show you how it's done. So remember that we're using strict comparison, so the triple equals. So if it's Monday, then do this, and I will, after finishing the structure, I will just go ahead and copy the console logs from up there. Then we need an else if. For the case it's Tuesday, then we need another else if in case the day is Wednesday, or if the day is Thursday. And again the same error. And you see that we're writing quite a lot of repetitive code, especially always the day and then the triple equals. So, and that's what the switch statement kind of tries to avoid. So else if, and then if the day is equal to Friday, do this. Else if the day is equal to Saturday, or the day is equal to Sunday. And finally, also the else block in case that we have an invalid day. So let's grab these here. And note that in this case, we of course don't need the break, because JavaScript will only execute one of these blocks. So Friday and now Tuesday, and finally Monday, these two activities. Okay, give it a save, and now I'm gonna reload here. And so now we should expect the same result here, but twice. Once coming from the switch statement, and once from this big if-else block. Yeah, and indeed, it works just the same. Let's just try another one. Say Friday, just to make sure. And yeah, the result is the same. And so this logic here does basically exactly the same as this. We simply wrote it with a different syntax. Okay, so with the switch statement, we have to write a little bit more code, but in my opinion, it's also a lot more readable, which means that this one is easier to understand if you just read the code. Here we have a lot of this repetitive code and all these curly braces, and it just looks a little bit weirder. At least that's my opinion, but of course everyone is different. Now the switch statement is actually becoming less and less used, but you should still know about it, because there is definitely still a place for it sometimes. And actually in this example, for instance, I would actually prefer to use the switch. Okay, but again, that's down to your personal preference, and it's good that you start basically developing your own coding style and do what you like the most. Now that we're getting more comfortable with JavaScript, it's time to learn about a more theoretical concept, and that's the difference between statements and expressions. And this is going to be just a very high-level overview, just so that the future lectures make more sense. So essentially, an expression is a piece of code that produces a value. For example, 3 plus 4 is an expression, because this is going to produce a value. Okay, so I don't even mean the entire line of code. What I mean is really just this 3 plus 4. This is an expression, okay? And again, because it does produce a value. The same goes, for example, for just any number. This, for example, is an expression too, even though it's just a simple value. But it's still also an expression, because again, this itself will produce a value in JavaScript. Or we can do this. So true and false and not false. So all of this here is an expression, right? Because this will in the end produce some Boolean value. Now, on the other hand, we have statements. And a statement is like a bigger piece of code that is executed and which does not produce a value on itself. And we can compare this with normal spoken language. And so in this example, a declaration is like a complete sentence, and expressions are like the words that make up the sentences. Now, basically, we write our whole programs as a sequence of actions, and these actions are statements. So let's take as an example the if-else statement. So let's say if 23 is greater than 10, then, well, just do something. So create a string called 23 is bigger. The code itself doesn't really matter here. So this if-else statement is in fact a statement. And so that's the reason why I have called it the if-else statement all the time. And the same is true for the switch statement. So this statement here doesn't really produce a value, does it? All it does is, in this case, it simply declares this variable called str. But that's it. It performs some actions, in this case declaring this variable, but it doesn't produce a value. And so in that, it's different from, for example, having this here. Okay? Now the string itself, again, is an expression. So this is probably a bit confusing, but that's not a problem, okay? My goal here is not that you understand the exact rules of what an expression is and what a statement is, because in fact, it's all a bit fuzzy. So my main goal with this lecture is really that you know that statements and expressions exist, and that expressions produce values, and that statements are like full sentences that translate our actions. So the actions that we want the program to perform, okay? So really, that's all you need to know and all you need to basically memorize from this video. We don't need to go into all the details. So there's no need to start asking a bunch of questions about this in the Q&A section, all right? So this will all make even more sense as we move on. So I said that this string here is itself an expression, and then this whole line of code is a statement, because this again does not produce a value. And so basically, whenever something ends with a semicolon, that's then a statement. It's like a complete sentence, okay? Now this difference between expressions and statements is important to know because JavaScript expects statements and expressions in different places. For example, in a template literal, we can only insert expressions, but not statements. So let me just very quickly demonstrate that to you. So we can say, and then our placeholder here, basically. And so in here, we need to put an expression. So something that produces a value, which can then be put into the string that we're building here using the template literal. So let's say, just to do some calculations here, so 2037 minus 1991 years old. So again, this is an expression here. And so this one will work. However, we cannot do this. For example, we could not insert this if statement in here. That wouldn't make any sense at all. Okay, let's try that. And so we actually get right away unexpected token if. And that's because JavaScript knows that this is a statement and statements don't make sense where JavaScript expects an expression. Now, if we had a variable, for example, then if we used that here, then this would actually also be an expression because this variable will essentially just be replaced with this string. And so this produces a value. And so, of course, this is completely acceptable. Okay. And that's actually all I had to show you in this video. Again, my goal was really just to make sure that you kind of understand the difference between expressions and declarations so that moving forward, we are really both on the same page here. So we already saw two ways of writing conditionals: the regular if-else statement and the switch statement. But there is another one, and that's the conditional operator. And this one is actually really nice. So let's check it out. So the conditional operator allows us to write something similar to an if-else statement, but all in one line. So let's again start by defining an age variable. And this time I'm setting it to 23. And now let's write age greater or equal 18. So this is here our test to check whether the age is at least 18. So basically if the person is of full age. And then after this condition, we use the question mark. And then here we write essentially our if block. So that's the code that we want to be executed in case that this condition here is true. So let's say console.log, I like to drink wine. Let's again add a nice emoji here. So basically, if the person is of full age, they are allowed to drink wine, okay? And in this if block, so to say, we can only really have essentially one line of code. So only one thing can be done if this condition is true. Then we also need basically a mandatory else block. And that goes after this colon. And so let's just copy this code and say, I like to drink water. Okay, and that's actually it. So let's check the result and then analyze this a bit more. So in fact, what gets logged to the console is, I like to drink wine. And that's because the age is 23, and so this condition is true, right? And this means that this code here is going to be executed and this one is not. So the second part here, which is essentially the else part. Now, if we were 15, then of course, the second part is executed. Okay, so that's essentially writing an if-else statement all in one line. But instead of using a statement, we use this conditional operator. And the conditional operator is also called the ternary operator because it has three parts, unlike other operators. For example, the plus operator has only two parts. For example, 1 plus 2. But this one has three parts. So the condition, then the if part, and then the else part. Okay? Now, the conditional operator is in fact an operator, just as the name says. And remember that an operator always produces a value. So in other words, an operator is an expression, right? So what this means is that if we have a value, we can then assign that value to a variable. And so with this, we can make the ternary operator really useful to basically conditionally declare variables. So what we did here is not so much used, indeed. Instead, we do it more like this. So we would still test for this condition, let's say. So checking if the person is of full age. And if that's true, then all we want is essentially to return this. And if not, we only want this. Okay? And so again, this whole operator here is now an expression. And an expression produces a value. And so now we can go ahead and store that value into a variable. So let's call that drink. And then we can log this drink to the console. And let's comment out this part here. And check. And indeed, we get wine as we declared up here. Great. So drink is now really defined conditionally based on this condition and all in one simple line. So without the conditional operator, we would have to use an if-else statement. And with that, this wouldn't be so easy. Remember, when we want to declare a variable inside of an if or an else block, we need to first declare that variable outside. So let's actually do that. So simply call it drink2. And then we would say if the age is at least 18, then drink2 is going to be wine. Let's just grab that here. Or else drink2 is going to be this water here. Okay, and again, we need to define the drink2 variable outside of the if and the else blocks, because any variable that we define inside of a block is not available outside. So we declare the variable here and then reassign it inside of the blocks. So just to make sure it worked, let's log this one here as well. But we really just did this for the sake of comparison. Okay, just so you can see the tremendous difference that the ternary operator introduces here in our code. So if you ask me, this one here is a lot easier to understand and a lot easier to write, right? So just changing this to something else here. And yeah, in both cases, we get a water back. So using the ternary operator, we were really able to transform this big block of code all into one small operation like this. And this is going to be useful in so many cases. And we will really take advantage of this throughout the rest of the entire course. And now we can take it even further. Because since the ternary operator is really an expression, we can now use it, for example, in a template literal. So unlike a normal if-else statement, like we tried and failed in the last lecture, remember? So that was here, where I tried to insert this if statement here, and of course it didn't work. But using the ternary operator, which produces a value, we can actually have conditionals inside of a template literal. So let's simply try that. And so I can now say, I like to drink, and then based on the age, I can say if I like to drink wine or water. So here in this placeholder, remember, I can put any expression that I want. And this here is an expression. Again, because it produces a value. So I grab it from here, paste it here, and that's it. The template literal will now use whatever result we get from this operator. So that's either going to be wine or water. And then it assembles that result into the final string. So let's check. And indeed, once more, the conditional operator works just fine. And with our age back to 23, then we get, I like to drink wine. Great. So I hope that this makes sense. I know that especially this part here can be a little bit confusing for beginners. So take a minute to really understand what happens here. And always keep in mind the concept of operator and of expression, which is something that produces a value. And thanks to that, we can then put that value here in this placeholder in the template literal. All right. Now to finish, I just wanted to mention that the ternary operator is not thought as a replacement of if-else statements. Okay, we still need if-else all the time. For example, when we have bigger blocks of code that we need to execute based on a condition. In that case, the ternary operator is not going to work. But the ternary operator is perfect when we just need to take a quick decision, for example, like this one. And that's especially true in places where JavaScript really expects an expression, just like here in this template literal. So here we could not use an if-else statement, and so the ternary operator really comes to our rescue here. So I think you can understand that this one is really, really important. So make sure that you absolutely understand how it works. And once you do understand, then let's move on to the final lecture of this section, which is yet another coding challenge for you to see if you did actually understand how the conditional or ternary operator works. Okay, so I hope you successfully did that. And so let's try to solve it now together. Or actually, let me show you my solution so that you can see how it compares with yours. And as always, you can also find my solution in the final folder in the GitHub repository. Okay. Now, actually, let's start with the bill variable, which I'm going to set to 275, which is here the first test value. And now the tip, and let's calculate it using the ternary operator. So let's implement this rule, which is if the value is between 50 and 300, then the tip should be 15% of the bill value. So that means that bill must be less or equal 300, and at the same time, bill must be greater or equal than 50, right? And again, that's what it means for the bill value to be between 300 and 50. It's going to be less or equal 300, and at the same time, greater or equal than 50. So 40, for example, is of course less than 300, but it's also less than 50. And so this part here will then be false. And so this entire expression here, which is then true and false, will be false as well. Right? So in this case, the tip here will be the bill value times 15%, which, as I explained here, all we need to do is to multiply it by 15 divided by 100. So that's 0.15. And else, it's 20%. So bill times 0.2. Give it a save, and that's actually it. So that's number 1. And now as number 2, let's lock this string to the console as is requested here in number 2. So let's actually grab this template here. So then we just have to replace the values. And so since we're building a string, we are again relying on the template literal. So here we're going to put the bill value. Here we're going to put the tip. And we're missing the curly braces. And here the total value is going to be the bill plus the tip. So we can, as you already know, write an expression here using this operator, so the plus operator. And that's actually it. So let's try it. And with this bill value, the output should actually be exactly like it's written up there. And it is. So 275, the tip is 41.25, so just like here. And the total value is 316.25. Great. And just to understand this one, so this condition a little bit better, let's just take this one and paste it here into the console. And so we see that this one is true. And of course, that's because 275 is less than 300 and more than 50. So it is between this range. And therefore, this part of the ternary operator here will be executed and become the result of this operator, essentially, right? So the result of this operator will be bill times 0.15, and that's the value that will then be assigned to the tip variable, okay? Now let's try another one. So 40, and now the tip was 8. Let's try this one here again, and now the condition is false. So remember that here in the console, we have access to all the variables that we have declared here. So if I write bill now, you will see that it's actually 40. So bill is obviously below 300, but it's also below 50. So this part is false, and true and false gives false. And so in this case, the value that's going to be assigned to tip is 40 times 0.2. And that's exactly 8. So it's what we see here. Okay, and now just for the sake of completion, let's do the last one as well. And Yeah, this should have worked as well, because now this one is false again. And that's because this time 430 is above 300. And so 86 should be 430 times 0.2. Let's quickly check that. 0.2. And that's right. That's the 86 that we have up here. Great. So hopefully you did this. And once more, if you did it a little bit differently, that's not a problem at all. I just hope that you made it work. Okay? And actually, this concludes the coding part of this section. There's just one more lecture left, which is going to be a deeper dive into JavaScript versions, especially into ES5 and ES6. So it's going to be an interesting one, and yeah, I'm waiting for you there. Now that you're familiar with the fundamentals of the JavaScript language, we need to talk about JavaScript releases, or versions, before moving on. And we briefly talked about this in the intro video, but now let's go into more depth, because it's really important to know about how JavaScript releases work and how we can use them. It's important for your work as a web developer, and also because you will see these topics coming up in the developer community all the time. And so you want to be able to understand what's going on. And the best way to start understanding JavaScript versions is by looking at the history of JavaScript. So let's do that. And let's start at the beginning of the internet itself. So quickly after the internet was invented and the first web browsers were developed, developers wanted to start making websites more interactive. In other words, they needed a programming language for the browser. So in 1995, the Netscape Navigator, which by the time was the dominant browser, hired a guy named Brendan Eich to create the very first version of JavaScript in just 10 days. It was called Mocha, so not JavaScript yet, but it already had many of the fundamental features that modern JavaScript has today. So that's very impressive that he basically created this first version in really just 10 days. Then in 1996, Mocha was renamed to LiveScript, which was then again renamed to JavaScript for one simple reason: to attract developers from the hottest language at the time, which was Java. So the Java in JavaScript was really just for marketing reasons, because the language itself has basically nothing to do with Java. Now, some beginners think that this is the case, but actually no. JavaScript and Java are two completely different languages. Also in 1996, Microsoft launched the Internet Explorer, which basically copied JavaScript from Netscape. But they called it JScript for legal reasons because, well, you actually cannot just go around and copy other people's programming languages. Now, what this means is that we now had two very similar but competing languages, which of course is never a good idea in the long run. And so, with the internet growing like crazy around this time, people realized they needed to standardize JavaScript. So the language was submitted to an independent standard organization called ECMA, which in 1997 released ECMAScript 1, or ES1. This was the very first official standard for the JavaScript language. And with this, every browser could now implement the same standard JavaScript. In the real world, we usually use the term ECMAScript to refer to the standard, while JavaScript is used when we talk about the language in practice, as it's implemented in browsers. Now, fast forward to 2009, after a lot of complications and disagreements about where the language should be headed, ES5 was released with a lot of great new features. And then finally, another 6 years later, the much-awaited new version ES6 was launched in June 2015. And this was the single biggest update to the language ever. So it contained a ton of new exciting features, which we will explore throughout this entire course. This was and still is a really big deal for JavaScript and for the whole web developer community. Now, you will also see ES6 being called ES 2015, which is actually the official name, but most people just call it ES6. And so that's what I'm going to do here as well. And actually the reason for ES6 being called ES 2015 officially is that in 2015, ECMAScript changed to an annual release cycle. So right now, there's going to be a new release every single year. The reason for that is that they prefer to just add a small number of new features per year instead of shipping a huge new version every couple of years like it happened with ES6. And so this way, it's going to be much easier for everyone to keep up to date. And so according to this new annual release cycle, in 2016, ES 2016 or ES7 was released, ES 2017 in 2017, and like this, it will continue until the end of time, or something like that. Now, there is one particularity about JavaScript releases which is pretty unique for any programming language, and that is backwards compatibility all the way to ES1. So what does that actually mean? Well, basically it means that if you were to take some JavaScript code written back in 1997 and put it in a modern browser with a modern JavaScript engine today, it would still work just the same. So again, the JavaScript engine that's in our browsers today is able to understand old code written 25 years ago without having to rely on version numbers or anything like that. It just works. And it works this way because of the fundamental principle that's baked into the JavaScript language and its development, which is to not break the web. This means that there is almost never anything removed from the language, but only added in new versions. And actually, we cannot really call them new versions even, because they do not contain breaking changes like when other languages move to a new version. Instead, new versions are always just incremental updates which add new stuff. And so I like to call them releases and not versions. The ECMAScript committee who works on updating the language does all this so that old websites basically keep working forever. Just imagine they removed some important feature that made a website from 2008 work just fine. If you then wanted to visit that page, it would be broken. And that's why we, fortunately, have the don't break the web principle. Now, of course, this comes with problems, because there are tons of old bugs and weird things in the language. Remember that Brendan Eich made the very first version in just 10 days. And no one back then could even imagine what JavaScript would be used for one day. The initial goal of JavaScript was just to add some simple dynamics to pages, not to write whole web applications in the browser like we do today. But anyway, these bugs and weird quirks in the language have been giving the language a bad reputation among many programmers, who can't really take JavaScript serious because of this. But here's the thing. We can actually go around many of this weird stuff by simply learning the modern JavaScript that matters today and just ignore most of the old weird stuff. And so that's exactly what we're going to do in this course. So next time your friends start hating on JavaScript, and believe me, this actually happens, then just tell them about the amazing things that you can build with it. Okay, but now there is one more thing that we need to talk about here, and that is forwards compatibility. So what do you think would happen if we took this totally made up code from the year 2089 and tried to run it in today's browsers? Well, you're probably right, it would not work at all. There would be errors left and right, and nothing would work. That's why we say that JavaScript is not forwards compatible. Basically because current browsers do not understand code from the future. And this actually brings us to our next topic, which is how can we use modern JavaScript today? Because browsers that users are using might be old, and there is no forwards compatibility, right? So to answer the question how we can use modern JavaScript today, we need to consider two distinct scenarios, development and production. So the development phase is simply when you're building the site or application on your computer. To ensure you can use the latest JavaScript features in this phase, all you have to do is to use the most up-to-date version of the Google Chrome browser. This will then ensure that all the features I show you in this course will work for you as well. The second scenario is production, which is when your web application is finished, you deploy it on the internet, and it's then running in your user's browsers. And this is where problems might appear, because this is the part that we actually can't control. We cannot control which browser the user uses, and we also can't assume that all our users always use the latest browsers, right? Now, the solution to this problem is to basically convert these modern JavaScript versions back to ES5 using a process called transpiling and also polyfilling. We will use a tool called Babel later in the course to transpile our code, but for now, during the course, we won't need that. Again, because you're using the most up-to-date browser during development. Transpiling back to ES5 is only necessary after your app is developed and you want to ship it to your users. Alright, so now let's take a look at how different JavaScript releases can be used today. So first off, ES5 is of course fully supported in all browsers today, all the way down to Internet Explorer 9 from 2011. So we can assume that ES5 is safe to be used at this point, which is the reason why we use it as a target for transpiling. Now about the newer releases ES6, ES7 and all the way to ES 2020 as of mid-2020, they are actually quite well supported already in all modern browsers. And we usually call all the current versions together ES6 Plus. So right now that's from ES6 to ES 2020, and basically all together they are the modern JavaScript. Now it's in this modern JavaScript, so in this ES6 Plus, where transpiling comes in, as I mentioned earlier. Again, because it's not safe to assume that all our users are using these modern browsers, and we don't want to break our app for them, right? And by the way, if you want to stay up to date with what features are currently supported in which browser, you can check out the ES6 compatibility table. It's really interesting. The link is actually on my resources page on jonas.io. Next, there are also the future releases of the language, like ES 2021, ES 2022, and so on. And these future releases together are many times called ES Next. Now, why is this even relevant? Well, because most browsers actually start implementing new features even before they enter the official ECMAScript specification. That's possible because as new features are proposed, they have to go through 4 stages, starting with stage 1, where they are first submitted, all the way to stage 4, at which point they enter the language officially. But when a feature is at stage 3, browsers can be pretty sure it will eventually pass to stage 4, and so they're going to start implementing that feature while still in stage 3. And there is a lot more to be said about this, and actually I find this really fascinating, but I'm going to stop here. You can find tons of information about this online if you want to learn more. And a great place to start is actually, once more, this compatibility table that's up here on the slide. But anyway, as these new features start coming out, I will simply add new videos about them to the course in order to keep it updated. With the annual release cycle, this is now way easier to do, because there will be no drastic changes to the language like ES6 was. Okay, and now to finish, let's quickly talk about how versions, or releases, are taught in this course. So, as I said earlier, I will teach you modern JavaScript right from the beginning of the course. Now, I used to teach this course starting with ES5 and then moving to ES6 in the middle of the course. But now, after a couple of years, it was time to fully move to modern JavaScript. However, it's also super important to learn how some things used to be done before we had this fancy modern JavaScript. For example, in this section, I already showed you the modern const and let for variable declarations, but also how we used to use var before. And there will be many more examples like this. But why bother with ES5 at all, you might ask? Well, here is why. First, you will better understand how some features in JavaScript actually work behind the scenes. For example, ES6 classes, which hide all the implementation details of object-oriented programming in JavaScript. Also, many tutorials and example code that you will find online are still written in ES5 today. Plus, as a developer in many jobs, you will actually have to work on older code bases. And it's totally possible that that code base might still contain a lot of ES5 code. Okay, so I hope that made sense. And that's it for this lecture and for this section. So see you in the next one. In this section, we will continue learning important JavaScript fundamentals. And so that means that we will learn the basics of functions, objects, arrays, and also loops. So after this section, you will already have a good foundation to start writing your own small programs using the power of JavaScript. And I hope that sounds super exciting. And so let's get started. Now, before continuing to learn JavaScript in this new section, we should first activate a special mode in JavaScript called strict mode. And here on my desktop, I already have the folder for this Part 2 Fundamentals section. And for you, as I explained before, these starter files will come from the GitHub repository that I showed you at the beginning of the course. So use that GitHub repository as your starter folder, or of course, you can just copy that data somewhere else to your computer and work from there. Whatever works for you. Now I'm creating here a new VS Code window. And let's open this new folder. So that's our new working folder. And this time we already have the script file here. And in the HTML file, we see that the script is also already linked. So we don't have to do that this time. At this point, I assume that you already know how to do that. So closing the sidebar here, and let's now get started in this new section. And as I said, let's start with strict mode. So strict mode is a special mode that we can activate in JavaScript, which makes it easier for us to write secure JavaScript code. And all we have to do to activate strict mode is to write this string at the beginning of the script. So use strict. And that's it. So with this, we activated strict mode for the entire script. Now what's important is that this line of code, so this statement here basically, has to be the very first statement in the script. So if we have any code before this, then strict mode will not be activated. Comments are allowed because JavaScript will just ignore them, but no code. Okay, now we actually can also activate strict mode only for a specific function or a specific block, but I don't really see the point in doing that. And so I always just use it at the beginning of each script. And so I believe that you should do the same. So always just put strict mode in the beginning of your scripts, and like that, write more secure code. And with secure, I mean that strict mode makes it easier for us developers to avoid accidental errors. So basically, it avoids us to introduce bugs into our code. And that's because of two reasons. First, strict mode forbids us to do certain things. And second, it will actually create visible errors for us in certain situations in which, without strict mode, JavaScript would simply fail silently without letting us know that we did a mistake. Okay? So again, first, strict mode forbids us to do certain things. And second, it creates visible errors in the developer console, where in other situations, JavaScript would just fail silently. Okay, but now to make this a bit more clear, let's actually see an example of one of the most important changes that strict mode introduces. So let's create a variable here with a complicated name. Let's say has driver's license. And let's initialize it to false here. And then I also will create pass test and set that to true. And I'm using let in both of them because I want to change them later. And actually this one not. So let's just use a const here. Because remember, by default, we should always use const to avoid accidental errors. So basically there is a certain person which right now does not have a driver's license, but they just passed a test. That's why we have passed test set to true. And now we want to write some logic so that when they pass the test, this variable here gets set to true. So we can say if pass test, right? Because this here is a Boolean value, and so this condition will be either true or false. And then let's introduce a simple bug here, okay? So this is a kind of hard to write variable name, and so let's pretend that we are writing it wrong here. So has driver license equal to true. So what I did here was to basically omit the S. So this letter here is not in this variable that I'm trying to change here to true. And again, that is an error that I'm making here on purpose, just to show you how strict mode can help us avoid a certain kind of error. Because doing this is actually more common than you might think, okay? And now, then let's log something to the console if the person has a driver's license. And so now we're actually gonna go back to writing it correctly. So if has driver's license, and so you see that now this one is exactly the same as VS Code highlights both. So if has driver's license, then log to the console, I can drive. And now let's actually start by deactivating strict mode again, just so we see how this bug could affect our code. So I'm giving it a save, and then let's go and open this index.html file. Okay, now let's open up the console here. And again, I'm going to increase the text by hitting Command plus a couple of times here. Okay, so let's reload here just to make sure that everything is working. And now what we see is that it didn't log I can drive to the console, even though we attempted to set has driver's license to true here. And so we expected that driver's license being true should then log I can drive. But it didn't work. And that's because of the mistake that I just introduced here on purpose for getting this S. So without the error, it should work, right? But without it, it's not gonna work. And again, because basically here I set a new variable to true and not the original one. So this one is still false, and that's why here this logging does not happen. So now our program has a bug, which means that it has a mistake, and we would now go ahead and find that bug. But strict mode can actually help us with this. So let's turn it back on, give it a save, and now try it again. And now we actually get an error. So here we see that has driver license is not defined. So in line number 6, which is right here. And so this error message now tells us exactly what is wrong. So it tells us that this variable is not defined. And then we can see, oh, we did a mistake here. We're missing the S, right? So now it's the same variable here, here, and here, okay? And so if we try that now again, then the error is gone. And so strict mode really helped us avoiding this kind of bug that we created here. And you can experiment a little bit with this to make it really clear. Now, another thing that strict mode does is to introduce a short list of variable names that are reserved for features that might be added to the language a bit later. For example, let's try to define a variable called interface. For example, for an audio interface. And now if we try this, then we see that we get an unexpected strict mode reserved word error message, basically. And that is, again, because JavaScript is reserving this word here for a feature that it might implement in the future. And so by reserving this kind of words, it will then make it easier to implement the feature in the future. So another one is private, for example. So const private just some number here. And so this one will also not work. And that's because in the future, there might be something called private fields in classes or in some other places, even in the language, and they might want to use this word for that. And so strict mode reserves these words so that we cannot use them for variables. It's the same logic as this one. So we cannot call a variable if, right? And that's because there is already an if statement. So here we get unexpected token if. And so that's like the rules that I explained to you in the beginning about naming variables. Okay? All right. Now there are actually a lot of other changes that affect things that we haven't learned about yet. So that's stuff like functions, objects, setting properties on primitive values, and many more. And I will mention them in future lectures when the time comes. But everything that I'm going to say in the rest of the course from now on will always assume that you have strict mode turned on. And so I will add this line of code here to all the scripts in the future, and so you should do the same. Anyway, with this out of the way, let's now start learning functions. The fundamental building block of real-world JavaScript applications are functions. They are one of the most essential concepts in the language, and so let's study functions over the next couple of videos. So, what actually are functions? Well, in the most simple form, a function is simply a piece of code that we can reuse over and over again in our code. So it's a little bit like a variable, but for whole chunks of code. So remember, a variable holds a value, but a function can hold one or more complete lines of code. So let's now declare our very first function. So we start with the function keyword, and then we define a function name. And let's now just create a simple logger, which is a function that will simply log something to the console. So I will call this one logger, and then we need parentheses, and we will see why in a next example. And then we use the curly braces to create the so-called function body. So all the code that is within this code block here, so within this block of curly braces, is called the function body. And it's this code that will be executed when we run this function. So let's say we needed to execute a log many times somewhere in our program. So let's simply console.log. My name is Jonas. And so somewhere in our program, we needed to reuse this line of code here multiple times. And so that's why we put it in a function. Okay? So we created the function, and now we can use it. And we can use it as many times as we want. So to use the function, we simply write the function name followed by parentheses, and that's actually it. And this process here of basically using the function is called invoking the function, running the function, or calling the function. So let me actually write these terms here. So calling, running, or invoking the function. And you will see me use these three terms here interchangeably. Okay, so they basically mean the same thing. You can think of them as like executing or using the function that we defined previously. Okay, and as I said, we can now use or call or run this function as many times as we want. And each time that we call the function like this, then the code that is in the function will get executed. All right, so in this case, what should we expect here? Let's see. And indeed, we get this my name is Jonas log 3 times because we called the function 3 times. And so this line of code here was executed 3 times. Great. So we just wrote our very first function and it's already working just fine. And I hope that this logic of reusing code makes sense to you. But let's now take it to the next level and really use some more functionalities of functions, because they can do a lot more than simply reusing a line of code like we did here. So usually when we write functions, we also pass data into a function. And additionally, a function can also return data as well, which means to give us data back that we can then use for something else in the program. So a function can not only reuse a piece of code like we did here, but it can also receive data and return data back. And so I like to think of functions as machines. So I think that's a great analogy. So for example, let's imagine a food processor. So we put food into the processor, then the processor does something to our food, which is the function body basically. And then in the end, the food processor returns the processed food, for example, a juice. And so that's exactly what we can do with functions as well. And actually, let's implement exactly this example. So again, we need to use the function keyword, and then we choose a function name. And just like with variable names, we should choose descriptive function names so that we know exactly what they do. So let's call this one a fruit processor. But in this function, we also specify something called parameters. And parameters are like variables that are specific only to this function. And they will get defined once we call the function. So let's give this fruit processor function two parameters, apples, and then a second one separated by a comma called oranges. And again, these two will get defined once the function is called. And they represent the input data of this function. Okay, and this will make even more sense when we then actually call this function. And let's start by logging these to the console. So apples and also oranges. And so what I'm doing here is to basically use these parameters here, so apples and oranges, just as if they were normal variables here inside this function. And now let's actually do something more interesting with these parameters. And so we want to kind of simulate that this fruit processor produces a juice out of the apples and oranges that we give it. And so let's just create a string which says that. So I'm going to create a variable called juice and then a template literal. And I'm going to say juice with, and then I'm using actually the apples parameter here. So apples and then apples, because this apples parameter will be a number once we call this. For example, if we set apples to 3, then the string will be juice with 3 apples. And again, this will really make sense once we call this function. So oranges and oranges again. Okay, so here we build a string using the input data that we get into the function. And now comes the really cool part, because now we can use the return keyword. And with this, we can return any value from the function. And so let's actually return the juice that we just produced. And so this value that we then return can be used anywhere later in our code. So basically, this juice will become the result of executing this function. And let's actually do that. So let's call or run or invoke this function now. So fruit processor. And now we're going to specify the actual values for the parameters apples and oranges. And so let's say, for example, 5 apples and 0 oranges. Okay, and so these now will be the inputs of the fruit processor function. So you can think of these parameters here like empty spaces that we still need to fill out when we are writing the function. And when we call the function then later in the code, here at this point, we then fill these blank spaces by passing in the real specific values, which will then get assigned to the parameters. In this example, apples will become 5 and oranges, which is the second parameter here, right, will become 0. And these actual values here of the parameters are called the arguments. All right, So let's now basically run this script. And so now we get 5 and 0. So this is coming from line 26, which is this line. So it's this logging to the console of the apples, which is 5, and oranges, which is 0. And apples are 5 because that's the value that we specified here. Okay? So we specified apples as 5, and so in this function, the apple parameter, or you can think of this parameter as a variable, is now 5. And oranges is of course 0. But now you might wonder, what about the juice that we just produced here? Where is it? Well, the juice was returned from this function. So basically that means that the result of running this function here is the juice that we just returned. Basically, once this function has been executed, this code here is then replaced by the result of the function. And in this case, that's going to be the juice string that we produced. So if we want to use that value that was returned, we need to store it in a variable. So let's do that. So let's call it apple juice. And then let's log that to the console. Reload it here. And now we get juice with 5 apples and 0 oranges. So let's recap again what happened here. So we called the fruit processor function here with 2 arguments, 5 and 0. And these arguments are the specific, so the actual values of the function's parameters, which are apples and oranges. And so when the function is running now, apples in here will be 5 and oranges will be 0. Then we use these values to build this juice string here, and then we return that value from the function. And what that means is that basically the result of calling this function here will be the juice value that was just returned. Okay? And then we need to save that value somewhere. We need to capture it. And we do that by basically saving it into this apple juice variable. And then we can simply log that value to the console. Of course, we could have also directly logged it to the console. So basically without capturing the value anywhere and simply logging it. So let me just copy this one here. And so if I run this now, we should see the same string twice. And yes, indeed, now the fruit processor function was executed twice, once here and once here. The only difference is that in this case here, we did not capture the value into any variable. We simply logged the result of running this function to the console directly. Okay, so just to show you the difference. Okay, and now thanks to the power of the function, we can reuse the function with different input values and then get a different output. So let's try that, and let's create a apple and orange juice. So apple, orange, juice. And so this time we can call fruit processor, let's say with 2 apples and 4 oranges. So once again, we are defining specific values here, which are the arguments, which will get passed into the function here as these parameters. So essentially what we did here was to create a very generic function that works for any number of apples and oranges. So it's really like we're leaving apples and oranges as the blank spaces. And then when we call the function, we fill in these blank spaces using our arguments. So 2 and 4 in this example. And now we can also then log the result. So apple, orange, juice. And actually we can get rid of this console.log here because we don't really need it. All we want here is to produce this juice and then return the juice from the function. Okay, and so now we get 2 juices, one with 5 apples and 0 oranges, which is this first one, and then finally the juice with 2 apples and 4 oranges. And so that's the second one that we just produced. And of course, we could run this function as many times as we wanted. But we should call it at least once, because if we never call the function, then the code that's in the function will never be executed. And that makes sense, right? So without executing the function, it's kind of useless, because the code will never run. It will never be processed, because that only happens once we call the function like this. Or like this here also. So as you see, this function here has no parameters. And so here, when we call the function, we do not specify any arguments. We could do that. So let's just pass 23. But since there are no parameters, it will not get used. And so specifying the argument here or not will not have any effect. You see that this function here also doesn't return anything, and that's not a problem at all. Not all functions need to return something, and not all functions need to accept parameters like the fruit processor that we have down here. So this is a very simple function here, and this is a more complete example showing you everything that we can do with functions. And this kind of function is actually way more usual than this simpler one here. So a function like this without parameters and without a return, we really only use when there's a block of code that we want to reuse over and over again. Once more, keep in mind that this function does not return anything. All it does is to log something to the console, but that has nothing to do with returning a value. This really only prints a message here to the developer console, but it doesn't return a value. So basically, this here does not produce a value because we don't return anything from the function. And that's why here we also don't save the result of the function to any variable, because it doesn't produce any result. Well, technically it does produce undefined, but that's not really relevant here. And so of course we don't capture that undefined value. Okay, great. And that's basically the fundamentals of functions. And I'm pretty sure that this was confusing for you if this was your first contact with functions. And actually, that's probably how it's supposed to be. So what I want you to do is to review this lecture very thoroughly and really understand how all of this works together. So how writing this generic function with the parameters works together with then calling the function with the specific values, and how the function then returns a value, and how in the end we then receive that value here and capture it into this variable. So that's what I want you to think about and to analyze. All right. So as a conclusion to this lecture, we can say that functions allow us to write more maintainable code, because with functions, we can create reusable chunks of code instead of having to manually write the same code over and over again. So that's the most important thing that you need to know about functions. And when you know that, you will know when you should actually use functions. And this is actually a very important principle for writing clean code that is used in programming all the time. And this principle is called don't repeat yourself, or dry. So we say that we should keep our code dry, which means that we should not repeat ourselves. And so functions are perfect for implementing dry code, because they are reusable code blocks that together make up our applications. And of course, we will use functions throughout the rest of the course because, as I said in the beginning, they are a fundamental building block of JavaScript programs. Oh, and by the way, you can now understand that console.log here is actually also just a function, but a built-in function that we do not have to write ourselves. But you see that we just call it like our own functions. So we call it using the parentheses here, and then we pass in a value. So apple orange juice. And the result of calling the function is simply this message then appearing in the developer console. And the same is true for the function that we used to convert a string to a number. So this is another built-in function that takes this 23 string in this case as a parameter. So we pass this argument into the function, and this function will then be executed and return the string as a number. And then we can save that like we did before. Okay, so this is going to work just the same. Oh, and of course, we cannot see it, but we can still check it out by writing num. Okay, but now anyway, I will leave you to really analyze how all of this logic here works that we just wrote. So do that now, and only once you fully understand how this example works, move on to the next video. Welcome back. So I hope that you studied the last lecture really well, so that you really understood what we did there with our food processor function. Now, in JavaScript, there are different ways of writing functions, and each type of function works in a slightly different way. But don't worry, they are still all very similar. So let's find out now. So the functions that I showed you in the last lecture are called function declarations, because we simply use the function keyword to declare a function, a bit like we declare a variable. So let's now write another function declaration, and this time a function to calculate an age based on a given birth year. So let's again use the function keyword, and we're going to call this one calc age 1, and that's because we're going to have another one later. So as I said, we want the person's birth year as an input to this function. And what is an input? Well, it's just a parameter in this function. And a parameter, remember, is a bit like a local variable that's only available inside of this function. Then the function body with the curly braces, and now the code that we want to create here. So how do we calculate an age? Well, just like we did before, we take the current year, which once more, let's suppose it's 2037, and then minus the person's birth year. And then remember to take this value now out of the function, we return it using the return keyword. So we calculate the age first, and then we return that value. And actually we can simplify this and basically return all in one go. So there's actually no need to store this value here in a variable if all we do is then later return that value. So in fact, we can just take this value here, get rid of this, and then simply return the result of this expression here. So basically of this operation. Okay? So we're taking the birth year that we're going to receive and then use that to calculate the age. And so once again, this is a generic function which is then going to work for any birth year that we give it. So of course, let's now call or invoke or execute this function. And again, I can use all of these three words interchangeably. They all mean the same thing. So calc age 1, and then remember to call the function, we use parentheses, and then we specify the actual value of the parameter, which is called the argument. Remember? So let's say 1991. Now some people use the words arguments and parameters as if they were the same, and actually that's not a big deal, but to be really precise, the parameter is, again, the kind of placeholder in the function, and the argument is then the actual value that we use to fill in that placeholder that is the parameter. Anyway, this will now create a value, right? And the value that this will create is the value that's returned from the calc age function. So basically this returned value. And so, once again, we need to capture or to save that value into a variable. So let's call this one age1. And just to make sure that it works, let's quickly check it out in the console. Okay. And indeed, we get 46 just like we did before. Okay. So that is a function declaration. But now let's create a function expression. So that's the other type of function that exists, and it looks like this. instead of writing a function with the calc_h name, we simply write function basically without a name, and then we still define the parameter. We still define the function body, which is going to be the same as this one, because we want another calc_h function here. So we write the function like this, and then what we have to do is to store all of this here into a variable. And that variable will then be the function. So let's call it calc_h2. So again, we did write the function in a very similar way, but we didn't give it a name here. So it's a function without a name, basically, which is also called an anonymous function. So all of this here is basically an expression. And remember that an expression produces a value. And so we use that value and store it into calc_h2. And this will then be the function. And I know that sounds very confusing, but it will make sense, trust me. Now, to call this function, we actually do it in the exact same way. So let's do h2 equals calc_h2, and let's use 1991 again. And then let's grab this console.log here and log both the ages. So h2 here. Let's also add some comments here. Function declaration and function expression. And so we should get twice the 46 value here. And yes, indeed. So the function expression works the exact same way as the function declaration. So we call it in the same way, we capture the returned value in the same way, and then of course the result is also the same because the function body is the same. But it's very important to know that we have these two types of functions in JavaScript, because in some places we will actually need to write them like this, as you will see as we go through the course. So again, this part here that I just highlighted, this function here is in fact an expression. And remember that expressions produce values. And so we just assign this whole value here then to this variable. And so this variable will then hold this function value basically. And one big implication of what I just said, so that this here is just a value, is that in fact in JavaScript, functions are actually just values. So just as a number or a string or a Boolean value. So a function is not a type, okay? It's not like a string or a number type, but it's also a value. And so if it's a value, we can store it in a variable. So just keep this in mind because it will become very important later when we really dig deep into functions. Now, besides these technical differences, you might be wondering, what is the big deal? So what's the big difference between function declarations and function expressions? Well, the main practical difference is that we can actually call function declarations before they are defined in the code. So let me show that to you. So here is the declaration, right? This is the function declaration. And as I just said, we can call them in the code before they are defined. So now we're calling it first and then defining it later. So let me show you that that still works. And indeed, we still get the same result. But if we attempt to do the same with the expression, then that should not work. So let's see. And so cannot access calc_h2 before initialization. Okay. And internally, this happens because of a process called hoisting, but more about that in a future section. Okay. For now, just keep in mind that you can call a function declaration before you define it, even though that might not be such a good idea in many cases. But you can do it if necessary. All right. Now, another question that you might have in your mind is, which of the two types of functions should I use when I write my own functions? And well, The answer is that oftentimes it's really just a matter of personal preference. And so different developers prefer different formats. Personally, I prefer to use function expressions because this then forces me into a nice structure where I have to define all the functions first at the top of the code, and only then I can call them. So this makes the code a little bit nicer and more structured. I also like to have everything stored in variables, so both values and functions. But again, that is just my own personal preference, and many other developers don't agree with this and prefer to use function declarations. So if you also prefer function declarations, that's fine. So just use declarations then. It's absolutely no problem. However, even if you prefer one over the other, you still need to know about both the function expressions and function declarations. So you cannot just pick one and then forget the other one, because both have their place in JavaScript. And so it's really important that you know how to use and how to distinguish both function declarations and expressions. So we learned about function declarations and expressions in the last video, but there is actually a third type of function that was added to JavaScript in ES6, and that's the arrow function. And an arrow function is simply a special form of function expression that is shorter and therefore faster to write. So let's actually get back this function expression from before here, so from the previous lecture, just so that we have a comparison, so like a reference point. And so now let's write the arrow function. And this is how we write an arrow function. So again, we want the birth year because we want to calculate the age again. And then we write an arrow. And that's the reason why this function is called arrow function. And then we simply write what we want to return. So in this case, that's 2037 minus the birth year. And that's it. Now to finish, we actually want to be able to use this function. So let's again store it in a variable, just like we did here with this function expression. So let's say const calc age 3 this time, and then we set that variable to this function here. Okay? So as I said, this is a special form of a function expression because it still is a function expression actually. So it's a value, all of this, that we assign to this variable. So just like this function expression up here. But this one, as you see, is a lot easier and faster to write. The first reason for that is that we don't need the curly braces, like we have here to define a code block. And second is that the return actually happens implicitly. So this value here will automatically be returned without us having to explicitly write the return keyword. Okay? So this is excellent for simple one-liner functions. And you will see throughout the course that this is going to be extremely helpful in certain situations. And now to use this function, it of course works the exact same way as using all the other functions. So we call calc age3 just like we called the other calc age functions. Okay. And again, we save the returned value here to a variable. And then let's just check it out here. And so this one should be 46 again, just like we had in the previous lecture. And yeah, it works. So indeed, the value that we calculated was returned automatically without us having to write the return keyword. And you see that here we also didn't need any parentheses or anything like that. Just this here is the function. Okay? Now this is actually just the simplest form, which is when we only have exactly one parameter and only basically one line of code in which we want to return something. But it gets a little bit more complex when we add more parameters or more code. So let's now write another function, and we can get rid of this one since it was just a copy anyway. And so let's say that we want to calculate how many years a person has left until retirement. So let's call this function years until retirement. And then we set that equal to a function. And once again, let's pass in the birth year. Then the arrow again. But now here we need some more code. Because to calculate the number of years until the retirement based on the birth year alone, we first need to calculate the age. And then from there, we need to calculate the retirement age minus the current age. So we need more lines of code. And so we are back to actually needing the curly braces in order to define a code block like this. So let's do what we just said. So calculate the age based on the birth year. So 37 minus the birth year. And now let's calculate the years until retirement, basically. And so let's say that the retirement age is 65 years, as it is in many countries, here in Europe at least. So 65 and then minus the current age. And that will then give us how many years we have left. And now to return this retirement, we actually need to write the return keyword explicitly. So we can only omit the return here in case we have a one-liner function like here. But if we have more, then we need to do the return still. So let's now run this function. So years until retirement, and then again some year. And then, as always, we could capture the return value into a variable. But this time, let's actually log that value to the console directly. So console.log, and yeah, so let's try that. And so it's 19. So, and that makes sense because 65 minus 46, which is the age, is 19. Okay, so that's the scenario when we have one parameter here and then more than one line of code, basically. And remember, in that situation, we need the return statement here. But now, what if we had multiple parameters? Well, then we need to wrap the parameters here into parentheses. So in VS Code, we can just select a variable and then write parentheses, and then it will automatically wrap this variable into parentheses on both sides. So let's say that we want the birth year, but also the first name, so that we can like return something else, like a sentence. So let's comment out this part here, and instead let's return a string. And again, we're using a template string here to build that string. And basically I want to say like first name retires in X years. So let's use that placeholder here. So first name retires in, and then we use that value that we just calculated. So retirement, give it a save here, and now we need to call it. And so let's add the second argument here so that it will go to the second parameter. So the first one here is of course birth year, and so that corresponds to 1991. And now the second argument will go to the second parameter, which is the first name. So let's say Jonas, and let's just call it twice, so that it actually makes more sense that we even put this logic into its own function. So let's say that Bob was born in 1980, and so let's see how many years he has left. So Jonas retires in 19 years, Bob retires in 8 years. Great. And that's essentially how the arrow functions work. You just need to keep in mind the couple of different scenarios that there are regarding to the number of lines of code that you need and the number of parameters. So as you add more code and more parameters, it gets a little bit more complex, and we kind of lose the advantage of using an arrow function. So now you might ask the same question as before. What type of function should I use? Should I use arrow functions for everything since they are so easy to write? And well, the answer is no, but it's also complicated. That's because there is another fundamental difference between the arrow function and more traditional functions. So function declarations and function expressions. It's the fact that arrow functions do not get a so-called this keyword. And this, once more, is a topic for much later. So remember that learning is not at all a linear process. And so topics need to build up on one another in an incremental way. Otherwise, you would just get super overwhelmed and super stressed if I were to tell you everything at the same time. So for now, we will actually keep using mainly the normal functions, except for very simple one-liner functions. For example, like this one here. And that doesn't mean that arrow functions are not important. They absolutely are, and I love them and I use them all the time. Sometimes I don't write regular functions at all. But again, you cannot yet understand all the implications of using arrow functions. So for now, again, we will keep using probably the function expressions the most. Let's now take functions even one step further and calling one function from inside another function. And this is something that we do all the time in JavaScript, but I have seen many beginners struggle to understand this logic. And so I created a specific video just for this topic. And to illustrate functions calling other functions, let's go back to our initial example of a function being like a food processor. So let's move to the first functions lecture, which is this one, and simply copy this function. So remember that we had this function, which was like a fruit processor, which received a certain number of apples and a certain number of oranges. And then based on that, it basically produced and returned a juice to us. But now in this example, let's consider that the fruit processor can only make juice with smaller fruit pieces. And so before making the juice, the food processor now needs another machine that first cuts the fruits that we give it into multiple smaller pieces. So I hope that's not an example too silly, but I think it makes sense actually to understand the point that I'm trying to make. So let's actually start by writing that machine. So basically that function that cuts a fruit into multiple pieces. So let's say function cut fruit pieces, and then this function will receive a fruit. And all this function will do is to return the fruit cut in 4 pieces. So basically, fruit multiplied by 4. So if we get 2 apples here, it will return 8 pieces to us. So simply the number 8. Okay, so that's our machine that cuts the fruit in pieces. And now here in the fruit processor itself, we receive the apples and oranges, and then we're going to use our newly created machine to cut the received apples and oranges into pieces. And so let's do that. So we start by calling cut fruit pieces in here with the number of apples that were received. And the result of calling this function, we will then capture into a variable called apple pieces. Apple pieces. Okay? And now let's do the same for the oranges that we receive. So orange pieces will be also cut fruit pieces, but we call it with the oranges. Okay? And so for the first time now, we called one function inside of another function. So if we now call fruit processor with 2 and 3, then this will call the fruit processor function, which then in turn will call the cut fruit pieces function. And actually twice. So once here and once here. And so let's now actually analyze how the data flows between these functions. So down here we are calling the fruit processor function with the arguments 2 and 3. And as we already know, this will then replace the apples parameter in the function with the number 2 and the oranges parameter in the function with the number 3. So that should be nothing new at this point, right? We are simply replacing the parameter placeholders with the actual values 2 and 3. And now let's analyze what's going to happen with these apple value. So apple right now holds the number 2. And that value 2 will then be used to call the cut pieces function, right? Now, as we call cut pieces, this 2 is actually the argument for the cut pieces function. And it will basically replace the fruit parameter, so the fruit placeholder, okay? So now fruit here in this cut pieces function is also 2. And I hope that these arrows here make the data flow quite obvious. Then inside this function, of course, the fruit is then also 2, which will get multiplied by 4. And so the result here is going to be 8. And so the result of calling this cut pieces function with apples will be 8. And so that's the value that we then store into the apple pieces variable. And from there, we will then build this juice string that we have down here. Okay? So take a moment and analyze exactly how the data flows from one function to another, because I know that it can be a little bit confusing, especially calling the cut pieces function here without a tangible number. So we're calling cut pieces here not with an actual number that we wrote ourselves, like 2 or 3, but really with the argument that we received into fruit processor. So that can be a little bit confusing, so take a second to understand exactly what happens here. And what happened here with the apples variable will of course happen exactly the same with oranges. And so I'm not going to go into that part here, because that would be too confusing having all these arrows here on the slide. But of course you can analyze that for yourself and see exactly what is going to happen. But now let's move back to the code to see how this actually works out in practice. And so now we need to change this juice string here. So in the function that we just saw, it was already complete, but let's now write that out ourselves. So here we used to have apples, but now we want to use the apple pieces value. So apple pieces, piece of apples, and then here we want orange pieces of orange. So orange and apple here. Okay, so here we call the fruit processor function then, just as I explained in the slide. And then let's simply log the result to the console. There is no need in this case to store it into a variable. Okay, and so again, this works because the result of calling this function will become this string here that we return from the function. And so then console.log works with that string. So let's try that. And indeed, we get a juice with 8 pieces, which is 4 times 2 here, and then 12 pieces of orange, which is 3 times 4. And so that works just as expected. Great. So I think that was a really great example to illustrate this mechanics of one function calling the other. But now again, you might ask the following question. Why not simply multiply both of the input values by 4 and call it a day? So we could do that, of course. We can say apple pieces equals apples times 4, and orange pieces here is oranges times 4 as well. Well, but we did it this way for, well, multiple reasons. First, the point that I'm making here is that it's very common for one function to call another function. So just like we did here. And second, this is also a very good example to illustrate the don't repeat yourself principle that I mentioned earlier. So the dry principle. For example, imagine that suddenly the cutting machine would cut in 3 pieces and not in 4 pieces. Then if we didn't have the separate cut fruit pieces function, we would have to change the code in multiple places. And this is not a problem, of course, with 2 lines of code. But if we needed to cut like 10 fruits into pieces, then we would have to change that in all the places, and that would simply be annoying, and it could also be a source of bugs, so of coding mistakes. And so it's a lot better to put that functionality into its own function. So if the fruit was now only cut in 3 pieces, all we have to do is to change it here, and that's it. Then this changes to 6, which is 2 times 3, and this changes to 9, which is 3 times 3. Okay? So I hope that made sense to you, and that you can start internalizing this kind of logic. With time and practice, you will exactly know when you should create your own functions and when to have multiple functions, one calling another. Great. Once more, congratulations for all the progress that you're making here. Working through these lectures about functions can be a lot of work, I know, and it can be sometimes a little bit confusing. So you're making great progress, and it's great to see that you're already at this point of the course. So again, functions is a very important topic, and so in the next video, we're going to take a couple of minutes to review the fundamental principles about functions that we just learned here. So stay tuned for that one, and I see you in a minute. To finish this part about functions, let's review everything important that we learned so far, in order to make sure that you really understand functions before we move on to other topics. And let's start by bringing back and rewriting the function that we wrote before, which is the years until retirement function. So I think that was, it was here in the lecture about arrow functions. So let's copy this one and paste it here. And the first thing that we're going to do is to actually convert it to a more normal function expression. So how do we do that? Well, in this case, we simply get rid of the arrow here and then write the function keyword here. And so now this is just a regular function expression like we learned before. Next up, we could export this functionality here into another function. So like a calc_h function that we've been using before. So let's do that, because then we can do what we did in the last lecture, which was to call one function inside of the other function. So let's write another function expression here, calc_h equals a function, and then the birth year again. And what we return from this one is simply 2037 minus the birth year. So we already did that before, right? Now you might find it confusing that we have 2 different functions here with the same parameter names. So this one has birth year and this one has 2, but that's not a problem at all. So this birth year in this function is not at all related to this birth year in this function. They are 2 completely different parameters, so basically 2 different variables. We could even have a variable outside of any of the functions, which could also be called birth year. Okay, and we could do that now, but I don't want to confuse you even further. Okay, but what matters here is that this parameter is really like a local variable to each function. Anyway, let's now go ahead and delete this here, and instead calculate the age based on the function that we just wrote. And actually we just delete this part here. And so now the age will come from the function calc_h, and what we pass in here is the birth year. So again, it's confusing now with these same parameter names here, but let's quickly call this function just so I can quickly show you the data flow. So years until retirement with birth year 1991 and first name of Jonas. So 1991 will be the birth year here in this function. Then as a first step, this years until retirement function calls calc_h. And it calls calc_h with the argument of 1991. So this one here. And so then birth year in this function also becomes 1991. And so then here the operation will be 2037 minus 1991. And if you find it less confusing, we could change this year to something else. Let's just say year, and it would work the exact same way. Okay, so again, these variable names in these two different functions, they do not have anything to do with one another. All right, but let's actually put it back here because it's good to keep this in mind. Down here, let's actually go back to returning a number and not this string, which for now I will just comment out. So here we call this function, and once more, I'm not going to store it into a variable. So we will just log the result of this to the console. So this should be just like before, 19. Okay, but now I want to show you something, which is to call this function again. Let's say now with Mike, and let's say Mike was born in 1970. And so his years until retirement will be 2. So a negative number, which means that he already retired. So let's quickly account for that. So what we will do is to basically return this number if it is above 0, and if it is below 0, we are going to return something else, like -1 or something, or some special number. So instead of returning simply the retirement, let's take a decision here based on the retirement value. And so that's something that we learned in the last lecture. So let's use an if-else statement and say, if the retirement is greater than 0, so if there are more than 0 years left until retirement, then return this retirement value. Okay? So remember that in the if block, we can put any code that we want. And so that includes the return statement. And else, well, let's just return always -1. So -1 is kind of a standard number in programming. We could also like return like this. So a number that shows us clearly that this has no meaning. Let's just keep it at number 1, minus number 1, okay? And I'm returning actually numbers here and not a string as we had before, because that's usually what we do, especially when we actually receive a number as an input. So here in this function, we get birth year here as an input, and it's a number, and therefore it's a good practice to then also return a number. Okay, let's try this again. And I would even change it to something more drastic. So 1950. And let's see what we get now. Yeah, so it's -1 now. Great. Now, one thing that I didn't mention yet is that this return keyword here will actually immediately exit the function. So it will first return the value that we tell it to return. So in this case, the retirement value. And then after that, the function is done. So it exits immediately. And we also say that the function has returned. So let me actually demonstrate that to you. And what I will do is to take this string here. Now we can get rid of the rest. And I will put that after the return. So we will log to the console this string here that we just had. And then here, let's log simply the first name has already retired. And then we can put another emoji here, like this party emoji that I like. And yeah, what do you think will happen when we run this code now? And keep in mind that we have the return before the console.log in both cases. So in the if block here and also in the else block. So what do you think is going to happen with these console.logs? Well, let's see. And indeed, they are simply ignored. So they will not get executed because, as I said before, the return statement immediately exits or immediately returns the function. And so therefore, there's no chance that this code here is even reached. So if we want this one here to execute, we need to put it before the return. And in VS Code, I can simply hit Option or Alt up. Okay, and that will then move the line up. So we also have that here somewhere in this menu. So that's move line up and move line down. So just so you see which one is the shortcut. So I use that one all the time. I also use add cursor below all the time. And I also use add next occurrence. So that would be Command or Control D. So what this means is that we have, if we have this, for example, here selected, then we can already see all the other ones. But if we hit Command D, then it will actually select that. So you see, now we have these 4 selected. And so we now could replace all of them at the same time. For example, like this. Okay. But anyway, let's go back to what we were doing here. So I just moved the console.log before the return here. And so now there should be a chance that the console.log is actually executed before the value is returned. And so let's do the same here. So again, I'm hitting Option or Alt up. And so these 2 lines changed position. And now, now it works. So we get the string, and here we get Mike has already retired. Okay, so this was to show you some more things about functions that we had already learned, and also show you something new, which is the fact that the return statement here immediately exits the function. So we reviewed already some things here, but now it's time to really review everything that we learned so far about functions in these first couple of lectures. And here we have the 3 types of functions that we talked about. So we have first the function declaration, and one particularity about function declarations is that they can be used before they are declared in the code. Second, we have the function expressions, and they are essentially function values that are stored in a variable. And finally, we have arrow functions that are in fact also function expressions, but special ones. And these are great for quick one-line functions where we don't need to explicitly use the return keyword and no curly braces either. I also said that this one has no this keyword, but more about that in one of the future lectures. Now, what's important to note here is that these are 3 different ways of writing functions, but they all work in a similar way. So all of them can receive input data, they transform data, and then they can output data. It's all optional, but usually that's the things that functions do. And no matter which type of function we use, we can always do these 3 things. And now let's zoom in a little bit further and take a close look at the structure of a common function, let's say. And this one here is a function statement, but it works the exact same way for all other types of functions again. So first, usually a function needs a function name. So calc age in this example. Then a function also has parameters. And these parameters are essentially placeholders that receive input values. So as I said before, these are a little bit like local variables of a function. So variables that are defined only inside of this very function. Now, as you also already know, we use functions to reuse pieces of code. And these pieces of code are inside the function body. So this is where the function's input data is usually processed and then returned. And speaking of the return, by the end of the function, we usually have a return statement, which we use to output a value from the function. And also, as I mentioned a little bit earlier, the return statement also immediately terminates the function's execution. We also say that the function returns. Okay, and now about calling the function. We do that using parentheses. So we write the name of the function like we did here with calc_age, and then with the parentheses, we call the function. Because without the parentheses, the function is really just a value. But then with the parentheses, we actually call the function. And we can also say that we run the function, or invoke the function, or execute the function, and all of these terms kind of mean the same thing. Now in this case, since the function actually has parameters, we then call the function with arguments. And these arguments are the actual values of the function parameters. So we use these to input the actual data into the function. And we can also imagine this as replacing the placeholders that are the parameters. Then, once the calc_h function has finally done its job, then all this expression will basically be replaced with the returned value. So in this case, the h that was replaced here. And that h value is what we then store into this h variable. So we use this variable to basically save the returned value that was outputted from the function. Okay? Now, just one other thing that I want to make clear is that this console.log that we have in the function, so in that first line there, has nothing to do with returning a value. This simply prints a message to the developer console, but it has nothing to do with returning. So actually, the console.log is actually just another function call inside the calc_h function, because console.log is itself a function. And so the argument that we pass into the console.log function is what will get printed to the developer console. Okay, so just wanted to make sure that you really get this distinction between console.log and return. The reason why we always use console.log is because we want to see the results of our experiments in the developer console in the browser. Anyway, I think this pretty much sums up all there is to know, at least for now, about functions. So make sure that you got all of this down, and then you can move on right to the next video, where the first coding challenge of this section waits for you. And as you can probably guess, it's going to be about writing your own function for the very first time. So I hope to see you there soon. So let me show you my solution to this challenge, which I hope, of course, you were able to do on your own. So I'm going to start with the calc_average function, as in number 1. And remember that this should be an arrow function, and it will receive 3 values so that it can calculate the average of these 3 numbers. And here I'm actually just going to call the 3 numbers a, b, and c, because again, this is supposed to be just a generic function which can calculate averages of any 3 numbers. It doesn't have to be any scores. And so a, b, c are just generic variable names. But of course, it's totally okay if you used more specific variable names. So adding all the 3 numbers together and then dividing by 3. So this one is nothing new. This was just to basically test your knowledge of the syntax of the arrow function. So what's important to notice here is that we need the parentheses here because we have multiple parameters, but then here we only really have this line of code. And so therefore, we don't need to even write the return. This value gets automatically returned from the function. And now let's just test it out before we move any further. So calc_average, and then let's just use some random numbers, because here we know that this is supposed to be 4, right? So we have 3, 4, 5, and so the middle one here is the average between these 3. And indeed, it is. And so we know that our function works. And so we can move on to point number 2, which is to use the function to calculate the average for both teams. So let's say score Dolphins is equal to calc_average, and now we pass in the specific arguments for the 3 parameters a, b, and c. And so for test data 1, which is this, so let me actually write that here, test 1. So for the Dolphins, we pass in the values 44, 23, and 71. Then for the koalas, it works the same way. So score koalas equals calc_average. And now we have 65, 54, and 49. So nice reusable function right here. And so having this function, we don't need to calculate it here manually every single time. So that's really great. So we can really appreciate the fact that, again, a function is really like a machine in some sense. So it doesn't care where the inputs come from and where they go. All it does is to calculate the average of three numbers, no matter if it's scores or heights of people or money or whatever it is. So this function really is kind of isolated from the rest of the code here. It's a standalone function that we can then use for our own purposes. And that might sound pretty obvious, but it's actually important that you really internalize this aspect of functions. Only then can you really start to see the potential for functions everywhere in your code. Anyway, with that being said, let's now log these values to the console, because I always like to see what I'm doing. So this part is of course not mandatory, but it's also nice to be able to know these scores so that we know if the logic that we're going to implement next is working correctly. So we see that in this case, the koalas have a score that is higher than the one of the dolphins, but it's not double. And so we already know that in this case, no team should be able to win. But let's now actually implement that functionality. So that's the function check winner. And so it takes the average dolphins and average koalas parameters, okay, and then it logs the winner to the console. So let's do that. And once more, it's no problem if you did this differently. If you made it work, then it's great. So average dolphins and average koalas. And now all we need to do is to check whether the dolphins won or the koalas won, or if no one won, basically. So when do the dolphins win? Well, they win if they have double the points of the koalas, right? That's the condition. So again, a team only wins if it has at least double the average score of the other team. And so that's why I told you here in this hint that this is how we check for that. So A has double the amount of points of B if A is greater than 2 times B. So let's do that. So average dolphins greater or equal to 2 times the average koalas. And in this case, we log to the console dolphins win the trophy. So let's use an emoji here again, but you don't need, of course, to do that. So it's already here. And now it also told us to put the points. So, for example, 30 versus 13. So both points with the verses in between. So that's average dolphins versus average koalas. So you see that here we are also practicing all the other skills that we already acquired before, especially in the previous section, right? Okay, and now here we just need to do the opposite. So else if, and now if the koalas have at least, so that's basically what this one here means. So greater equal is basically at least. So if average koalas have at least double the points of the dolphins, then the koalas win. So let's just grab this one from here. Koalas, and here it's average koalas and then average dolphins. Average, yes. All right. And now in any other case, we say that no one wins. So I think that's also said in the rules. Yeah, that's number 5. I think I even forgot to tell you this one, but hopefully you read it. So you should ignore draws in this exercise this time. So if none of these is true, we simply say that no team wins. no team wins. Okay, and now all we need to do is to call this function here. So check winner, and we will do that with score dolphins and score koalas. Okay, so let's recap. We calculated the score of the dolphins up here and of the koalas as well. And now we call the check winner function here, okay? And we use as arguments the scores that we calculated before. And then score dolphins will become average dolphins here in this function, because that's the name of the parameter. And I see that I misspelled this. And so now I can use that Command D that I talked to you about before. So I can select all of them. So Command D, Command D, Command D, Command D. And now I can use all of these cursors here at the same time. So dolphins. You see, I inserted the P in all of the variable names everywhere. All right. And so now this parameter name here gets used for all these calculations. And again, originally this value comes basically from here, from calculating the average of these three scores. So this average gets stored here, then we use it here, and then it gets basically transferred to average dolphins and is then used everywhere in this function. Okay, so let's now test. And as we expected, no team wins, because this team here, even though it has more than the dolphins, it's not double. And so therefore, they do not win. Now, of course, what is also important to mention here is that this check winner function here is also completely independent of these score values that we calculated earlier. So here we can simply call this function with completely different values. So the function doesn't care where these values come from. So where average dolphins and average koalas come from. It's a standalone function and it doesn't care at all where these values came from. We can just plug in some random numbers here and then call it. And let's use a smaller number here. Okay, so just so that the average dolphin here is actually more than double of the average koalas. So if we run this now, then we see that the dolphins win with 576 versus 111. And so that's exactly the numbers that we plugged in here. Okay, so once more, it's important to keep in mind that these functions are all independent from another. We just happen to call check winner here with these values that we calculated before. But it's not mandatory to do that. Any other values will work just as well. And so we proved that here. Anyway, now let's use test data 2. And actually what I'm going to do is to reassign these two scores here. So we calculate them first, then we call check winner, and then I'm going to recalculate them and call check winner again. So what I mean by saying that is that these need to be let variables so that we can reassign them. Remember that? Const values cannot be mutated. They cannot be changed. And so they need to be let. And then here, of course, we need to get rid of that let because we do not want to create new variables. We just want to overwrite. So we want to reassign the values that we had earlier. So this time the values are 85, 54, and 41. 85, 54, and 41, and I hope that's correct. And then for the koalas, we have 23, 34, and 27. So that's 23, 34, and 27. Let's log these actually also, and then simply call check winner again. And now with the new values of score dolphins and score koalas that we just reassigned. Okay, so let's see. And now the dolphins have an average score of 60 and the koalas of 28. And so now the Dolphins win with 60 versus 28. So that's a close call. So if the Koalas had 3 more points, then no one would win. But the Dolphins managed to do it. Great. So I hope that this all made sense to you. And I know it is probably still a bit confusing at this point. And if you did some things differently, well then, once more, that is completely okay. It just means you're developing your own coding style over time. For example, here with the average scores, of course you could have created new variables down here for the test data too. So that's just one of many things that you could have done differently, which are perfectly fine. As long as your results are the same, you're good to go. So take some time and review this lecture. Remember that you can check out my final code also in the final folder in the GitHub repo. And then you're ready to move on to our next big topic in this section, which is going to be arrays. So I hope to see you there soon. Welcome back. Let's now talk about our first data structure, and that's going to be arrays. And let's say I wanted to store my friends' names in variables so that I could use them later in my program. And so with the knowledge that we have so far, this is how we would do it. So const friend1, let's say Michael, let's spell this correct, then friend2, Stephen, and then friend 3, let's say Peter. Now, this isn't really fun to do, right? Because imagine that we actually wanted to represent 10 friends, and then we would have to create 10 variables. So that doesn't sound like fun. Instead, wouldn't it be great to essentially bundle all of these values together into some bigger container? Well, that's why we have data structures in JavaScript, and arrays are such a data structure. So an array is like a big container into which we can throw variables and then later reference them. And that's super important because programming is most of the time all about data. So we get data from somewhere, we store and process data, and then we give some data back. And that data, it has to go somewhere. So it has to be stored in some place. And for that, we use data structures just like arrays. So in case we have more than just a single value. The two most important data structures, at least in JavaScript, are arrays and objects. And so now let's learn all about arrays. So instead of doing this, let's create a variable, which I'm going to call friends. And then we use the brackets to create a new array. And then in there, we can put different values separated by commas. And so let's now use the exact same friends. So Michael, comma, then Stephen, comma, and Peter. And make sure that these commas here are outside of the string. So that's an error I see people do. And so this needs to be one string. So you need to start and finish it, then the comma, and then another value, then another comma, and then another value. Okay, and now let's take a look at it in the console. Okay, and so this is what the array looks like in the console. So basically just as we wrote it in our code. And that is the absolute basics about arrays. So that's how we create one. At least that's the way that we use the most. But there's actually another way. So let me show that to you as well. So let's say we wanted an array of years. And so instead of the brackets, we could also write new array and then parentheses. And in there, we would then specify our values. Let's say 1991, 1984, 2008, and let's say 2020. So an array can hold as many values as we want, and also values of any type that we'd like. So it doesn't have to be strings like here. Of course, numbers work just the same. So here we used a different way of creating the array, which was using this array function. So you see that it's a function because we called it here, basically using these parentheses. And we also needed to use the new keyword, because otherwise it's not going to work. But anyway, it's way more usual to just use the brackets like I did up here, which is called the literal syntax. Great, so now we know how to create arrays, so basically how to put elements into an array, but of course we need to have a way to get them out. And for that we use the square bracket syntax again. So let's say that we want to log to the console the first element of this friends array. So that would be Michael. So console.log, and now we write friends. So that's the name of the array. And then we use the square brackets and then the number 0. That's because arrays are 0 based, which means that this first element is the element number 0, then this one is element number 1, number 2, and so on and so forth. And so if we want the element at position 0, so this first one, then we write friends, square brackets, 0. And that's it. And now let's say we wanted Peter here as well. So that would be element 0, 1, 2. And so let's just write 2. And check it out. And indeed, we get Michael and Peter. Cool. Now, we can also get the actual number of elements that is in the array. So let's also log that one to the console. And this one works by saying friends dot length. Okay? And this dot length is something called a property, which we're going to talk about a little bit later in this section when we talk about objects. Anyway, what matters is that this is going to be the exact amount of elements that is in the array. And it's not 0 based. So it will not be 2, even though the last one here is element number 2. Instead, it really gives us the number of elements in the array. So we should expect this to log 3. And yeah, here we go. Now we can use this to automatically get the last element of any array. And that is useful so that we don't have to count how many elements are in the array. So let me show you how we could do that. Friends, and then remember to retrieve an element from the array, we need the square brackets. So just like this. And then to get the index of the last element in the array, all we need to do is friends.length minus 1. So friends.length minus 1. And that's because, again, friends.length is not 0 based. So this is 3, remember, but this last element is 2. And so we always need to subtract 1 from this number here. Okay? So what this also means is that inside of these brackets, we can put any expression. It doesn't just have to be a number, literally like we did here and here. So here we have this expression. And remember that an expression is something that produces a value. And so this one here is going to be calculated first. So it will compute friends.length, which is 3, minus 1 is 2. And then it will get friends at position 2. And that's also one of the reasons why it's important that you know what is an expression and what is a statement. Because once again, we could not put a statement in here. So inside of these square brackets, JavaScript expects an expression, not a statement. Anyway, we got the correct element from the array, which is the element number 2. And so that means that this automatic retrieval of the last element works just fine. All right. And moving on, there is more stuff that we can do. So this square bracket syntax that we used here is not only for retrieving elements from the array, but we can also change it to add elements to the array. So let's say that for some reason I'm no longer friends with Peter and that I want to replace him with some other friends. And so now we can change or mutate the array in the same way. So we can say friends at position number 2, and now I'm doing it manually here again. So we can say that this should be equal to something else. Let's say J. And if we now log this friends array to the console, then we should already see the new array. So friends, and let's see. And indeed, the element number 2, so this one here, is now replaced with J. Okay, so in the beginning, when we first logged the friends array to the console, it was still in this state. So it still had Peter. And that's why here in the beginning, we still see that original state. But then as we move on through the code, at some point here, we change that array. And so when we then log the array again, that change is of course reflected here in the output. But wait, didn't I say in the last section that variables declared with const cannot be changed? And we did in fact declare the friends variable here with const, right? But I was still able to change one element of the array here from Peter to J, right? So isn't that a contradiction? Well, what I didn't tell you at the time is that only primitive values are immutable, but an array is not a primitive value. And so we can actually always change it, so we can mutate it. And it works this way because of the way that JavaScript stores things in memory. And once more, we will have a whole lecture just on that topic alone in a special section about how JavaScript works behind the scenes. So what you need to know for now is that we can actually mutate arrays even though they were declared with const. Now what we cannot do is to actually replace the entire array. So we cannot do this. We cannot say that the entire friends array should now be Bob and Alice. That would be illegal. So let's see. And now we get assignment to constant variable. And so that's why that we cannot do. But let's just keep it here anyway, so you get this as a reference. Next up, I want to show you that an array can actually hold values with different types all at the same time. So let's experiment with that. So let's create an array which holds all kinds of information about me. So let's say Jonas, so that would be the first name, then the last name, then the age, and here we can actually calculate the age from other values. And that works because in each position, JavaScript simply expects an expression. And so if we do this, then this is perfectly fine. Okay, so this will here produce a value, and so that's the value that will then be stored at position number 2 of the new array. And that also works for variables. So we could, for example, do first name equal Jonas, and then here instead of literally writing that, we could use this variable name. And so this would then be replaced with the actual string. So let's put some more data. And actually, we could even put other arrays inside of an array. So that's really cool. So let's put the friends array here in the Jonas array. And then with this, we have all the relevant data about Jonas in one handy data structure. And that's really convenient because then we don't have to create one variable for each of the data points. So let's, of course, inspect this now in the console so that you can see that all of these expressions here, basically, so this and this here and this, so all of them are going to be replaced with the values that they produce. And so, indeed, we now get Jonas, we have the calculated age, and here we have the array 3. And we can expand that by clicking on this small triangle here, and then we can see the actual array in here. We also have the length. So length is 5. And so that's where JavaScript gets this friends.length from. Jonas.length would of course also work, and it would be this 5 that we see here. Okay, so that's the one. Great. So these are the very fundamentals of arrays in JavaScript. And now just to finish this video, let's work on a very small array exercise so that we can see why arrays are actually so useful. And to do that, let's bring back our old calc_h function. So it's got to be somewhere here. Yes. Let's use this one. We've coded this so many times that I don't want to repeat it. So exercise. So calc_h. And now let's say that we have an array of birth years. And then we want to calculate the ages for some of them. So a new array. And let's say 1990, 1967, 2002, 2010, and 2018. And now we will be able to use the calc_h function and then store the results of calculating the ages for some of these years into a new array. So let's see how, and let's see first how we could not do it, okay? So, for example, if we wanted to use the calc_h function for all of the elements in this array, we could not do this. This would be not illegal, I would say, but it's not going to work because this years is an array. And if we pass this years array as an argument to the calc_h function, it doesn't know what to do with it because this operation here expects a single value, and we cannot do a number minus an array. So let me actually show you what's going to happen if we run this. And well, that's not the error that I wanted to show you. So what we get is identifier years has already been declared. So this means that somewhere in the code we already have an array called years. And yeah, here it is. So let's change the name of this one to just y. So that one doesn't really matter anyway. But now let's see what happens. And well, not much did happen. So we actually need to inspect the result of this. So console.log and then the result of this. So let's see. And now we get the result, not a number. And so that's the result of attempting to subtract a whole array, which would be this years array, from a number. Okay, so let's actually do that here as well. Remember that we have access to all the variables that we declare in the script, also in the console. So that's the years array that we just declared. But years, for example, plus 10, does not work. At least not in a way that we expected it. So the plus operator, what it does here is to convert everything to a string, just like I showed you before. And so the string here is then basically this array as a string, and then it adds the 10 here. So that's not meaningful at all. And if we use it with minus 10, then it's even weirder. So we get not a number. So all of this is to say that we cannot really do operations with arrays. But we can still use the calc_h function on individual elements of the array, of course. So let's do that. And we will assume that I want to calculate the ages for the first, the second, and the last array element. So this one, and this one. So let's calculate this and then store the result into a variable called age1. Then we need to get rid of this parenthesis. And so as I said, I want to calculate the age for this first element. And so what we do is to take years at position 0. And so this here will then basically be replaced with 1990. And then calc_h is called with 1990 and the result is stored to age 1. Now let's do this some more times and say age 2, age 3, and here I'm using 1. So remember, I want this, this, and the last one. But I don't want to count the number of elements in the array. And so I use that trick that I just showed you in the beginning, which is to first compute the length of the array. So years dot length, and then -1 to account for the fact that the index of the array is 0 based. And now we can quickly check out if this actually worked. So h1, h2, h3. And yeah, so we got 3 values here, which are these 3 ages. But we can take this even a little bit further. So since we started with an array, it's usually a good idea to also end up with a new array. So let's create an array, const ages. And now what should I put in here? Well, remember how I said up here that any position of the array simply needs to be an expression, so something that produces a value. And as we already know, this here produces a value as well, right? It is an expression. And so I can take this and simply put it as a position in this array. And so JavaScript will then go ahead, compute this value, and place it in the array. So basically, we can place function calls into an array just fine because they will produce a value. And now here we need to again do years dot length -1. And now finally logging it to the console, and then we're done. And indeed, we get the 3 same values that we had up here separately, now all nicely placed into this array. And this of course works because JavaScript will start by running these function calls, these 3 function calls here, and then place all the results in an array afterwards. Nice. And I think that should be enough for one video. I hope that you see how fun arrays can be and how useful they can be. And in the next lecture, we will make them even more useful by doing some operations with them. JavaScript has some built-in functions that we can basically apply directly on arrays. And these are called methods, and we can think of methods as array operations, basically. So let's now learn some useful array methods. And there are actually countless array methods in JavaScript. And in fact, we have a whole section dedicated to arrays alone. That's how important they are in JavaScript. But in this video, we're going to learn just some basic ones that you really need to know. And also so that you start to get used to the idea of using methods on arrays. Now let's start by bringing back the friends array from the last lecture. All right. And now let's start with a method called push. So the push method adds elements to the end of an array. And so let's say friends dot and then push, and then the element that we want to add to the end of the array. So let's say j here. So push is essentially a function, and we can see that by these parentheses. So it's a function that we call, and we call that function really attached to the friends array itself. And that's what this dot here stands for. All right. So again, push is a method, which technically is a function, and we call that function directly on the friends array. So the push function is kind of attached to the friends array. And if you're wondering why that is, we will once more learn that a little bit later in the course. But there is a good reason why this works, and it's actually pretty fascinating stuff. So I hope that you're excited to keep continuing to explore this course until you'll really learn how all of this actually works. Now, anyway, let's now check out the friends array. in the console, because this is really all we need to do to add an element to the end of the array. And indeed, now we get the original array that we had before, plus the j element. And you see that the length is now also 4. Okay, so this actually changed, so it mutated the original array, but that's no problem at all, just like I explained you in the previous lecture. Remember that? All right. Now, since push is a function here, it can also return something. So we already know that we can pass arguments into functions, and we did that here with j. Then the function can do some work, and in this case, the work that the push function does is to add the element to the array, and actually the push function does return a value, and the value that it returns is the length of the new array. So if we want to capture that data or that value, we can create a new variable for that. So let's call it new length. And let's then also log it to console. And indeed, it is 4. So most of the time we actually don't do this. So we just push an element and call it a day, because usually we don't immediately need the length of the new array. But in case we need it, we don't need to then calculate it separately. We can simply take the result of this function here, store it into a variable, and then use that. Great. Now, besides the push method, which adds elements to the end of the array, there's also a method to add elements to the beginning of the array. So that is the unshift method. So unshift. And so let's say we wanted to add John right to the beginning of this friends array. So again, let's check it out. And so now it should have 5 elements, and the first one should be John. And yeah, it is. And just like the push method, the unshift method also returns the length of the new array. But in this case, we are just not saving it because we don't really need it. Next up, we also have methods to remove elements from arrays. So these one here, add elements. So let me just write that here. Add elements. And then we have some to remove elements. And let's start with the pop method, which is basically the opposite of the push method. So this means that pop will remove the last element of the array. So let's write that here. And this time we don't need to pass in any argument. And that's because there's no information needed really to just take out the last element. So let's try that. Oh, we didn't log it again to the console. So let's just grab it from here. And now you see that j is actually gone. And if we did it twice, for example, which of course we can also do, then Peter should also be gone. And indeed, we removed j and Peter. Now again, this pop method also returns something. But this one doesn't return the length of the new array, but instead it returns the removed element. And so that can sometimes be useful. So let's call this one popped, okay? And so let's log that one to the console as well. So that is the popped element. And we could do the same for this first call. But as I said earlier, we don't always do this because it's not always that useful. But here I just want to show you that it actually works. And so the popped element should now be Peter. So this first one here is j, and then the last one becomes Peter. And so here in the second pop call, Peter is the one that's being removed. And so that's the element that's then going to be saved into popped. And yeah, here it is. Okay. And finally, let's also remove the first element from the array. And so that's friends that unshift. So let's copy this one again, give it a save. And so now only Michael and Steven should be left after all this manipulation, right? Oh, and actually that did not work. And that's because I did a mistake. So unshift is of course to add elements to the array. And so this one here is called shift and not unshift. So now it should work. Yeah. Once again, we didn't need any arguments. And once again, this method here will return the element that was removed. So if we need that, we can capture it. Next up, there is a very useful method that tells us in which position a certain element is in the array. So let's work with this small array that we have left. And what we want to log to the console now is friends.indexOf. And then we pass the element which we want to reference. So let's say we want Steven. And so, as I said, this should return the index at which this element is located. So we know that Steven is right now element number 1, right? So 0 and 1. And we actually can see that here in the console. So 0 is Michael, 1 is Steven. And so this indexOf function call should return the value 1. Because again, that's the index of the element Steven. And yeah, there we go. Now, if we try the same thing for an element that is not in there, let's say Bob, we will get -1. All right. And now finally, to finish this, this lecture, there is a very similar method to the indexOf, but which is a bit more modern and, in my opinion, also more useful. So this one is an ES6 method and it's called includes. So includes, instead of returning the index of the element, will simply return true if the element is in the array and false if it's not. So let's check that. So friends.includes. And now we can actually do the same as up here. So let me just copy that. And the difference here is, again, the includes method. So let's see what we get now. And as expected with Steven, it is true, because indeed we have one element here, Steven, but Bob is false because, well, there is no element called Bob. And this method actually uses strict equality for this check. So let's say that we pushed some value here to this array. So friends.push, which remember will add a value to the end of the array. So if we added 23, and then if we checked for 23 the string, it would not work. So it would say false, right? And that's because it is testing with strict equality, which means that it does not do type coercion. And since 23 the string is different from 23 the number, it gives us false. But if I test it directly for the number, then it should be true. And yes, it is. So we added it here to the array, and so then of course the array includes it. That makes sense. And so we can use the includes method to write conditionals. So that's one of the very useful applications of this method. For example, just to test it out very quickly, let's say friends.includes Peter. And then, if so, we can log to the console. You have a friend called Peter. Okay? So we already know that this here returns a Boolean, and we also already know how the if statement works. And so only if this is true, so if the array does include a string with Peter, only then this code is executed. And so right now, of course, nothing happens. But if I ask for Steven, then here let's say Steven as well, then I get, you have a friend called Steven. So that's probably the most used case of the includes method. All right, and that's all I had to show you for this lecture. And as I said in the beginning, there are many more useful methods for manipulating arrays. But for now, I just wanted to show you the most basic ones. And next up, there's yet another coding challenge waiting for you. Okay, and I'm going to start by creating the calcTip function. And I'm going to start doing it with a function expression. So this one will receive a bill as an input, I think, yeah. So calcTip takes any bill as an input. So let's simply call it bill. And then what we want to return is the tip. And here I'm going to write the exact same code as we did in the other challenge. So there's no need to explain it all again. It would just be a waste of time. So if the bill value is between 50 and 300, so less or equal than 300, and here we're using the ternary operator, then return the bill value times 0.15, so that's 15%, and otherwise it should be 20%. Okay, so the result of this ternary operator here will be one of these values. So either bill times 0.15 or times 0.2. And so that's going to be the result of this operator. And so that's what this function will return. If you prefer the arrow function, we can also do that. So const calcTip equal bill. And now we can omit the return keyword and do it all in one nice line. So now you just have to choose which one you like better. And I will just, for the sake of readability, keep the first one there. Okay? But if you prefer the arrow function, you can just use this one. Great. So number 2 is to simply create a builds array with these 3 values. So builds 125, 555, and 44. So that was easy. And now we will create an array tips, which will contain the tip value for each bill. So let's do that. And now this is similar to what we did previously with calculating the ages. So we are going to create an array, and then each position will be the function call to calcTip. So we want to calc the tip with builds at position 0. Then at position 1, we want to calculate builds, or we actually want to calculate tips based on builds on position 1 and then on position 2. And that's it. So let's log both the builds and the tips to the console here. And that gives us tips is not defined. So here it should be tips. So usually when I have an array, I like to give it a plural name, like here builds and here tips. So because it's multiple values. So now that should work. And yeah, so these were the 3 tips that were calculated. And of course, you could have created separate values or actually separate variables for each of these function calls, like tip1 equals calcTip with builds 0, something like this, and then tip2 and tip3, and then you could have created like an array with tip1, tip2, and tip3. Okay, so something like this. But my idea was to actually do it like this, because then we don't have to create all these extra variables. So that's a lot cleaner. Later on in the section, we will find an even better way of doing this, but with what we know at this point, this is the best that we can do. So we take the first bill, calculate the tip based on that, and put it in position number 0. Then we take bills at position number 1, calculate the tip, and put it in position 1 of this new array. And then we take bills at position number 2, calculate the tip, and put it at position 2 of the new array. And so then, yeah, we end up with this. Lastly, let's also complete the bonus question number 4 here. And all we have to do here is to create an array which will have the sum of the bills and the tips. So that's going to be totals. And now you might have tried to do something like this. So like bills plus tips. But as I told you in the previous lecture, this is simply not going to work. So we cannot do any operations on arrays like this. It doesn't work like that. So let me show you the result that we would get from doing this. And so basically, each of the arrays would be transformed to a string, and then the two strings would be concatenated. So that's completely useless. And so the only thing that we could do is to say that we want bills at position 0 plus the tips at position 0. And now we do this for all the 3 values. So at position 1 as well, and then at position 2. And so this fixes this error, because now in each position we do actually have a real value, because this is an actual value, and so with that we can then do calculations. So yeah, this is correct, looks correct, right? And yeah, so with that, all of the 4 points are solved. And so here we conclude this part about arrays. So after arrays, it's now time to learn about another data structure in JavaScript, which is objects. So up until this point, we have been using arrays as a data structure to basically store multiple related values in the same variable. So let's just quickly recap that. So Jonas array, and you don't need to write this code. Okay, I'm really just trying to recap here. So we had the first name, and you see that I'm writing this in multiple lines now, and that is perfectly acceptable. So sometimes that's easier to give us an overview of a data structure, as long as we remember the commas here after each of the elements, we're going to be fine. So then we have kind of this age calculation here. Then we had the job and even an array of friends. So we have an array inside an array. So Michael, Peter, and Stephen. So again, this is basically a data structure which combines multiple values which all belong to this Jonas entity. Now we know intuitively that this first element here of the array should be called the first name. And this one is the last name. This one could be called age. This one could be called job. And this one could be called the friends. But in arrays, there's no way of giving these elements a name. And so we can't reference them by a name, but only by their order number in which they appear in the array. And so to solve that problem, we have another data structure in JavaScript, which is objects. So in objects, we actually define key value pairs. And so then we can give each of these values here a name. So let's see how. So again, we're defining a variable. And so I'm calling this one Jonas now. And then this is the actual object. So now instead of the square brackets that we use for arrays, we use the curly brackets or curly braces. So this is the second time we're seeing the curly braces. First, we saw them to define a code block, for example, in an if-else statement or if a switch statement, or even to define a function body. But this is different. Okay, so these curly braces here are to define a new object. And so let's now fill up this object with key value pairs. So the key is basically the variable name. So let's say first name, then a colon, and then the value. And the value can be of any type that we want here. Then to define another key value pair, we just separate them with commas, just like in the array. So last name, and then colon, remember, Schmettmann, then the age, and once more, we can put any expression here. So this will be calculated and then will be assigned to age. Then the job, which is teacher, and finally the friends. And let's just copy this array from here. Okay, and so with this we have now an object which contains 5 key value pairs. So again, these are the 5 keys, and then each key has a value. And so essentially with this, we were able to assign a name to each of these values that we had. So that's something that was impossible in arrays, but now it is possible. Now each of these keys is also called a property. So we say that this object here, so this object, which is called Jonas, has 5 properties. So property first name with the value of Jonas, property last name with the value of Schmettmann, and so on and so forth. Now, objects are probably the most fundamental concept in the whole JavaScript language. So there are many ways of creating objects. And simply writing an object in the code like this is probably the simplest way of creating an object. So here with the curly braces. So there are multiple ways of creating objects, but again, using the curly braces like this is the easiest one, and it's called the object literal syntax, because we are literally writing down the entire object content. So to recap, just like arrays, we use objects to essentially group together different variables that really belong together, such as the properties of Jonas that we've been working with. Now, the big difference between objects and arrays is that in objects, the order of these values does not matter at all when we want to retrieve them. And that's important to keep in mind. So in arrays, the order in which we specify the elements matters a lot, because that's how we access these elements, right? So we can only access array elements using their order number. This means that we should use arrays for more ordered data and objects for more unstructured data, and data that we actually want to name and then retrieve from the object based on that name. But how do we actually do that? So how do we get data from an object? And that's exactly what the next lecture is about. So see you there in a second. In this video, you're gonna learn how to retrieve data from objects and also how to change data in objects using both the dot and the bracket notation. So let's actually get the object here from the previous lecture. So that's Jonas object. And I noticed that we actually didn't even take a look at it in the console. So let's quickly log it. But we're actually not gonna see a big surprise. So all it shows us is really this same object that we just wrote in code. So it looks like this. So essentially just as it is here in the code. The only thing that's different is that the properties here are ordered alphabetically. And so that's what I mean when I said in the last lecture that the order of properties does not matter. And that's because we simply get the properties from the object using the property name itself. So that's actually the topic of this video. And so let me show you the two ways in which we do that. So the first way of getting a property from an object is by using the dot notation. And that is very straightforward. So let's log that to console. And so let's say that we want to get the last name. So all we have to do is to write Jonas dot last name. And that's it. You see, here is my last name coming straight from the Jonas object. So Jonas dot last name. And this dot here is actually an operator which will go to this object and then retrieve the property with the name that we specified here. Now we can do the exact same thing using the brackets notation. So let me show that as well. So Jonas, and then we use brackets in a similar way in which we retrieve data from an array. But here we need to specify a string with the property name, so with the key. So let's do my name again, or actually last name. And so these results should be exactly the same here. Now the big difference between these two here is that in the bracket notation, here we can actually put any expression that we'd like. So we don't have to explicitly write the string here, but instead we can compute it from some operation. Because remember that an operation is basically an expression. So something that produces a value. And so we can put that here inside the brackets. So let's actually try that. And imagine that we had a variable in which we store the repeating part in first name and last name. So we have name here in both. And so let's store just that inside of a variable. And you will see my point here in a second. This will all make sense, trust me. So name key, and then just name. So again, that's the repeating part in these two property names. And now we can use that variable to get both the first and the last name. So console.log, and then Jonas, brackets. And so now here we can insert the expression. So let's create a string first and concatenate it with name key. And here we could have built this string using a template literal, but in this case, it's not really necessary. So let's just copy this and then also last. So what will happen here is that as JavaScript sees this line of code, it will start by executing this plus operation, and so it will create the string first name. And then it will go to the Jonas object and retrieve that property. And the same for the last name here in the second line of code. And so that's how we get Jonas and Schmettmann. And doing something like this is more common than you might think. And so that's why it's important that we understand that in the square brackets, we could put any expression here. Okay? Now the same thing would not work with the dot operator or the dot notation. So we cannot write Jonas dot and then this here, for example. This would not work at all. So an unexpected string. And so that's the reason why we need the brackets notation. In dot notation, we have to use the real final property name and not a computed property name. So for example, this one. This one is a real property name as it appears in the object. And so that's why it works here in this case. So in what situations should we use the dot notation, and when do we have to use the brackets notation? And I kind of already replied to that, but this is just to recap. So when we need to first compute the property name like we did here with the first and last name, then of course we have to use the bracket notation. In any other case, just use the dot notation, which looks a lot cleaner and is also easier to use. Okay? And now to make the need for the bracket notation even more clear, let me show you another example, which I think is going to be really fun. So let's say that we don't know yet which property we want to show. And instead, we get this information from some user interface. So for that, we can use the prompt function, remember? So we can use prompt, and prompt is yet another built-in function that is built into JavaScript and that we can use in any script. So here we can write a string, and then this will create a pop-up window with an input field, remember? So here we can write, what do you want to know about Jonas? Choose between first name, last name, age, job, and friends. And remember that this function will then return a string, and this string we just need to store into some variable. So let's call this one interested in. All right. And to start, let's just log this interested in value to the console here, just so we see that it actually works. And so here is the pop-up. And so now we just write one of these options here. So let's say job. And indeed, now here we get job. And so what we want to do now is to basically display the job here in the console, because that's what the user chose. So how will we do that? Can we use the dot notation? So basically, can we do this? Jonas.interested_in? Well, let's find out. But I hope that you can guess. And so we get undefined. And this is something new that I didn't explain yet. And so let me tell you now that undefined is what we get when we try to access a property on an object that does not exist. So Jonas does not have a property called interested in, right? And so therefore, the result of trying to access interested in on Jonas is undefined. Now, what we need to do here is, instead of the dot notation, use the brackets notation, because then we can put any expression here, which in this case will be interested in. And so JavaScript will now come here and replace interested in with the actual value of the variable, and then that's the one that will be looked up on the Jonas object. So let's try that again. And now, when I say job, we get the correct result. Great. And I hope that you did understand the big difference between using the dot notation and the bracket notation, and why the bracket notation gave us the correct result. So again, it's because basically this expression that we put here between these brackets will get evaluated. And then this one here is job. Now, of course, we can also pass in something else. So something that is not here. For example, let's try to access the location. And then again, we get undefined. And once more, that is because there is not a property called location on the object. So let's actually handle that using some knowledge that we already have. So we know that undefined is a falsy value, right? And so we can use that to our advantage now and create some logic that will print a custom string whenever the user tries to access a property that doesn't exist. So let's do that. And we can say, if Jonas brackets interested in, then log that to the console. So basically this. And again, I'm using now the option and arrow down to move this line. And so if this value exists, then it is a truthy value, because it is not undefined. And so any string that is not empty or any number that is not 0 will then trigger this code block here to be executed. Now, if one of these properties was actually empty or 0, we would then go to the else block, but let's not account for that here in this case. Let's say that doesn't happen. All right. So in case that the value does not exist, so for example with location, we then get undefined. And so in this case, Jonas interested in is undefined which is false, and therefore we would go to the else block. And so let's say something like wrong request, and then we can repeat this sentence here. So let's try that again here. So location, and now we get wrong request. But if we try something that exists, then we get that result. Great. So I think this was a fun little experiment here, and yeah, I hope you liked that. And now that you know how to retrieve elements from an object, let's also learn how to use both the dot and the brackets notation to add new properties to the object. So that's pretty straightforward. So all we have to do is Jonas dot, and now let's actually use location and set it equal to something. So to some value. So I'm located in Portugal, and so that's how we use the dot notation. And then we can also, of course, use the brackets notation just the same. So let's say my Twitter handle here, which is @Jonas Schmettmann with just one N. And you should definitely check that out. And now just to see that it worked, let's log it to the console one final time. And okay, it's asking us for the field name again. But anyway, now we have the location and the Twitter here as well in the object. And of course, here we could put any expression just like before. So it works in the exact same way. All right. And that's how we use the brackets and the dot notation. Now, finally, I have one small challenge for you that you can just do right now here at the end of this video. And so what I want you to do is to write a sentence like this one that I'm going to show you now, but in a dynamic way. So let's just write challenge here. And so I want you to write, Jonas has 3 friends, and his best friend is called Michael. So here we suppose that the first friend in the array, so in the friends array, is the best friend. Okay, and for the record, I do have more than 3 friends, but of course here we need to keep it all very simple. So again, I want you to write this sentence, but without hard coding any of these values. So what you need to get from the object is this value, and this value. And this is actually a bit hard, I would say. And so there's absolutely no need for you to nail this. But you can still try it, and maybe you can do some of the parts. One hint that I can give you is that you will need to use multiple dots to get the number of friends. Okay, so that's totally possible. And so take like 5 minutes to try this out now. So pause the video and I'll see you in a second. All right. And so this is how we would do this. So we want to log this to the console, of course. And so we're starting with the name. And this one is probably the most straightforward one. So that's just Jonas.first name. So that is where the name is stored. Then has, and then the number of friends. So the friends are stored in Jonas.friends. Now, do you remember how to get the number of elements in an array? It is by writing the array dot length, right? And so let's do that. So Jonas dot friends, and so this is our array, right? And so on this array, we can now ask for the length. And so basically you can see here that length is also a property that is available on all arrays. So it's a property that we don't define ourselves, but it's automatically available. But now that you know about the dot notation, you can also start to understand that the dot length is just a property that is available on all arrays. And so that's what we're doing here. So again, we have an array, which is this one. And on there, we can simply then request .length. Okay, let's continue the sentence now. And his best friend is called. And now we need to simply get the first element from the array. And so that's again Jonas.friends. And now remember, we get the first element of an array using square brackets 0. And that's it. So once more, this here is simply an array. And so we learned that to take the first element, we just use square brackets with 0. So in a sense, on arrays, we also have the brackets notation. Okay, so let's just test this. And again, this annoying pop-up. But indeed, Jonas has 3, and we're just missing the friends here. So friends, and his best friend is called Michael. So just what I had written here as a template. Now in terms of operator precedence, let's quickly check out why it actually works this way. So with the dots here. Because remember, as I said, the dot operator here is really just that. It's just an operator. And the same goes for the brackets. So I will again Google MDN operator precedence. But the link to this table is also on the resources pages on my website. And the link to that one is right in the first text lecture of the course. But anyway, here we have the dot notation, which here is called member access. And then we have the brackets notation, which is here called computed member access. And so the computed is because, as I mentioned multiple times now, because we can compute the property names that we want to access. Now what matters here is that they both have a really high priority and both are left to right. And so that's why all of this works. So we have 2 dots here. So Jonas.friends.length, and they are executed left to right. And therefore, the first thing that JavaScript does is Jonas.friends. And so essentially, this will then be replaced with the array. And then on that array is where the .length is then applied. And the same thing here. So first, Jonas.friends is done. And then this one is also left to right. And so from there, we take element number 0. Okay, so there's no magic involved here. There is rules for everything, and everything makes sense. And again, you don't need to memorize this here. With time, all of this will become second nature to you. Let's keep exploring objects. And this lecture will bring us to object methods. So we learned that objects, just like arrays, can hold different types of data. And they can hold even arrays, and in fact, they could even hold objects inside objects. But now we can take it even further. And for that, remember how I said that functions are really just another type of value. And if a function is just a value, then that means that we can create a key value pair in which the value is a function. And that then means that we can, in fact, add functions to objects. And so let's now see how. And once more, I will get back this object here, but we will change it up a little bit this time around. So here, let's simplify and just put the birth here. So just 1991. And I also want to add a Boolean here. As driver's license. Just to show you that we can hold all kinds of different data types in one object. But now let's also add a function here as a key value pair. So to do that, all we have to do is to add another key here. And the function that we want to add is again the calc_age function. So that's one of the favorites, as you can see, but it is because it's a very simple calculation that we can do with the birth here. So to do that, let's simply add the name basically of the function here as a key. So as a property, so calc h, and then the colon. And now here we simply specify the function as an expression. And that works because the expression produces the value. And so we can just do this. So function, and just like before, we pass in the birth year, and we return 2037 minus the birth year that was passed in. So this is pretty similar to simply writing this, right? So a regular function expression. So const calc h like this. This is how we used to do it before. And so you see that this is pretty similar. The difference is just in the syntax, because now calc h is not a regular variable like here, but it's a property of the Jonas object. And so therefore we use the colon here, but the rest here is exactly the same. And so that's why it was very important that you understood what a function expression actually is. Because here we need the function expression to create this method. And that's what this function is called. So any function that is attached to an object is called a method. So of course we could have not used a function declaration here. So something like this. So function calc h, for example, that would not work. We would certainly get an error here. So unexpected token function, because this is a declaration. And so it doesn't work here. Here we need an expression. And so this will work indeed. Okay, does this make sense? So if you can think of functions as simply being values, then you can see that a method is actually also a property. It just happens to be a property that holds a function value. So here we have a string value, here we have an array value, here we have a Boolean value, and here we have a function value. All right? So I hope that's logical. And now, just like we can access any other property, we can also access the calc h property or method. So Jonas.calc h. And so calc h is now the function value. And just like any other function, in order to call it, we use the parentheses. And now we can pass in the year here. And so that should then calculate our age. And let's just log this result to the console here, just to see if everything works. And it does indeed. Okay. And you could also have accessed this method using the bracket notation. Because again, it's just as if it was a normal property. And the brackets would actually be necessary here, so that this then here is the function, and then we call the function using the parentheses. So let's try that. And yeah, here this needs to be a string. So like I showed you in the last lecture, and now here we get 46 as well. Okay, so just like I showed you in the last video with the operator precedence table, the first thing that happens here is that Jonas.calc h is computed. And so this here will become the function value. And then with the parentheses, we call that function value here and pass in 1991. And the same thing here. So here we access the property calc h using the brackets, and then this here will basically be replaced with the function, and then we call the function right here, just like before. All right. Now, you might have noticed that the birth year 1991 that we passed here as an argument to the method is actually already defined in the Jonas object itself up here, right? So we already have this information in the Jonas object. And so writing the same number here and here is not ideal, because we might make a mistake and pass in the wrong year. For example, right here. So Jonas's birth year is 91, but here we could, for some reason, accidentally do 92, and then it would be wrong. And even if we do not make any mistake, this is still not ideal because we are not keeping the code dry. So we're violating the don't repeat yourself principle. So if we know the birth year of Jonas, it should only be written in one place, not in multiple places. Because if that might change, then we have to change it everywhere. That's always the philosophy that we need to keep in mind. So what if we could actually access this birth year property directly from the Jonas object instead of having to pass it in? Well, it turns out that we actually can. And that's because in every method, JavaScript gives us access to a special variable called this. And so what we can do now is in this calcH function, we can read the birth year directly from this object itself without having to pass it in as a parameter here into this function. All right, so let me copy this and comment this one out just so that we keep a record of what we did. But this here will be the new version. So now we no longer need this parameter and we will read the birth year directly from the object. And for that, again, we will use the this keyword. So the this keyword or the this variable is basically equal to the object on which the method is called. Or in other words, it is equal to the object calling the method. So let's see who is calling the method. So down here is calcH, and the object that is calling the method is Jonas, because that's where the dot is. And let's forget about this one. I'll actually comment it out here. And so again, the object that is calling the calcH method here is Jonas. And so that means that inside this method, the this variable or the this keyword will point to Jonas. And so let me just write this.birthyear here, and then I can explain it even a little bit better. So here we don't need to pass the 1991 here, and I will run this now, and we still get the correct result. So great. And to make this even more clear here, let's also log this to the console. And indeed, this is the whole Jonas object. And so again, that's because the Jonas object is the one who is calling this method, so this function. See here, it's jonas.calcH. And so whatever appears before the dot is the one who is calling the method. And so therefore, in the method, this points to Jonas now. And if this points to Jonas, then this.birthyear is of course this value that we have right here. Great. So you see that the this keyword is something really, really useful. And we will learn even more about the this keyword in greater detail in a later section. For now, I just wanted to introduce you to this concept. And I know this can be a bit confusing, so really make sure to maybe pause the video and really analyze what's happening here. Maybe you can even rewind a little bit and hear my explanation again. That might be useful too. Now, you might argue that maybe we don't even need this confusing this keyword. Why not just do jonas.birthyear here instead? Well, because that would actually still violate the don't repeat yourself principle. It would work just the same here now, but then let's say that we need to change the name of the object. So we change it here to Jonas2, and then we call Jonas2 down here. And then the code will no longer automatically work. Because now Jonas is not defined, of course. And so we would have to keep that in mind and then come here and manually change this as well. While if we had the this keyword, then everything will keep working without us having to change it there. Because now this will simply point to Jonas2, because that is the object calling the method. And so therefore, it's always a good idea to reference the object itself and not hardcode the name of the object. So let's put it back to Jonas. And yeah, much better. So this works great already, and we're really going into some more advanced territory here. So I hope you're still following me and you're still making sense of everything. However, we can actually even take this a little bit further. But don't worry, it's not going to get a lot more confusing. Just a small variation of this. Because let's say that we need to access the age multiple times throughout our program. So that would be like calling this a couple of times. So let's say in 3 places of our application, we need to access the age. And so, of course, this will work. And indeed it does. And it always locks the Jonas object because we still have this here. So this makes it a bit easier to view. And so what happens here is that the function will get called a total of 4 times. And so this computation here will be done 4 times. And in this case, that's not a big deal, but it might be like a heavier computation that actually takes some more time. And so it would be a bad practice to do this multiple times. Instead, what we can do is to just calculate the age once, then store it in the object, and then when we need it at a later point, we can then just retrieve the age as a property from the object. So I hope you're following me here. So I will again copy this and comment it out so that we keep all the 3 versions that we did here. So what I was trying to say is that we can now use the this keyword also to store a new property. So we can say this.age is equal to this here. So we calculate the age and then we create a new property on the current object. So in this case, on the Jonas object. And remember that we can use the dot notation like this to create new properties. So we did that in the previous lecture as well. Where was that? Yeah, right here. So here we created Jonas.location and set it to Portugal. And so here we are essentially creating Jonas.age and setting it to this age that we just calculated. And then we can simply return this age. And of course, we don't even need to return anything if we didn't want to. We could make this method only calculate the age, but not even return it. But I think it's a good practice to actually also return it. And so now here we can replace the function call with simply a request for the age property. And notice this trick that I did here again with the command D, right? So this gives me multiple cursors and then I can do one operation in multiple places at the same time. So that's a really handy shortcut. So again, command D or control D, and in the menu bar, that means add next occurrence. So let's test this and the result should be the same. And it is, but we only needed to calculate the age once. Then from here, we simply retrieve the property that we had already calculated before. And so this is the most efficient solution, let's say. All right, and now I actually have another small challenge for you that you can do just in this video. So I want you to write a method called getSummary, and this method should return a string which should kind of summarize the data about Jonas. Or, of course, any other person data that you might have used. For example, let me again, actually we can get rid of this. So let me write challenge here again, and then do an example string. So I want you to write, for example, this. Jonas is a 46-year-old teacher. And we now could actually add all the data here to the string, but that would be too much work. And I'm a bit lazy now. So let's just also say if I have a driver's license or not. So Jonas is a 40-year-old teacher and he has a driver's license. And it says that I have a driver's license because has driver's license is true. But if it was false, then here it should say, and he has no driver's license. So it's either A or no. So figure out how you can do that. And so I hope you managed to do it. It's a bit similar to what we did in the previous lecture, but this time I want you to actually write a method on your own. So give this a try, and I see you here in a second. Okay, so let's add get summary. And remember that you need to have a comma between the properties. And so that's true also with methods. So here we need a comma, and then just a function. And it will then get all this data, of course, from the current object. So actually, let's first call this method. And we're doing it inside a console.log because, of course, we want to be able to see the summary string as a message in the console. So Jonas.get summary. Okay, so which is the object calling the method? It is Jonas. And so therefore, the this keyword inside of get summary will be Jonas. So I hope that this one is clear at this point. So let's now build a string here. And starting with the name, it is at this dot first name is a, and now the age. So this, and now what do we do here? Should we use the age property, or should we do calc age? Well, I would say that we should do calc age because we cannot assume that calc age was already called before. Okay, and if we don't call calc age before we call get summary, then the age property would not exist. And so it's better to actually do calc age here. And so I think we did this before. So in a template string, we can easily do a function call. That's not a problem at all. So this.calcAge will call this other method, and this will then return the age. All right. And maybe it might be strange for you to call the function also on this, but well, the rule is just exactly the same. This is Jonas in this object. And so this is essentially the same as writing it here. All right. So this will become the age. And so year old, and now the job, Jonas.job. And he has, and now we need to decide between a and no. So let's do a ternary operator here. So we get this dot driver's license. And basically, if it's true, then we want the result of this operator to be a. And if not, we want it to be no. And then driver's license. Okay, makes sense? So again, here we want either a or no, depending on the state of the has driver's license property. So we get that property by calling this dot has driver's license. And here we're using the ternary operator. And so if this first part is true, then the result of the operator will be a. And otherwise, the result will be no. And so that's what will then be put into this place of the sentence. Okay. And we already called the method down here, and we logged it to the console. And so I think this should work now. And it does. So Jonas is a 46-year-old teacher, and he has a driver's license. Now just to test, let's set it to false. And he has no driver's license. Beautiful. Okay. And yeah, that's all the code that I had to show you in this video. And now just to finish the lecture, which I know is already running quite long, but I want to basically build a bridge between this method and the array method lecture. So remember that we used methods on arrays previously. So we can quickly go there. So it was before this challenge. Yes, indeed. So for example, here we have friends.push. And so we have an array, and on there we call a method. So just like we did in this video. Now what this means is that arrays are actually also objects. They're just a special kind of object. And so they have functions, or in other words, they have methods that we can use to manipulate them, like push, pop, shift and unshift, and many more. All right. So in this lecture, we created our own methods on our own objects. But here we basically used built-in methods on arrays. And so once again, that means that arrays are actually also objects. That's why they can have methods as well. And we will dive deeper into why things work like this. But I wanted you to realize this early on in the course. This is quite a complex topic. And so there is really a very exciting journey still ahead of you. So I hope you're enjoying this journey so far. And now to test your knowledge, there is coding challenge number 3 coming up next. Okay, so let's get to work. So number 1 is creating an object for each of them. So object mark. So full name property Mark Miller. Then the mass, which is 78 kilograms, and then the height, which is 1.69 meters. So that's it for now. And now I'm just gonna copy this. As always, I'm a bit lazy, and that's just how programmers are, I guess. So John Smith, and he is 92 kilos and 195 meters tall. Okay, so that is point number 1. And now we will create the calc BMI method. And then a function without any parameters, because we will take the data directly from the object, just like we did it with the calc H method previously. And remember that it says here that we should store the BMI value to a property and also return it from the method. So this means that we will do this dot BMI and then do the calculation here. And remember, from the formula, the BMI is calculated by this dot mass divided by this dot height squared. So exponentiation operator with 2. And then also return it. So this dot BMI. And just to see if this actually works, let's actually call this method. So mark dot calc BMI. And now I will quickly log to the console the property that we just created. So I could have logged this to the console directly, but I want to do it this way now, and it doesn't really matter. So with this, remember, we created a property called BMI. And so that is now, of course, accessible here. So mark.bmi, because remember that here in this method, this now points to mark, because that is the object that is calling the method. And therefore, this .bmi will be on mark. So mark.bmi equals mark.mass divided by mark.height. And so that's how we get this data into this method. All right, so that's essentially what we learned in the last lecture. And so here I'm doing the same. I'm first calculating this value, and then I'm doing mark.bmi, which was added here in this method call. Of course, without this method call, mark.bmi would not be available, because this method here doesn't call itself. We need to explicitly call it. Now console, missing the .log. How can that still happen after all these years? Okay, so here we get the BMI of 27, which seems about right. And now, as I said, we will simply go ahead and copy this method exactly the same to this John object, and it will work just the same. Believe me. So let me show that to you. So now we call John.calcBMI. And so now the object calling calcBMI is John. And so now in this method here, this will point to the John object. And so this time, John.BMI will be calculated using John's data of mass and height. Okay? Are you still following that? As always, you can pause the video, analyze the code on your own, or you can always rewind to hear the explanation again. I actually like to do that myself when I watch other online video courses. So I think that's a good tip, maybe. Anyway, so we just calculated the BMI of John here as well. And so now I'm logging both to the console. And so, yeah, this one also looks correct. And so this means that simply copying this method from one place to the other actually makes it work and adapt to the data of each object. Now, having the exact same code in both of these objects kind of violates the don't repeat yourself principle, right? And actually, there is a way in which we can avoid this. And of course, we will learn how at a later point in the course using something called object-oriented programming. But for now, we are still learning the basics and just want to make things work. And of course, have some fun along the way. So this was the hardest part, I believe at least. Now all we have to do is to write this string here. Let me actually copy the example so we have it as a reference down here. Otherwise, I'm going to get a bit lost. So, if mark.bmi is larger than john.bmi, then console.log. So let's get the full name now from the object. So mark.fullname BMI. And now we also need it here in these parentheses. So let's put it there. Mark.bmi is higher than, and now let me just copy it here. So, and again, I'm using Command D to select the next occurrence, and then let's just replace it with John. So Mark's BMI is higher than John's BMI. And now let's grab this again. Else, if John BMI is larger than Mark.BMI, then essentially say the opposite. So here it's going to be John. And again, Command D. And here it's going to be Mark. Okay. So 27 is higher than 24, and that 27 belongs to Mark. And so this seems to be about right, but it's not completely right. So, of course, here it should be lowercase. So BMI, and now I cannot use the Command D because then it will select this one as well. So I'm double clicking on this one, and I hope that you're finding these VS Code tips useful as well. So I'm clicking, or actually I'm double clicking on this one. Then I hold down the Command key, which in your case might be the Control key or maybe the Option key. So I know there are different configurations for this, and it might not even work for you. So please don't ask any question in that case. But for me, I just have to hit Command, and then I can double click on multiple words, and then all of them get selected. So now I have these 4 multiple cursors here again, and I can simply delete all of them and write the one that I'm interested in. So that's the lowercase BMI. And now we get the correct values. And also this conditional logic is correct as well. And so with this, we did actually solve the challenge. And with this, we also finished this introduction to JavaScript objects. And once again, I really want to congratulate you for the progress that you're making here. Great job and really well done. And I really mean it because I know how hard it is to stick to a course like this and to learn a completely new thing that is probably a bit confusing for you at this point still. Just keep in mind that that is absolutely no problem at all. And actually, in the next section, I believe, I have a video about how to learn, basically. So about learning how to code. And there's a lot of great tips that I'm sharing there. So once you reach that, make sure to watch it carefully. But now, anyway, I will leave you to review this lecture if you want, or to move on together with me to the next video, where we're now going to start talking about loops. When we talked about the if-else statement, I mentioned that it's a control structure, and also that there are more control structures, right? Well, one of the other control structures are loop. And so loops are our final big topic in this JavaScript fundamentals section. So loops are a fundamental aspect of every programming language because they basically allow us to automate repetitive tasks. So tasks that we have to perform over and over again. And here I like to use the analogy of a gym. So when you go to a gym, you might, for example, lift weights, right? And let's say that you do 10 repetitions of a certain weightlifting exercise. So we could represent that by doing something like this. So lifting weights repetition 1. And then some more emojis here. Okay, so repetition 1. And remember, we want 10 repetitions. So we would have to paste this code here 10 times. And I don't know even if this are 10 times or not. But anyway, you can start to guess that this is probably not a best practice. Just imagine that we had 30 repetitions instead of just 10. And then if we wanted to, for example, change some word here in this string, then we would have to change that in all of them. So this really violates the don't repeat yourself principle, right? Because we're basically repeating the same code here 10 times, and all we're changing is just this number. So instead of doing all this, we can now create a loop and then put one of these lines of code in there, and the loop will then run that code over and over again until we tell it to stop. And so let's implement a so-called for loop now. And that's a loop which has a counter. So let's do that. And we simply write for and open parentheses. So a little bit like the if statement, and this is a for statement. And so it looks similar. Now the loop statement has 3 parts. The first part is the initial value of a counter. And in the case of this current example, the counter is the value that will start here at number 1 and go all the way to number 10. So let's call this counter rep, which stands for repetition. And so here we literally create a variable called rep. And we start it at 1 because, well, that's our first repetition. Okay? And here we need to use a let variable because this counter will later be updated by the for loop. So that's the first part of the for statement. Then we use semicolon and go to the second part. And the second part is a logical condition that is evaluated before each iteration of the loop. So before each time that the code in the loop is executed. So let me just write it here first, and then this will make more sense. So our condition will be rep needs to stay below or equal 10. So again, this condition that we just described here will be evaluated before each iteration of the loop. Now, if the condition is true, then the next loop iteration will run. But as soon as this condition is false, then the loop stops. And so no more code will then be executed. So basically, the loop will keep running while this condition stays true. And this is really important to realize, and let me actually write that down here for you. So for loop keeps running while condition is true. So this is the kind of notes that I hope that you are taking throughout the course, but this one is really important, and so I wanted to write it down. Okay, and so now I hope it makes sense that we have this condition, because in each iteration of the loop, the rep counter will get increased. And so at a certain point, it will reach 10, and with 10, this condition is still true. So 10 is still less or equal than 10. But then after that, it will be 11. And so then repetition is no longer less or equal 11, and then the loop will stop. And at that point, we will have printed these 10 strings, basically. So let's continue writing this so that in the end, we actually make that work. So speaking of increasing the counter, that is actually the third part of the for statement. So another semicolon here. And now here we actually update the counter after each iteration. So that's necessary because right now the counter would just stay at 1 forever. And so this condition here would never be false. And so what we do here is to now increase the counter by 1 after each iteration. So we can say rep equal rep plus 1. But does this look familiar to you? So basically increasing the value by just 1. Remember that in the last section, we actually learned about a special operator which does just this, but in a much simpler way. So instead of writing rep equal rep plus 1, we can simply write rep plus plus. And so this will take the rep value and increase it by 1. All right. And now all we have to do is to write the code that we want to be repeated. And so let's copy this string here. Okay. And let's say 1, and then it will print this string 10 times. So let's start with that. And then afterwards, I will show you how we can actually update this number here. But for now, let's try this out. And actually, let's comment this code out so that it doesn't get in our way. So command / for that. And let's go. And indeed, we see that the string was printed 10 times. That's what this 10 here stands for. So the DevTools will not print the same string 10 times. It will simply put this 10 here. But what matters is that this logic here actually worked. So now let's actually use this counter variable that we created here to actually increase the number in the string that we're printing out. So how do you think we will do that? Well, it's actually simple. All we have to do is to replace this number here with the current value of the counter, because this variable that we defined here, so this rep variable, it's just a normal variable, and it's going to be available here inside of this code block. So let's transform this to a template string so that we can then insert that variable into the string. So we get rid of the hard-coded value, and now we basically dynamically build the string. And so here, all we need to do is to put the rep variable. And now we get exactly what we wrote here manually in the beginning, right? So that works. And so let's recap exactly what we did here. So we wanted to log our string here, so a string like this, 10 times. But of course, it could be any other repetitive operation. Again, we're just using console.log here so that we can see the result in the developer console. Anyway, in order to solve this problem of not having to repeat the same code over and over again, we used a for loop. And so we initialized the counter of the loop at 1. So right here, we created this new rep variable, and rep again stands for repetition, but it could be any other variable name, of course. And so we started at 1 because, well, we wanted to start at repetition number 1. But we could also start, of course, at repetition 5. So let's see how that looks like. And then, as you might have expected, the first repetition that's printed is the number 5. Okay, but let's put it back to 1 now. So after each iteration of the loop, we then increase this counter value by exactly 1. And this happens by the end of the iteration. So in the first iteration, this string here is logged to the console with the current repetition, which stands at 1. So this here will be replaced by a 1, and then afterwards the rep counter will be updated to 2. Then in the next iteration, this same string here is printed, but now with rep at number 2. Then rep is updated from 2 to 3, and so on and so forth. And these loops keep running while the rep variable is less or equal 10. So basically, while this condition here is true. And that's how we achieve exactly 10 repetitions. So what the loop does is to verify before each repetition if our condition here still holds true. And only if it does, it will keep running the loop. So it will execute the next iteration, and so it will execute this block of code here one more time. And of course, we could change it to something else. Let's put it at 30, and then we should get, indeed, 30 repetitions of the same string where only this counter here is changed. All right, and in a nutshell, that's how the for loop works in JavaScript. In the next few videos, we will see some more useful applications of the for loop and also talk about another type of loop that we have in JavaScript. Let's now explore some more features of the for loop and also create a somewhat more useful example. And one of the most used applications of for loops is to loop through arrays. So let's get back the array that we were using before. So where is that? So I mean the one where we talked about objects. Yeah, this one. So go to this lecture about Introduction to Objects and then grab this Jonas array. And maybe you didn't write it back then, but then you can just write it right now. Okay, and so now we can use a for loop to loop through this array. And let's say for now that we wanted to individually log every element of the array to the console. So very simple. All we want to do is to log these 5 elements here. So let's write a for loop. And as always, we start with the counter. So let, and now a traditional counter variable name has been I for a long time. And so let's use that here as well. So just I, and this time we need to start it at 0. And that's because the array is 0 based when it comes to reading elements out of the array. Remember? And this will make sense once we actually write the code of this loop. Let's now actually skip the condition for now. So we're going to deal with that a little bit later. And so now updating the counter is going to work exactly the same as before. So since we want to log all of the elements, we need to update the counter variable simply by 1. And so again, we use ++. Okay, and now let's write our loop here itself. So console.log. And remember, all we want to log to the console is each element of the array. And so without the loop, we would write that like this. So Jonas 0, right? And then let's do that outside. So we would do this, this, and then all the way to number 4. Right? So let's comment this out, but this is helpful to see what kind of code we want to achieve. So again, we want to start at Jonas 0, which is the first element. Jonas 1 is this one, then 2, 3, and 4. And so that's the reason why we started the counter at 0, because that's the first element that we want to get. It's Jonas 0. And so here, instead of hard coding the 0, of course, we are going to use our counter variable. So, and that's I. And now the trickiest part here is the condition. And so that's why we left it for the end. But now we need to actually tackle it. So for how long do we want to keep this loop running? Well, it should run when I is 0, right? It should also run when it's 1, 2, 3, and 4, because 4 is the last element. But when it's 5, it should no longer run, right? And that's because Jonas at 5 does not exist. Let's just write that. Does not exist. And so that means that the I counter variable should always stay below 5. So let's write that here. So I should stay below 5. And so with this, as soon as the counter variable is updated to 5, then the next iteration of the loop will not run anymore. So let's try this. And here it's of course not Jonas, it's Jonas array. So let's actually change the name up here in the array itself. Try that again. And yeah, we get a log of each of the elements in the array. So all of the 5 of them. Great. But there's actually still one problem with this, which is that we hard-coded the length of the array here with 5. So let's now say that we add another element. Let's say just true. And so if we try this now, do you think that true will be logged here as well? Well, it will not, because of course we are still telling JavaScript that I should stay below 5. And so it will not print the array at position number 5, which does now exist. So now we do have Jonas at position 5, right? And so the solution to this is to not hard code the value here, but to compute this value. So basically to get it from JavaScript itself. And how can we get this number? Well, actually this 5 is simply the length of the array, right? Not of this one anymore, but of the original one. So this array has a length of 5. And so 5 is exactly the number that we put here. And so we can simply replace the hard-coded value with a dynamically calculated one. And that's Jonas.length. Remember? So let's try that. And indeed, it still works. And if I now go back to adding something else, like true, then Jonas.length will now be 6. And that of course happens automatically, and we don't have to manually change any code in that loop. So now indeed true also appears here in our log. Great. Let's now also log something else here. Let's say the type of the variable. So type of Jonas I. And I hope that this part here makes sense. So the fact that we're using the counter variable here to retrieve all the elements of the array. So now let's say, so string, string, number, string, object. So remember how I said that an array is in fact an object, and here we have the proof of that. And then finally the last one is of course a Boolean. Okay, so I hope that this logic here made sense. And so this is, in a nutshell, how we loop arrays using the for loop. Now, what we did here was only to read values from an array. But now let's also at the same time create a new array which will contain this type of each of the elements. So basically this. All right. So again, what I want to do now is to create a new array which will contain all the types for all these elements. And if that sounds a little bit useless, then just keep in mind that these are all just educational exercises. So I designed them to show you how these different features of the language work. So in the real world, we would probably not create an array with types of variables. But this is excellent to show you how to create a new array based on the values of one original array. So to do that, we start by creating a new empty array outside of the loop. And let's do that here after this one. So I will call this one types. And now I think this is something we didn't do before, which is to simply create an empty array. And all we have to do is to basically create an array with the usual syntax, but without any element inside of it. And so now we have to go here to the same loop, because this new array types will be based on the Jonas array. So it's going to have the same length. And so we can use the exact same loop that we used to read data from the Jonas loop, also to construct this new types array. So let's say types at position I should be equal to type of Jonas at position I. And remember that this works because we can essentially do this. So we could do it again without the loop and say types 0 is equals string. So this would work, right? And so of course it also works with the index number here dynamically. And so that's exactly what we're doing here in the exact same way as we read data from the Jonas array. Right? So in iteration 0, we will have type 0 equals type of Jonas 0. Then in the next iteration, we will have types 1 equals type of Jonas 1, and then 2, 3, 4, and 5. All right. So just to see if that works, let's then log to the console this newly created, or to be more accurate, this newly filled array. So let's see. And indeed, now we get this array, which has exactly the types that we can see here as well. So string, string number, string, object, and Boolean. So these 6 that we also have here, which means that we achieved our goal here. Now, this is just one way of filling an array. And let me write that down here. Filling the types array. And here we do basically reading from Jonas array. But this is just one way of doing it. So let's comment out this one and do it in another way. And do you remember how to add elements to an array in another way? Well, we could use the push method, right? So that would be types dot push. And remember that push adds a new element to the end of the array. And so here we now need to pass in the element that we do want to add on to the array. And so that's again type of Jonas at position I. So of the current counter. And so if we try this now again, we should get the same. And it's important that we add the new element to the end of the array and not to the beginning. So we really need to use push here and not unshift. So I think that this way of doing it here is actually a little bit cleaner. But if you prefer this first way here, then of course you can just use that one as well. But what matters here is that we really understood the logic of how to construct all the different parts of this for loop in order to loop the array. So it starts with the counter being 0 because that's the first element of the array. And then this condition here, which specifies that the current index always needs to stay below the length of the array that we're looping through. And then in the loop itself, we always get the current element using the current counter, which is going to go from 0 to the length of the array minus 1, basically. All right. And to make sure we really get this, let's try another, maybe more practical example. So let's go back to having an array of birth years. So 1991, 2007, let's say, 1969, and 2020. And now what we want to do is to calculate the ages for all these 4 birth years here. And we want to store them in a new array. And that's a very common type of operation, which we actually already did before, but without using loops. So essentially that's what we did in the tip calculator challenge. So yeah, here. So here we had an array of 3 builds, and then we manually calculated the tip for each of them. So manually we specified the index 0, 1, and 2, and created a new array based on these values. But in the real world, we would have used a loop to do that. And so that's what we will do now. Okay, just with another, a bit more simple example. Years is the array which contains the birth years. And now let's create another, and again, empty array, which will then hold the ages. And so what we're going to do now is to loop through years and then fill up these ages array. So 4. And then once more, let's define the counter at 0 for the same reasons that we did it before. And it's not a problem that this counter variable here has exactly the same name. Then the condition is also going to be the same. And actually the whole loop always kind of looks the same when we loop over an array. So now here the difference is that it's of course years dot length. And then at the end we, as always, increase the counter by 1. And now what we need to do is to calculate the age of the current year. So that's going to be 2037. So as always, that's the year that we're currently in, let's say, and then minus the current birth year. So how do we get that? We say years at the current loop position. Okay, so that's nothing new, I hope, now at this point. Okay, so we have this calculation now, and now we want to add it to this new empty array. So we say we want to push it to that array. And so we use the push method to do that. So ages dot push. And so this is the value that we want to push into this empty array. And that's actually it. So let's check it out in the console. And here we go. So just to confirm, 2037 minus 1991 is of course 46. And let's just do it with 27 as well, 2007, I mean. And so that's 30, which is this one. And so this array result is correct indeed. So what we essentially did is this. We cannot do operations between simple values and an array. So that I showed you earlier, right? We cannot do 2037 minus the years array. That will just give us not a number. And so here in this loop, we basically did it individually. So we did the calculation one by one. In each iteration of the loop, we calculated 2037 minus this year and then added it to the first position in the ages array. Then we did 2037 minus this and put it at the end of the ages array again. And then the same for this one and for 2020. Great. So that is a very, very useful and important application of the for loop. And now to finish, let's learn about 2 important statements for loops. And that's the continue and the break statement. Let me just write that here. Continue and break. And let's start with continue. So continue is to exit the current iteration of the loop and continue to the next one. On the other hand, break is used to completely terminate the whole loop. So let's see 2 quick examples for that. And let's go back to actually this first loop that we had here, where we looped this Jonas array. So I will just copy this because we already learned how to loop through the array, and now I'm just interested in showing you how continue and break work. So let me delete this and this as well. And now let's say that for some reason we only wanted to print elements to the array that are strings. And the continue statement is perfect for this. Because again, with continue, we can exit the current iteration of the loop. So what we can do here is to say, if the type of the current element, so of Jonas I, is not a string, then continue. And so that's how we write the continue statement. It's really just this continue keyword. So again, what we want to do here is to only log strings to the console, which means that everything else should basically be skipped. And that's what we do here. So we say if the type of the current element, so that's this one here, so if the type of the current element is not a string, then continue, which again means that the current iteration of the loop is exited and then the next one starts immediately. So let's just write some other note here to the console just so we know what we're doing here, like only strings, because otherwise the output here is going to start to look a little bit confusing. But anyway, let's test this now. And indeed, we only get strings now. So these three are strings and all the other ones are not strings. So this number, this array, and this boolean, so they will now not get printed because we basically skipped them. For example, that age number, which is 46 here, so the third element, does have the type number here, right? So it's not a string, and so this here will be true because, of course, number is different than string. And so this is true, and so this code here will run. And what continue will do is that it will immediately exit the current iteration. And so this line of code here will not be executed in the current iteration. It will not even be reached. Okay? And now finally, let me just show you how break works. And remember that what break does is to completely terminate the whole loop. So not just the current iteration. So what we want to do now is to log no other elements after we found a number. So essentially, after a number is found, which will be this 46 here, nothing else should be printed. So let's do that. And I will again copy all of this. And so let's say here, break with number. So let's translate the logic that we just said into the code. So as soon as a number is found, we want to break the loop. So our if condition here should be type of Jonas I, so the current element, if it's equal to a number, so now that's number, then break. Now, okay, let's see the result here. And indeed, that's exactly what we wanted. So after the first number is found, which is this 46 here, nothing else is printed. So in this iteration, where the number is found, not even this line of code is printed anymore, and then the loop is terminated completely. All right, now this might not sound very practical, but believe me, there are some important use cases for continue and break. It's just hard to create some small and isolated code examples to show you just how useful they can be. But anyway, I wanted to let you know that continue and break exist. But the most important takeaway from this lecture is definitely to understand how we can loop through arrays using this kind of logic here. Okay, so this one here is really important that you understand this snippet of code. In this lecture, we're going to do two interesting things. First, we will loop over an array backwards, and then second, we will also create a loop inside another loop. So let's have some more fun with arrays now. And so let's get back our array again here. So the Jonas array. And let's forget about this element here. And so now, as I said in the beginning of this video, let's now loop over this array backwards. So the first element that we want to print is this one, then this, and finally Jonas. So essentially, in the last lecture, we looped from the beginning. So we started with index 0, then 1, all the way to 4, right? But now we want to start at 4. Then we want to go to 3 and all the way to 0, which is going to be the last index. So this one is 4 and this one is 0. And so now we need to create the for loop according to this new information. So basically according to this new methodology. So let's start again with the counter. And we'll name it I again. But now what should be the initial value of the counter? And we already replied to that question kind of. So it should be 4. But should we just write the 4 here? No, we shouldn't, right? Because we already learned that hard-coded values like this are not a good idea. So what is 4? Well, 4 is basically just the length of the array, which is 5 minus 1. So that's exactly what we will write here. Jonas.length minus 1. Then the condition. And when do we want the loop to stop? Well, it should stop after the 0. And so the condition we need to write, remember, is telling JavaScript in which condition the loop should keep running. And so basically the loop should keep running as long as the counter is still above 0. So I should be greater or equal, actually, 0. So let's quickly simulate that. So at number 4, which is in the beginning, I is greater or equal 0, right? So this condition will be true. And so the next iteration will run. Then we need to decrease the index or the counter. And so let's actually do that as well. And so instead of using I++, which we used before to increment the value, we use minus minus to decrement or to decrease the value by 1. And so now we move from 4 to 3. And 3, of course, still is greater or equal 0. Then all the way to 0. And so 0 is still greater or equal 0. Then the counter gets updated again, and it will be updated to minus 1. And now minus 1 is not greater or equal 0. So this is false, and so the loop will stop. Okay, so I hope that this was not hard. Really, all we have to do is to think when we create these 3 parts here of the for loop. And I hope that you could follow my train of thought here. Now anyway, the rest, of course, is going to work just exactly the same. So we're getting, again, the current element. So let's check that very quickly. And yes, great job, it works. And just to really show it, let's also log the counter variable itself. So first the I, so the counter, and then the array value. And so indeed, this works just as we intended. We start with number 4, just as we have it here. And then we move to 3, 2, 1, 0. And if we now edit one element, then for sure, this is going to work just the same. Because now Jonas length is 6 and minus 1 is 5. And so it will start here at true. And indeed, it does. All right. Now you will probably not be doing this all the time in your own code, but I thought that this was a nice exercise so we could again think about how to define the counter, the condition, and the counter update. Okay, so that was the first part of this lecture. And now I want to show you how we can create a loop inside of a loop. So does that sound crazy? Well, it's not so crazy. And it's not so difficult either. And to do this, let's go back to our gym example from the first loop lecture. So there we had 10 repetitions for a certain weightlifting exercise. Remember? But now let's say that we have 3 different exercises and we want to repeat each of them 5 times. So that means a total of 15 repetitions, 5 for each of the 3 exercises. So to log all these exercises, we will need a loop inside a loop. So let's roll up our sleeves and get to work here. And we're going to start with the 3 exercises. So let's create a counter, and I will actually call it exercise. So exercise, and we start at 1 now this time again, because we simply want to log exercise 1, 2, and 3. So our condition here is that the exercise should be less or equal 3. And actually, this would be exactly the same as writing exercise below 4. So you can do whatever you prefer most. And I think I will actually stick with this one this time. And then we need to increase the exercise after each iteration as always. So now let's log to the console something like this. Starting exercise, and actually here we want to include the exercise number. So let's instead create a template literal. And so here we use that counter variable. So let's just check this one. So we have 3 exercises, but we don't have any repetitions yet in there. And so now, again, we need to create a loop inside a loop so that in each exercise, we can have the 5 repetitions that we want. And the repetitions themselves are a loop, right? And so that's why we now need that loop inside of this loop. So let's do that. And this is going to be basically the same as we did earlier. So let's again call it rep, start at 1, and then the condition. So remember how I said that we want 5 repetitions this time. And so let's say we want to stay below 6. So again, that would be exactly the same as writing less or equal 5. But let's keep it a bit different this time and say below 6. And then rep plus plus. And now lifting weights, repetition. And again, I forgot to make this a template literal. So yes, this should work much better. And now this cute emoji here again. Oh, where is it? And let's test this now. So what do you expect to see? Think about that before you load your own result or before I load here the result. So, is this what you expected? Let's even increase this here a little bit. And now we see the full picture. All right, so we start exercise number 1, which is what we have here. And then inside of this iteration of exercise 1, a new loop is created and executed. And so that's what then creates this lifting weights repetition from 1 to 5. All right. Then this loop here is finished, right? So it run all the 5 times, and then this first iteration is finished. And so the exercise loop, so this outer loop here, goes to its second iteration. And so we are at exercise number 2. And then this whole loop here will run again from 1 to 5. So that's these 5 here. And then that loop again finishes. And then the exercise iteration finishes. And we go to iteration number 3. So exercise is now number 3. And then the whole repetition loop So this inner loop here will run 5 times again. And with that, we end up with a total of basically 15 repetitions, just as I said in the beginning. So 3 times 5. Okay, and we could even include the number of the current exercise in this string that we're printing here. So let's do that as well. Exercise and then exercise. So this is the variable that we get from the outer loop. And so this variable here is of course available inside this whole loop. And that does include all the inner code, even this inner loop. And so that's why we can access this variable here as well. And so now we should see exercise 1 printed for these 5, then exercise 2 printed for these 5, and exercise 3 for the last ones. And yeah, beautiful. All right. I think this was a very fun exercise. And again, even though you might not use this all the time in the real world, I still think that this was a pretty cool example to show you some more power of loops. And now to wrap up this section, all there is left to learn is another type of loop, which is the while loop. All right, so we learned all about the for loop and even created a loop inside a loop. But there is another type of loop in JavaScript, and that's the while loop. So let's explore that one now. And to understand how the while loop works and the difference between the for and the while loop, let's actually go back to our first for loop lecture and get back the code of this weightlifting exercise. So just copy this and we will keep it for comparison basically. So let's put it back to 10 here as well. And so let's now do the same thing with a while loop. So implementing the same with a while loop, we still need the same components. So we still need a counter so that we can then actually print the current value to the console. We still need a condition so that we know when to stop, and we still need to increase the counter somehow. Now in a while loop, it works a bit differently because for the while loop, we can only specify a condition. So while, and then just the condition is the only thing that we can specify here. So that's going to be exactly the same as this one. So we want to keep the loop running while repetitions is less or equal 10. And that's actually why this loop is called while. So again, it's called the while loop because it will run while this condition is true. All right, but now we need to kind of manually, so more explicitly define the other two components of the for loop. So the repetitions and the increasing of the counter. And so we need to do that basically outside. So we start at the beginning with rep equal 1. Then we have the condition. Then let's put the code that we want to execute. And then at the end of the iteration, we will then increase the counter. And so let's just do that. So at the end of the iteration is basically the end of this code block. And so let's do that there. And that's it. And so now we should get the exact same result twice, once coming from this for loop and once coming from this while loop. And yeah, so 1 to 10, and then again 1 to 10 coming from the while loop. Just write that here, just to make 100% sure. Yeah, and indeed, the second set here is coming from the while loop. So this all means that the while loop is more versatile than the for loop, which means that it can be used in a larger variety of situations. And that's because it does not really need a counter. So we put the counter here because we need it for this specific use case. But all the while loop really needs is the condition, which needs to stay true for it to keep running. And that condition can be any condition. It doesn't have to be related to any counter at all. And sometimes that's exactly what we need to solve a certain problem. So a problem without any counter. So without a number that is increasing. And so let's create such an example here. So I will start by taking off this for loop. We no longer need that one. And now we will do a simple example that does not depend on a counter, but instead it will depend on a random variable. Okay? So what we're going to do is to basically roll a dice and then keep rolling the dice until we roll a 6. And then when we roll a 6, we stop. So essentially, we will want to keep running the loop while the rolled dice is different from 6. And so in this case, we do actually not know beforehand how many times the loop should run. And so we don't need a counter variable. And that's exactly the use case of a while loop. So let's start by creating that random number. And so the roll of a dice is a number between 1 and 6. The way that we implement this does not matter at this point. Okay? We will learn more about random numbers at a later point. And so for now, basically just type what I am writing here. So we're using math.random, and this will create a number between 0 and 1. Then we multiply that by 6, but this is going to be a decimal number. Let me just show that to you quickly, because I think this is still interesting for you. So you see that it's a decimal number, and so now we need to get rid of this decimal part. And so that we do using math.trunc. And so this will give us a number between 0 and 5, and then we add 1 and get 1 to 6. So again, don't worry about the implementation of this at this point. We will do this again later. But what matters here is that as we reload the page, we get a random number here that is different every time. And so it will be different for you, of course. So different from what you see in the video as you keep reloading your own page. Okay, and so now let's do what I explained earlier. So again, we want to keep running the loop until we roll a 6. So until this dice variable here holds the value of 6. And so the condition of the loop is now going to be dice different from 6. And as soon as the value is 6, it will stop. And let's log the value to the console here. So you rolled a and then dice. And so let's get rid of this one here. And now let's log it to the console. But keep in mind that actually right now we are only creating one dice value. So at this point the loop doesn't make a lot of sense. And so actually let's keep working on this before we test it. So again, we are only creating one random number between 1 and 6 here, right? And if that's different than 6, this loop here will run. But right now, the loop would then run forever, which I'm not going to show you here now because that would crash the browser. So this would be called an infinite loop, and we don't want that. So what we will do is to keep creating new dice values. And so we are going to reassign this value at the end of each iteration. And so now we're ready to test the result here. Whoa, you see we got a lot of dice rolls here. Let me actually also comment out just this console.log here. And so of course your result will be different from mine because we are using different random numbers. But anyway, let's analyze what happened here. So we start with some random dice number, and then here we check if that dice is different from 6. And apparently it was different. And so then we entered the loop, which then logged you rolled a 2. So my random number was first a 2. Then in the next line, we created a new random number, and then the loop ran again. So again, this condition was tested. So is the dice different from 6? And apparently it was. And so we entered the loop again. And so it printed, you rolled a 1. And then the next dice was a 5, and then the next one was a 4. But then apparently the next dice that was rolled here was a 6. So at the end of this iteration here, this dice value was a 6. And so then in the next iteration, dice was actually equal 6. And so then the condition is no longer true and the loop stopped. And let me actually write one more line of code here in which we can say if dice is 6, then log loop is about to end. And so this way we can know when a 6 happened. And so the very first thing that should ever happen here in this output is this, right? Because then when the dice was 6, the next iteration will no longer run. So let's do that. And indeed, so we get 1, 5, 4, 1, but no 6. And then loop is about to end. And so the dice was 6. And so this condition was true. And so we saw this log to the console. And then in the next iteration, again, 6 equals 6. And so the loop finished. Let's try some more times. And of course, it works. Oh, and now we get the situation where the first dice ever was a 6. And so the loop never even started. And this was the situation I was waiting for here. So when dice is 6 right away in the beginning, then of course this loop will have exactly 0 iterations. It will never start. Okay? And so the conclusion of this is that the while loop does really not have to depend on any counter variable. So whenever you do need a loop without a counter, you can reach for the while loop. So basically, that happens whenever you do not know beforehand how many iterations the loop will have. So in that situation, the while loop is the right tool for the job. And that's exactly what we had here. So we had no way of knowing how many times we would roll a dice that's different from 6. Now, on the other hand, when we do know how many times the loop will run, that means that we're going to actually need a counter. For example, when we want to loop over an array, we already know how many elements that array has, and so we know how many iterations we will need. And therefore, the for loop is usually the right choice to loop over an array. All right, and with this, we kind of finished the JavaScript fundamentals. All there's left to do now is for you to complete the final coding challenge of this section. Okay, and let's start by grabbing the calc tip function from earlier. So that should be here. Okay. And that's why we keep all the code in one neat file like this. Next up, we create the builds array. And this one has quite a number of values, but we can just copy them. They're already almost in the correct format. So no end, but a comma. Then we create the empty tips and totals, const tips equals an empty array, and const totals another empty array. And now is where the magic starts. So basically where we will calculate the tips and the totals. So that is question number 3. So use calctip to calculate tips and total values. So essentially what we will do is to loop over the builds array and then fill up these two arrays. So for let I equal 0, And we want this to run while the counter is less than the length of the builds, which is 10. And so the last index is 9. And so that's the last element that's going to be taken. And now in here, let's start by calculating the tip and store it in a variable. So const tip is equal, and now we're using the calcTip function. So we call it using parentheses, and now we need to pass in the bill value. And what is the bill value? Well, it is just the bills array at the current position. And now you might wonder why I am able to declare this tip variable here as a constant. Am I not changing it in every loop iteration? Well, actually that's not what happens. Actually, in each iteration, a new tip variable is going to be created. So we're not mutating, we're not changing the original tip that we declare here. In each iteration, we will simply create a new one. And that's why we can use const. Anyway, now we have the tip calculated. And so we just need to push it into the tips array. So tips.push, and here the tip. And finally, we need to push into the totals. So totals.push the tip plus the current bill. And we already know that that is bills I. Okay, and that's actually it. Now you could have done it in a different way. For example, without this variable here at all, you could have just put this code here and here. But then you would have calculated the value twice, and that's just not necessary. We just calculate it once, and then we use it both to push the value into the tips and into the totals. Okay, and now as always, let's check all the 3 arrays out in the console. And whoa, that's a lot of numbers. But just by quickly looking at them, everything looks correct. Great, that's really great. We basically just did the same as we did in the previous version of the challenge, but this time we did it using a loop instead of manually creating the array by calling calcTip with builds 0, 1, and 2. So that's what we did in the previous challenge, but this one is a lot better. Because now, no matter how many builds we have here, the loop will take care of all of them at the same time, basically. Okay, so that's the basic challenge. I hope you arrived at the same result that I did, no matter how you solved it. And now let's go for the bonus here. So we're writing a function called calcAverage. So const calcAverage. And once again, I'm using a function expression here, which is my favorite kind of function, I would say. And as we said, we will receive an array, and any array here will work. So once again, we're building a generic function which does not care what kind of values it's going to receive. It can receive builds or tips or scores or heights or masses or whatever, really. It doesn't care what the values are. And that's also why I gave it this generic name. So it's just calcAverage and not, for example, calcAverage totals. Let's now do what we say, or what I say here in 4.1, which is to start creating a sum variable that starts at 0. Then as we loop over the array, we will keep adding the current value to that variable. So this time it needs to be a let, because this sum will of course be updated as we loop over the array. And now all of this is pretty standard at this point. So equals 0. I should stay below the array dot length. And so this time array is simply the array that we're receiving in this function. So it's this parameter. And now, as I said, as we loop over the array, we will keep adding the current value to the sum. So what I mean is sum will be equal the current value of sum plus the array that we received as an input at the current position. And that's it. We're just missing here the increment of the counter, but that's easy to fix. And this one here could be even more condensed. So let me just copy this one and comment out the original one, because remember that we have a more shorthand operator in JavaScript, which we can use when we want to update a value. So instead of sum equals sum plus, remember we can write sum plus equal array I. So this one is exactly the same as this. So if you prefer, you can write just this version, but this here is going to do exactly the same thing. Okay. And just to see if this works, let's actually test this now by logging only the sum. So console.log sum. And now, again, to test it, I will just call the function calcAverage with simply an array of sum values. So 2 plus 3 plus 6. And we know that this will be 11, right? And so now we can test this function here just to see if this first part that we just wrote works. Let's see. And yes, we get 11. And so this logic here is correct. So we got this array here into the function. Okay, and so R is now 2, 3, 6. And so that's the array that we're then looping over. Okay, so we end up with the sum. And now what we want to return is simply the sum divided by the number of elements in the array, which remember is r.length. And that's it. You can now get rid of this, but now we need to log the result to the console if we want to see it, because this function here now does not log it, it simply returns it. And remember that that is a big difference. So we know that the sum of this is 11, and 11 divided by 3 is something like close to 4. So we could change this here to 7, then the sum would be 12, and 12 divided by 3 is 4. And so then we can make sure that this function works. So it is 4, so great. This means that the function now works. And so now we can use this function to actually calculate the average total. And so here we simply use the totals value that we already created before. And that's it. So the average total value of all our builds plus tips is 275 and 19. And let's actually do the same with the tips themselves, just to get an idea of the kind of tips that were paid here. So the average tip is 42.89. Hopefully that part here was not too confusing. But if you go slowly through the code step by step, you will understand it. All right, and with this, we finished the complete JavaScript fundamentals. So we made a ton of progress here. So congratulations for making it this far. Great job, really. However, as you know, we are really just getting started here. There is so much more to learn. And actually in the next section, we will quickly configure our VS Code editor a little bit better and also set up a better development environment. So that's going to be super useful for writing code a little bit faster. And I will also teach you some developer skills that every developer should really have. But as always, before moving on, make 100% sure that you understood all these fundamentals from this section and the previous section. So if you want, you can redo the challenges, or you can come up with your own small problems or ideas to solve. And by doing that, you will reinforce all these tools even better and ultimately become a better developer faster. Then, when you're really ready, let's together move forward. Congratulations on finishing the introduction to JavaScript. So you mastered the absolute fundamentals, but there is still a lot of content ahead. In fact, there's over 50 hours of video left in this course. However, I know that this is way too much for some people. And so let's now take 5 or 10 minutes to plan your unique journey through this course, so that you can achieve your own learning goals. Now, to start, keep in mind that this is, after all, the complete JavaScript course. And so it makes sense that it covers everything and has a lot of big projects and challenges. That's the reason why this course is so long. But here is the thing. You don't need to watch the entire course to become really good at JavaScript. There are many lectures and some sections that you can safely skip and still become a great developer. Now, watching the entire course is of course the best option. So if you're planning on doing that, then just go to the next section. But if you don't have the time, or if you really want to focus only on the most important parts and on your own learning goal, then just keep watching. So, to help you navigate through this massive course according to your goals, I created a couple of different pathways through the course and also a roadmap for each section. So, a section roadmap is basically an overview of each section, which will tell you exactly which videos are the most important ones, which ones are not that important, and which ones are optional. And you can find these roadmaps at the beginning of each section. And so, by using them, you can focus only on the most important videos if you want, and therefore complete the course a lot faster. So the section roadmaps tell you which videos you may skip, but you might also want to skip entire sections. So sections that you don't need to watch in order to achieve your learning goal. And so that's where the course pathways come into play. So I defined these 7 learning goals that you might have and selected the sections that you should watch in order to achieve that goal. And the 7 pathways are in a PDF document that you can find right in the next lecture. But just as an example here, your goal might be to learn only the most important parts of JavaScript. And this might actually be a great goal for Udemy for Business students who are probably watching this course at work. Now, in this case, your pathway through the course is gonna look something like this. So just like in the section roadmaps, here you can see which sections are very important for your goal, which ones are just good to know, and which ones are optional. And so again, by following a pathway like this, you don't have to watch the entire course if you don't have the time. In fact, this particular pathway actually shrinks the course down to only 24 hours. Alright, so again, the best option is of course to watch the entire course from start to finish. But if you don't have the time, then please take a look at the course pathways PDF document in the next lecture and select your learning goal and pathway from there. And then I see you wherever your path will take you in this course. So now that you're familiar with the basics of JavaScript, it's time to take a small break and take a look at some other skills that you also need to develop in order to become a great JavaScript programmer. So in this section, you will learn how to actually learn to code, how to think as a developer, how to debug your code in case you run into problems, and also how to set up a professional development environment on your own computer. And we're gonna start this section by configuring the VS Code editor to fit our needs a little bit better. And so that will then make coding a lot easier in the rest of the course. And once more, here on my desktop, I already have the starter files for this section. So go ahead and get yours from the GitHub repository as well, even though in this lecture we're not yet gonna need them really. But let's still open VS Code, because of course we're gonna need a VS Code window if we want to configure it. All right, now here on my desktop, of course I choose the developer skills folder, which is the folder for this section. And once again, we have an HTML file, which already has the script linked to it. And then here's also the script file, which has basically nothing. All I put here to get started is activating the strict mode. Because remember that from now on, we should use strict mode in all of the scripts. And so I left it here already so we don't forget it. But anyway, let's now start configuring VS Code, and we will start with a tool called Prettier. And Prettier is an opinionated code formatter, which means that it makes assumptions about how good code should look like. And so if we install it and use it, then this will make sure that your code is nicely formatted, and also that it will look exactly the same as my code looks in the video. So that's gonna make it easier for you to take this course. And also, of course, for you to write your own code in the future. So this tool is available as a VS Code extension. So let's click this extension button here. And then here all you have to do is to search Prettier. And it's gonna be this first one. And I, of course, already have it installed. I just need to enable it. So I click here on enable, but you will have to install it and then probably reload VS Code. So I enable it, and so now it is working. So install it on your end and reload the browser and then come back here. Okay, so let's close the sidebar here again. And so installing this plugin was the first step. The second step is to now actually define Prettier as the default formatter of our code. So let's go here to Preferences, Settings, which should look something like this. And then here in the search bar, let's search for default formatter. So that's this one here you're looking for. And you see we have this huge list of available formatters. But the one that we are looking for is this esbnp.prettier VS Code. So this one should be here in case you successfully installed Prettier before. And so let's just click this here, and then we should be good to go. We just need to make sure that the format on save setting is also correctly set. So format on save. And we did this actually already at the beginning of the course. But in case you skipped that video for some reason, then just make sure that you actually tick this box here. All right. And so with that, Prettier should now actually be working. So let's just declare a variable down here and give it a couple of lines of space. And then simply x equal to something, and then give it a save. And you see that Prettier automatically did some changes to our code. So first of all, it removed all these blank lines that we had here. And it also transformed these single quotes into double quotes. Finally, it also added an empty line of code here at the end. Okay, so these may seem like small changes, but all of them added up throughout all the code can actually make a big difference. And again, Prettier is an opinionated code formatter. So opinionated means that they have a strong opinion, and then basically when we use the tool, we have to accept that opinion. And many people don't like that, but actually I believe it's a good thing. It makes it so that I don't have to take a decision on how the code should look like. For example, some people prefer to write the if-else statement without a space here, and other people like to have a space here. And let's just write something here. And so now, no matter what we do, Prettier will take that formatting decision away from us. So if I save this now, you see that it automatically inserted that space here, even if I don't like it. So if I remove it and save it again, it will be back. All right, but this makes it easier to make your code consistent and to make your code also consistent with other people's code. And in this case, my code that you can see here in the video. And so if we both use this tool, our code will look the same. Now, there are some things that we can configure. And for example, one thing that I don't like is the double quotes. I prefer to use the single quotes. But right now, Prettier will transform every single quote to double quotes. So I add single quotes, give it a save, and you see now they turned to double quotes. And so some things we can actually configure in Prettier. So let me show that to you. So just Google Prettier, and probably the first option here will be this tool. So here we can go to Docs, and then probably here. So here we can do options. So configuring Prettier and then options. And probably the web page looks a bit different by the time you're watching the video, but just search for the options here. So let's take a look at some of the things that we can change. For example, the width of one line, or if Prettier should use tabs or spaces here, or if it should add semicolons or not. But what I'm interested here is the quotes. And so using this option, we can tell Prettier to use single quotes instead of double quotes. And so that's what I want. Now, how do we actually configure Prettier? Well, there are multiple ways, but the easiest one is to create a configuration file in the current project folder. So let's go back to the sidebar here. Then we create a new file, and this one is going to be called .prettier and then RC. Okay, and now here we basically write this object, and it's not really an object because this is not JavaScript code. And so now we write single quote. And actually VS Code already gives us this option here. And then as I hit enter, actually we get this preset value. But I actually want to change it to true. Okay? And if I now give this one a save, and then also save this, then you see that it automatically changed my double quotes back to single quotes. Great. Now, another thing that Prettier does by default is something in arrow functions. So let me show that as well. And closing the sidebar here. So const, let's create a calc_h function again. Then we say birth year, and then we want to return 2037 minus the birth year. So just like we've been using. But now watch what happens when I give it a save. So you see that Prettier actually wrapped this single parameter here in parentheses. However, I actually don't like this. So when there's just one parameter, I like to see it without the parentheses. And so that's another thing that we can configure here. And so that one's called arrow parents. And so now we can choose between always and, well, some other options. So let's just search that here with Command F, arrow parents. So we can choose between always and avoid. And so I want avoid here. Okay? And so you can take a look at this entire list here if you want. And then you can change your own configuration to match your preferred coding style. Okay, and probably by now you don't have yet really a coding style, but it's good to know that you can change stuff that you don't like or that you don't want to see. So for me, this is the two things that I always change, and as necessary, I keep adding more stuff from time to time. So let's close it, give it a save to see if this change is now reflected here. And yeah, so as I saved it again, the parentheses here were gone. And remember that we enabled format on save. And so that's why all these formattings take effect whenever we save a file. All right. Now, if for some reason you cannot make this work, then don't worry. you can still progress in the course without having Prettier working. That's because this tool does, of course, not influence how the code itself works. It's just a visual tool that only changes how the code looks. Anyway, this was already a big step on making coding a little bit easier for us. But now I want to show you something else, which is to basically automate something very boring that we're doing all the time. And that is writing console.log. So whenever we want to log something, we have to write all of this console.log and do all this work. But in VS Code, we can configure snippets which can take that work away from us. So let me show you how. So we go here in the menu into this preferences folder or submenu, and then here we can define user snippets. So click on that, and then you can open one of these files, but the best thing to do is to just create a new global snippets file. So click that and then just give it a name, and it doesn't really matter. I'm just going to call it Jonas here. And so here we can define a couple of snippets. And remember that the snippet that we want to define is simply one that automatically writes console.log for us. And actually there's already an example snippet down here which basically does just that. So it's this here. And so let's just uncomment all of this. So again with command /. And so this here is the name of the snippet. Then here we say that it works in JavaScript and in TypeScript. This is the command that will basically trigger the snippet. And here I like to use CL. So whenever we write CL in the code, it will then expand that to console.log. Then here is the code that will actually be written. And here, get rid of this second line. And then here, also get rid of all of this. Because I found that this is the best way to make this work. And it's not really important that you understand how this works. This is just a recipe that I want you to follow here, just to make our lives coding a little bit easier. So then give it a save, and once you head back to your script, and now write CL, which remember is this prefix, but you could have chosen anything else. But in my case, whenever I write now CL and then hit enter, it will give me console.log. And then all I need to do is to go back and then write whatever I want to log here. Now here we can also define this $1, which is the way it was before. And then this will place the cursor between the parentheses. But then I found that when you do that, the autocomplete in VS Code does no longer work. And so that's why I don't use that. So you see now the cursor is here. But then autocomplete does not work. And in this case, you can't really see that. But if this variable name was a little bit longer, x, y, z, a, b, c, and then x, y, z, so you see that the autocompletion is not working. I would have to go down and go up again, and only then it would work. Okay, and so let's just remove that and call it a day. Okay, so from now on, I will no longer manually type console.log. I will always just do this. Okay, and now to finish, let's just go maybe a little bit over my extensions that I have here, just to show you what I use. So let's remove that search text there. And so these first two are about HTML development, and I'm going to show them to you in the next section. Then these don't really matter. ESLint is a tool that we're going to use later. Image preview is also good for HTML. Then Monokai Pro is the theme that I'm using, remember. Then, of course, Prettier. Then I have settings sync, which is very useful to synchronize settings between different VS Code installations. For example, if you have multiple computers or multiple accounts on your computer. And finally, one that I use all the time is to do highlight. So this allows me to highlight parts of a text. So for example, I can do something like this. So when I write bug in a comment, for example, then it gives me this nice red highlight. Or fix me is another one. So let me show you my settings here that will show how I do that. So that is preferences and settings. And then we need to go here into this icon. And again, by the time you're watching this, this might have changed. But what matters is that you need to open the settings in a JSON format. And so this shows all the settings that I have. And so here is how I defined these, these colored tags. So you need to install the to-do highlight extension, and then in your settings, you just write this kind of code to define different colored tags for different texts. Okay, so very useful one again. Yeah, I think that's enough for this video. This one was not really about coding or anything. It's just to set us up for the rest of the course, and also so that you start getting a feel for a little bit of the tooling that we have in the JavaScript ecosystem. All right, and actually in the next lecture, we will continue doing that. So I see you there in a second. Up until now, whenever we changed our code and then wanted to see the effect of the code in the browser, we saved the code and then manually reloaded the browser. But there is a much better way. So instead, we can make the page reload automatically whenever we change our code in the editor. So let's now learn how. So in the real world, no professional developer reloads their browsers manually like we have been doing. So everyone uses some kind of tool to do that. So to make our life easier as we go through this course, we will now also install such a development tool, which is called Live Server. And we can actually use Live Server in two different ways. First, we can install a VS Code extension, or second, we can use a bit of a more professional workflow using Node.js and a so-called npm package. And let's actually start with the easier approach, which is to simply install the Live Server extension here on VS Code. So that's Live Server, and it's this one here. So just click install as always. And then as we close this, you will see that down here we have this Go Live button, right? And so let's try to log something to the console here now. Or actually, let's try to click this button here first. So you see it says starting, and now it opened up a new browser tab on this address here. So this URL. Okay, then here we click on inspect just to open up the developer console. Let's increase it a little bit. And you see that right now we have no output here at all. And that's because we are not logging anything here in this script, right? And so now let's try to actually change the file. So let's just call the calc_h function here. And now watch what happens as I simply save this file now. So I hit Command S, and you see that here on the other side, the output automatically appeared without me having to reload the browser, right? And if I try some other value, give it a save again, then you see that it updated here again. And so that is the Live Server extension doing its work. Okay, but let's take it back here and actually close this window, because this was only the first way of using Live Server. So as I said before, there is like a more professional way of running Live Server, which is by using something called Node.js, which is a JavaScript runtime that we can install on our computers. Now, if the extension that we just installed works just fine for you, and you don't want to add any more complexity, then you can just skip the rest of this video and move on in the course. But I will actually use the second approach in the rest of the course, which is to first install Node.js and then use an npm package called Live Server there. But again, you can follow the rest of the course just as well by simply using the extension that we just installed. You don't need to install Node.js and the Live Server npm package. But if you're curious and want to see how the second approach works, then let's now quickly go ahead and install Node.js on our computers. So just Google Node.js here, and then it's probably this first result that you saw here. And Node.js is a way of running JavaScript outside of the browser, but also it's a way of running development tools, just like the live server that we want to install now. So go here to Downloads, and then you can use the LTS version for whatever platform that you're using. So Windows, Mac, Linux, just download whatever you need for your use case, then install it, and then come back to this video. Now, if for some reason you cannot do this, or if anything goes wrong, then don't worry. You can, of course, continue this course without using live server. So please don't get stuck on this video if you don't manage to install live server for some reason. Okay? Now, anyway, after you successfully installed Node.js, it will become available as a program in the so-called terminal. And let's use the VS Code built-in terminal. So VS Code has a terminal included, and to open it, we need to go to the menu bar and then New Terminal. Or we can also use this weird shortcut here, but I prefer to do it like this. So let's increase this a little bit, and then I will clear this terminal here by hitting Command or Control K, and that looks a little bit better. I can also increase this by hitting Command plus, and actually that increases the whole window, so that I don't want. So let's go back. But anyway, in case you're not familiar with the terminal, it is basically a way of giving a computer instructions. And we will learn more about the terminal later in the course. This is not the point to worry about the terminal. All I want you to do is to write node -v. Then hit return or enter, and then you should see some kind of number here. It doesn't matter what number, but as long as you see a number, it means that you successfully installed Node.js. So if you have this number here, then you can now write npm install live server -g. And in case you're on a Mac, you will probably need to sudo this command. So start the command with sudo and then npm install live server g. So again, it's not important that you understand what this does. Let me just in 10 seconds tell you that npm is the Node Package Manager, which is basically a program to download tools. Then here we say install, and then here we say that the tool we want to install is called live server, and -g means that it should be installed globally. And that will make the live server tool available everywhere on your computer. So if you're on a Mac, use sudo here before the command, but on Windows you don't need sudo. And it won't work even if you use sudo. Then hit enter, and if you're on a Mac, you now need to enter your password. And don't worry if you don't see anything there. That is on purpose. Just write it anyway, hit return, and then it should start doing something. So right now it is being installed, and I get some errors here, apparently, but I think they are not really important. Anyway, I already had live server installed anyway, and so these errors here, they should be no problem. So we can clear our console again by hitting Command or Control key, like this, and so that looks much better. And now all we need to do is to write live server and then hit return. So try that. And it worked. So it automatically opened up a tab in the browser. So probably in your predefined browser. And this browser tab is now connected to your current project folder. And so in the console here, you can see the folder, which is this one. So developer skills in this case. And so that's exactly the project folder that we are in right now. So whenever you run live server in some folder, that folder will then be opened in the browser. And whenever we open a folder in the browser, it will then open the index.html file by default. And that's why we always have an index.html file in any folder. Okay, so let's open up the console here. Then we get a small error, but as we reload the page, this error will disappear. Yeah, that's right. And so here, let's actually get rid of this. And here, let's log to the console the result of calc h, and then with some year, just so that we can now test this. So when I give it a save, watch what happens here on the right side in the browser. So I will not reload the browser, I will only hit Command S to save this file. And you see, it took like half a second, then the browser reloaded, and now we get the result here automatically. Also, you can see down here in the terminal that a change was detected, and so that's what triggered the reload. So any file that changes in this folder now will trigger a reload. So even if I change something in the HTML file, for example, if I save now, then see how it changed here as well right away. So let's put that back, close it, and actually we can even close this terminal. So if I close it and save it again, you see it reloaded again very quickly, and it's still working. So the terminal, it's still down there, it's just not visible. But we can always get it back by hitting New Terminal. And actually that's a new one, but then just click this menu here and go to the first one that we had, which says Node. Okay, and with this we established a real-world web development environment or workflow. And so now you can really start to feel like a real JavaScript developer, not one of the kind that has to manually reload their browser. So I hope that you find this as cool as I do. But in any way, we are now finished setting up our browser and also our development workflow. So basically, this part here of the section, so the editor setup, and so now we're ready to go a little bit into developer skills, because that's also an area that's important to develop for you as a new developer. And so the next couple of videos will be how to learn and how to solve problems. Now that you have a solid foundation of JavaScript, I want to talk a little bit about the actual process of learning how to code and give you some motivation. I think this is an important aspect of a course like this, but everyone else simply seems to overlook this topic for some reason. So let me share my advice on how you should learn to code as a complete beginner in this video. And to make this a bit more fun, I will start by telling you how to fail at learning how to code. And to do that, meet John. So John has been learning how to code for some time now, but he is failing miserably. He's just not going anywhere. I guess he is just not receiving the right advice. So let's see what John is doing wrong so that you can learn from his mistakes and learn how to code in no time. So the first mistake that John made was that he didn't have a clear goal at the beginning of his learning journey. He simply started by watching some courses and reading some tutorials, but he would just blindly copy the code without caring how it works. Even worse, sometimes he would just copy and paste code from tutorials or sites like Stack Overflow. While learning, he didn't reinforce what he was learning in the courses and tutorials by doing small challenges or taking notes. He also didn't practice coding outside of the courses, and he didn't come up with his own project ideas to improve his skills. Then, whenever he did code a bit, John would quickly become frustrated whenever his code was not perfectly clean or efficient. John also lost motivation pretty quickly because he thought he could never know enough. He could never know all there is to know. And this is a really big mistake. Also, he was just always learning in isolation without sharing his process. Finally, after finishing a couple of courses, He thought he was now a web developer and could start applying to jobs. But no one would take him because recruiters soon found out that he couldn't even build a simple app on his own. So that's a long list of mistakes, but it's not too late for John. We can fix all these mistakes, right? So let me show you how. So the first mistake is relatively easy to fix. What you need to do is to set a goal for yourself. Think about this and actually write it down on a paper or something. Make this goal specific, measurable, realistic, and time-based. For example, your goal might be, I want to become a front-end web developer within 1 year. From there, you can then develop a plan on how to get there. It also helps to know exactly why you are learning to code. For example, are you trying to switch careers? Or do you want to find a better job? Or are you just starting a new hobby? Whatever it is, it's important to be aware of the reason why you're doing this, because this will help you stay motivated when learning becomes more and more difficult. To stay motivated, it's also great to imagine a big project that you want to be able to build by the end of your learning journey. This has always helped me tremendously. With this project in mind, you just need to research the technologies that you need to learn, and then learn them one by one, step by step, in a calm way. Next up, instead of simply copying code from a course or tutorial, always make sure that you really understand the code that you're learning and typing into your editor. Don't move on if you don't understand. Also, always actually type code. Don't just copy and paste it from a tutorial or a site like Stack Overflow. This way, you're training your brain to remember the syntax later. Reinforcing is one of the most important learning techniques. It means that after you learn something new, like a new JavaScript feature or concept, you use it immediately to make it really stick in your brain. You can do this by taking notes and by challenging yourself with small coding exercises and challenges. For example, let's say you just watched the lecture about functions. So now you know what functions are and you saw some examples. But now, as a next step, you need to reinforce this knowledge by writing a function for your own personal environment. For example, you might need to calculate the average of your university grades, or you might need to convert recipe ingredients from ounces to grams while cooking. So just write a function that does this task for you and have some fun with it. Coming up with your own ideas like this and solving them will absolutely boost your confidence in your programming skills. And really take your time with this. There's absolutely no need to complete any course as fast as possible. Alright? Now, it's absolutely normal that in the beginning, it's hard to come up with your own challenges. That's why I included countless coding challenges in this course for you. You can also use a special challenge platform like codewars.com, where you can find thousands of coding challenges for different skill levels for free. I have actually solved some of Code Wars challenges in real life with some students, and I can tell you it's a ton of fun and really helpful. One of John's biggest mistakes was to not practice coding outside of the course environment. But practicing on your own is the single most important thing that you have to do. And I can't stress this enough, okay? Coding your own projects without any course guiding you is really not optional. If you just follow courses and don't code on your own, you will never ever be able to write programs on your own. So come up with your own project ideas, no matter how small or big, and just build them. Or you can copy parts of popular sites or applications. No matter what you do, really challenge yourself, make it difficult, and grow by overcoming obstacles. And I know it's scary to leave the comfortable environment of a course where you just have to follow the teacher, because you will fail and you will make mistakes and it will be difficult to code on your own. But getting out of our comfort zone is the only way we grow. So don't be stuck in tutorial hell, which is exactly the state of not being able to leave tutorials. There is more about this whole journey at the end of this lecture. Now, when you practice, you should never become frustrated with the quality of your code. Do not get stuck by trying to write a perfect code, which is really clean or really efficient. So none of that matters in the beginning. You're still learning, so just write as much code as you can, no matter the quality. Really, clean and efficient code will come with time. Alright? It's just natural progress. Also, you can always come back and refactor and improve code later if you want to. Another important piece of advice I can give you, and I actually give it to myself from time to time, is to embrace the fact that you will never know everything there is to know in web development. Web development is this huge field, and so it's completely normal and acceptable that you will never know everything about web development. So don't put too much weight on your shoulders and create too many expectations. So, in fact, the best developers and teachers have no problem in admitting that they do not know everything, like the legendary Kyle Simpson, who admits that even after 20 years, it's still a struggle to make his code work and understand it the next day. So do not lose motivation if you feel the same way. Also, do not compare yourself to top developers who do know a lot more than you. Because, of course they do. Many of them have been at this for over 10 years, or maybe even 20 years. But nobody was born an expert, and even experts are still learning all the time. Now, here it's actually pretty important that you have a well-defined goal for yourself. Because if you do, you can just focus on what you need to learn in order to achieve that goal. Everything else is unnecessary. It's just noise. For example, if you don't need a backend in your app, then you don't need to learn Node.js or PHP, okay? The next mistake that is hopefully easy to fix is to not learn in isolation. One great way to do that is to learn together with other people, no matter if in person or online. Whenever you learn something new, explain it to them, because explaining things forces you to really understand them first. And repeating a concept will then really make it stick in your brain. That's why many people say that the best way of learning is to teach. And I actually share that opinion too. Another great technique that many people like is to share your goals publicly. For example, on a social network to make yourself accountable. You can also share your progress on social media to motivate yourself and others. For example, on Twitter, there are some popular hashtags that people use, like hashtag 100 days of code, hashtag code newbie, and hashtag webdev. If you use these, you will get feedback and a boost of motivation from other people that are on the same journey of learning to code. It's a really nice and friendly community, at least on Twitter, which is what I know and use. So for sure, you should try it out. And finally, the absolute biggest mistake that John made was that after he went through a couple of web development courses, he thought that he was now a web developer ready to take a job. Now, this is probably the biggest misconception that people have. Just take a couple of courses and you're done. But no, that is just not how it works. So I'm sorry to bring you the bad news, but courses like this one can only take you so far. They will give you an amazing foundation, of course, but they are just the beginning of your journey. You need everything else that we just talked about in this lecture in order to become a successful web developer. So let's talk a little bit more about this and the journey of actually becoming a job-ready developer. So here is a very true graph that shows you how your confidence in your skills changes as you become more and more competent as a web developer. And this is useful because it allows us to plan a strategy for your learning journey. So when you start, you are in the everything is awesome phase. You are studying one or more courses or tutorials, understanding how the code works, and taking a lot of challenges, just like I mentioned earlier. Now, you're not really competent yet, but are starting to get confident and are pumped to keep going. So this is probably where you are right now and will be throughout this course or any other course that you take. But then, as you start practicing on your own, you reach the cliff of confusion. Here you realize that coding might be a lot harder than you thought when you no longer can just follow a course with a predefined path. So your confidence is gonna start to drop a little bit, and you might realize you can't build anything meaningful on your own yet. But don't lose motivation here. Just keep writing lots and lots of code on your own, no matter how much time you need to spend fixing bugs and searching for a solution. It's all part of the journey, and it's still gonna be fun. Slowly, you will become better at writing code, so you will become more competent. But your confidence might drop even further because now you start to realize just how much more you will need to practice until you can build a real application on your own. You are now in the so-called pit of despair, but believe me, it's not as bad as it sounds. You might start to feel lost, but a great solution for this is to start learning with other people, like other beginners or even other developers who might mentor and help you along the way. To leave the pit of despair, you must keep challenging yourself. You cannot stop here, okay? So keep building bigger and bigger projects, run into lots of problems, and keep fixing them. You really need to have this mindset of fixing problems in order to become a web developer. It's what we do all day long, basically. At this point, it's also important to keep in mind that learning how to code is a really hard thing to do. So don't beat yourself up for finding it too difficult and for being stuck all the time. It is difficult indeed, but it's gonna be worth it. And trust me, we've all been in that place. And everyone who successfully works in the industry today just started out the same as you right now. So really, congratulations for even starting this path. It's already a great achievement in itself. Now you just need to continue building stuff. If you want to know about me personally, I learned to code by starting projects that were actually way too difficult for me at the time, but that made them real challenges that made me grow tremendously. For example, I tried and failed to build a football simulation game with Visual Basic. Then I built a content management system in PHP with really bad quality code. But it worked, and I actually sold it to a client and made good money. I also accepted some client projects for websites that I didn't know how to deliver. But I figured it all out in the end, and it made me grow so much. And I'm sure that the same is gonna happen to you too. Anyway, back to the journey here. At a certain point, you will start to see the light. So at this point, you're getting quite good at writing code, and your confidence will finally start to grow again. You are now in the back to awesome phase. Now you can either start learning new technologies, or you can start rounding up your skill set with best coding practices and tools that you will need for jobs, for example, like version control, testing, task runners, etc. If your goal is to find a new job, you're probably starting to be ready to apply for jobs. You need many things for that, like a really good portfolio, but that is a topic for another day. Just be aware that even when you're working, you will never stop learning. So you are never really done learning how to code. Web development changes really fast, and so you will need to be constantly adapting to new technologies. All right, and that is basically the typical journey from start to job ready. Now, please don't be scared by what I just showed you. I'm telling you all these things not to scare you, but to prepare you, because I really want you to succeed on this path. And I want you to achieve real success, not like fake success. There are just too many people out there who will tell you that coding is easy and that you will magically become a web developer in 2 months if only you take their course. But this is simply not true. So I'm not going to sit here and tell you that coding is easy. It's not easy. But with the right attitude and the guidelines I showed you in this lecture, you can totally do it. And I mean that, because I've seen it happening time and time again. So many people have learned how to code from complete scratch, switched careers, found better jobs, and improved their lives dramatically. And I mean many of my students, and also many other people that I know personally. It's real, and you can achieve the same thing. Just keep going, keep coding, and keep building. In this lecture, we're going to talk about solving problems. Solving problems is one of the most important things in programming. So if your goal is to become a great programmer, you need to learn how to deal with problems effectively. So in this video, I will show you how to think as a developer by solving problems using a simple 4-step framework. And let's use our friend John again. So after some time, John can code now. He is almost job ready at this point, but he still needs to work on his problem-solving skills. And in programming, when we say solving problems, we mean a real problem that needs a real solution. For example, in an array of GPS coordinates, find the 2 closest points. And this problem is not straightforward, right? There are a lot of steps involved in solving this. And so we need a way to effectively solve problems like this one, or even way more complex ones. So problem solving does not mean to fix coding mistakes or bugs, alright? Anyway, whenever John encounters a problem that he needs to solve, he usually just jumps at the problem without much thinking. He also implements his solutions in an unstructured way without much of a logical approach. This makes him stressed out when things don't work right away. Another problem that John has is that he is too proud to research when he doesn't know how to come up with his own solution. So all of this is not effective at all. It makes John waste a lot of time. Now the first fix to this is to always stay calm and slow down and not just jump at a solution without having a plan. Also, when solving problems, you need to be in a mindset of taking a logical and rational approach. After all, programming is just logic, alright? Then, when you are in the right mindset, just use my 4-step framework to solve the problem at hand. And the first step of the framework is to make sure that you 100% understand the problem. Step back and take a high-level look at the big picture. And the most important part of this step is to ask the right questions in order to get a clear picture of the whole problem. And the best way of understanding this is probably to look at an example together here. So let's say you are working at some company on some project, and then your project manager comes and tells you, we need a function that reverses whatever we pass into it. And that's all you know about the problem. But do you understand it 100%? Well, probably not, right? I know that I don't. So let's ask the right questions to get there. First, we can ask, what does whatever actually mean in this context? So what should actually be reversed here? Well, and if we think about it, it only makes sense to reverse strings, numbers, and arrays. Objects don't have a well-defined order, so we can't reverse them. We're also not going to reverse like undefined or null or a boolean, right? Then, after we have that figured out, we can ask, what should we do if something else is passed in that is not a string, number, or array? How are we going to handle that? It's also relevant to ask, what exactly should be returned from the function? For example, should it always be a string, or should the type be the same as was passed in? Well, in this case, probably we should always just return the exact same type that was passed in. Also, we can start to ask more solution-oriented questions, like how to recognize whether the argument is a number, a string, or an array. Or how to actually reverse a number, a string, and an array. So these are just some of the questions that we can ask here. I'm sure there are more, but this should already give us a way more clear picture of this problem. Now, right now, at the beginning of your journey, you will probably not yet know what the right questions actually are. But don't worry, this will come with time and practice, I promise. The next step is probably the most important one, which is the divide and conquer strategy. Divide and conquer means to break up the big problem into as many small problems as possible, because these small problems are then a lot easier to solve. And this also ties in with the previous step, because by dividing the problem into subproblems, you also take the big problem apart until you understand it exactly. So based on the previous step, if we wanted to break down this problem, we could define a couple of subproblems. First, we need to check if the argument is a number, a string, or an array. And this is, in fact, a small subproblem, right? So now we can just solve this one in isolation and then move on. The next subproblem is to implement reversing a number, then implement reversing a string, and then implement reversing an array, so that we are ready to deal whatever is passed into the function. Finally, we then also need, of course, to return the reversed value. So these are our subproblems, and they kind of look like a task list that we now need to go ahead and implement. And this is great, because it makes our work so much easier now. Now, sure, this example is a pretty simple problem, but this strategy works just as well for bigger and way more complex problems. In fact, divide and conquer is an essential method of problem solving that is also used a lot outside of programming. Anyway, with this, we have actually already covered the two most important steps of the framework. But now let's say that we actually do not know how to implement one of these subproblems. Well, in that case, we should not be afraid of doing as much research as we have to. Now, of course, we should always first try to implement a subproblem on our own using our own coding abilities. But if we're constantly hitting a wall and cannot move on, then we should waste no more time and just find out how it works using Google or a questions and answers website like Stack Overflow or the MDN JavaScript documentation. We will see how to use these in the next lecture when we're going to work together on a real problem. And actually, researching is a huge part of a programmer's job, as you will find out very soon. So you really should not be ashamed when you don't know enough to solve a certain problem. That's just completely normal. Now, in this case, some questions that we could Google are how to check if a value is a number or an array or a string in JavaScript. Or we could Google how to reverse a number or a string or an array in JavaScript. Okay? And again, we will do this in the next lecture on a real problem together. Finally, in case we are trying to solve bigger problems, we should put all the previous steps together and write some so-called pseudocode before writing the actual code. And pseudocode is simply an informal description of the actual code that we're going to write. So it's like code for humans to understand, not computers. For our example, the pseudocode might look something like this. So you see, we use some structures of a programming language, but this is clearly not JavaScript, right? And there are no real rules on how to write pseudocode either. You just write so that you understand it yourself or other people on your team. So in this example, we just start by naming the function as reverse, and then we basically pass in a value. Then we say that if the type of the value is not a string and not a number and also not an array, then simply return the value back. And that's because, as we defined previously, we only want this function to work for strings or for numbers or for arrays. And again, you can clearly see that this is not any valid JavaScript at all. But anyway, if the type of the value passed this initial test, then we say if the value is a string, then reverse the string. If the value is a number, then reverse the number. And if the value is an array, then simply reverse the array. And then at the end, we want to return the reversed value. Okay? So this is really more like a list of instructions that we now could go ahead and actually implement using the JavaScript language. Okay, and that's it. That's the 4 steps to solve any problem, no matter how big. And now, before I leave you, a final tip I can give you is to develop a genuine curiosity and passion for understanding how things actually work, not only in programming, but really in the whole world around you. For example, the famous scientist Richard Feynman was repairing radios when he was just a teenager, and Elon Musk made his first computer game when he was 12. And there are many more examples like this, and all of them became geniuses in their fields, in part because of their genuine curiosity on how the world around them works. Alright, and with that being said, let's now go ahead and solve a real problem in the next lecture using this framework that we just learned about. So see you there. Let's now solve together a real problem using the framework that we just learned about and also tools such as Google, Stack Overflow, and MDN. And here is our very simple problem. So let's say that we work for a company that builds a smart home thermometer. And our most recent task is this. So, given an array of temperatures of one day, calculate the temperature amplitude. And keep in mind that sometimes there might be a sensor error. And they give us this array of data. So, what should we do here? How do we solve this problem? And this is actually a pretty simple problem, but it still shows us the fundamental logic of solving problems. Again, using the framework that I just showed you before. And so the 2 most important parts of that is to understand the problem and to breaking up the problem into smaller sub-problems. So let's start by understanding the problem a little bit better by asking some questions. So first of all, they want us to calculate the temperature amplitude. But what actually is that? So we can write that down here. What is temperature amplitude? And the answer to that is that it's the difference between the highest and the lowest temperatures in the array. So answer, difference between highest and lowest temp. And so this is the value that we will have to return from the function. Then we might ask, well, that's quite nice, but how do we actually calculate the highest and the lowest temperature in an array? So let's write that question. So how to compute the max and min temperatures. And finally, they also tell us here that sometimes there might be a sensor error. So what does a sensor error look like? So what's a sensor error and what to do when one occurs? And here the answer is probably to just ignore the error. Now here from our data, we can actually see what an error looks like. So it's this string here, which says error, okay? But it's good to have an idea of all of these questions so that we now really understand the problem that we need to solve. And so I think with this here, we do have a pretty good idea. So now, given our understanding of the problem, let's try to break the problem up into smaller sub-problems. So first, we need to make it so that the sensor errors are actually ignored. So as I was saying, the answer to what to do here is to just ignore the sensor errors and simply work with the rest of the data. So, how to ignore errors? Then another task is going to be find max value in temperature array. And then another task is to find the minimum value. And another task is going to be to subtract min from max and then return it. So subtracting min from max is, of course, the amplitude. And so that's what we need to return. And so all of these are simple steps, but it's good to have an idea of how we will solve this problem. And so that's why I wrote down every single step of the way here. So let's start writing a function. So although they don't tell us that we should write a function here, whenever we encounter a task like this, it's a good idea to write a function for it. So let's call this function calc temp amplitude. And so this function will receive an array of temperatures. So let's again just call that temps. And so now we are going to start to work on solving this problem. And let's start here with finding the maximum and the minimum value in this array. We can deal with the errors a little bit later. Now, probably we don't know yet how to do that based on what we just learned, right? I mean, we already have the tools for sure, but this requires a little bit of thinking. And if we don't know yet how to think about this kind of problems, it's a good idea to do some research. And so we will now use Google to research how we can find a maximum value in an array. And so that's what I meant when I said we should do some research and use Google whenever we need to. So what I like to do is to just write JavaScript and then be as descriptive as possible of what I want to achieve. So let's say get max value in array. And so don't be afraid to ask Google this kind of questions whenever you're stuck yourself. Now we get here a couple of replies, basically, but I'm interested in showing you Stack Overflow now. So Stack Overflow is a site of questions and answers, and most of the time someone already had the same question as we have. And so then they ask that question on Stack Overflow, and we can then go there and find a response. And this one here sounds good, right? Find the min-max elements of an array in JavaScript. So let's click on that one. But now here the problem is going to be that at this point, you will not understand most of the solutions. For example, this one here talks about prototypes. This one has like this weird apply and math. And so let's just scroll until one that we can better understand. This one has this weird dots that we will go into later. But here we actually have something that we can understand. So let's focus on this solution here. Okay. And usually the first solution is always the best one, or the first or the second. But in this case, we just scrolled a little bit more so that we can find a solution that we can implement with the tools that we already learned about. So what they're doing here is to start by defining the first element of the array as max. So in the beginning, they basically assume that the maximum value of the array is the first element. And then from here, they loop through the array or over the array. And in each iteration, here, they test if the current value is greater than the maximum value. And if it is, then the new maximum here becomes the current element in the array. Okay, does that sound like a good idea? Well, I think that it does. So let's try to implement this ourselves, and then I will try to explain you a little bit better why this is a good solution. So let's create a for loop here. And of course, we don't need to copy the code here from this site. Usually it's best to understand the solutions and then trying to implement it on yourself. So not copying the code exactly from Stack Overflow. So let's start with the counter I. Let's start at 0 as always, even though here they're starting at 1. But never mind, we will just do it like we have always been doing it. So I must stay below the length of the array that we're looping over, and in this case, that's the temperature array, right? So temps dot length, and then I plus plus. Okay, and actually before we do the loop, we need to create that max variable that they have here. So let's do that. Let max equal the temps array, so the very first element. So again, we will start by assuming that the first element of the array is the maximum. And that's because we didn't loop over the array yet at this point. So this is similar to the challenge in the last section, where we started out with the sum set to 0. So that was a good starter value. And in this case, a good starting point is simply the first value of the array. And now let's implement that logic here. So if the current value of the array, so that's temps at position I, so the current position is greater than the current maximum value, then the maximum value will become this new value. And that makes sense, right? Because if the current value in the array is greater than the maximum, well, then that value should be the maximum, right? And so that's what we then do here. Okay, and now let's simply log it to the console. And remember that from now on, I will start using the snippet that we defined in the first lecture of the section. So I just type CL, hit return, and then max. Okay, and now just to test this function, let's call it with an array of just some values. So 3, 7, and 4. And so now it's very obvious what the result should be. And so I already saved it, and so probably we now already have the result here in the console, because remember, we still have the live server here running. And so it automatically reloaded the page, and we get the correct result here, which is that 7 is the max value. Let's add something else here, like 23. And now 23 will become the max value. And so the logic here works. So let's get rid of this one, and just to analyze what happens. So in the beginning, before we even start the loop, the max will be the first element of the array, so 3. Okay? Then the loop starts at the first position. So that's 3. So here, then we ask, is 3 greater than 3? No, it's not. So nothing happens. Then in the next iteration of the loop, we are at 7. So then the question is 7 greater than 3, which is the current maximum? And yes, it is. And so now max equals 7. Okay, next iteration of the loop, which is 4. And so the question is 4 greater than 7, which is the current maximum? No, it's not. And so nothing happens, and then we're done. And so the result in the end is that max is equal to 7. All right? Does that make sense? So we solved this problem here, so this sub-problem, where we found the max value. But now we need to do the same for the minimum. And hopefully you can see how that one works, because it's pretty much in the same way. So let's say min, and we will start at the same starting point here. And all we need to do now is to add another line to this loop. So we can do it all in one go. And so now what we're going to say is if the current temperature is less than the minimum, then that should become the new minimum. So min equals the current temperature. And actually, since we're using this here so many times, let's create a variable for that. So const current temperature is equal to temps at position I. And now I'm selecting and then Command D or Control D, 1, 2, 3, 4, and replace all of this with cur temp. Okay, and now just to see again if it works, let's log the minimum as well. And let's add some other value here. And so what can we expect when we save it? Well, the max should be 8 and the min should be 1. So I'm saving, and yes, that works. Next up, we can then tackle the problem of ignoring errors. So what that means is that we do not want to include this, right? Or in other words, this logic here should only run if we actually have a number here. Okay, so basically if the current element is a number, only then it makes sense to make this sort of comparisons. And so we can use something that we learned in the last section, which is the continue keyword. So let's say if the type of the current temperature, so type of current temperature is different from a number, then continue. And remember that continue means that the rest of the iteration will not be executed. So the current iteration will be finished and then it moves on right to the next one. And so in this case, what happens is as soon as the loop reaches this part here, since it's not a number, then none of the logic down here is executed, and then we move on to number 9 right away. Okay, so let's now actually call conc temp amplitude using our temperatures array. And indeed, we already have here the max and min temperatures. So let's confirm that that's correct. And yes, 7 is the max and -6 is the minimum. Awesome. So that works. Now there's only the easy part left, which is to return the amplitude. So return the max minus the min. Okay, let's get rid of this one here. And here, let's store that result into a variable, or actually amplitude. Okay, and then console log oh, actually there's an error here. This should be called amplitude. Okay, and so 23. So you can probably start to see that this is my favorite number, and so it comes up all the time here. Awesome. We did a great job here in solving this problem. And again, we did it because we first understood it correctly, and then we broke it up into these sub-problems. But now let's suppose that after we're done with our solution, the project manager tells us that the function should actually receive 2 arrays of temperatures and not just 1. But the rest of the function should work just the same. Okay, so, well, let's quickly write that problem down here. So problem 2, function should now receive 2 arrays of temperatures. So let's try to again understand the problem. So we can probably ask the question, when we have 2 arrays, do we need to implement the same functionality twice? And well, the answer is actually no. So the solution is to just merge the 2 arrays at the beginning. So just merge 2 arrays. And now we need to then again break this one up into sub-problems. And in this case, that's just, well, really just one sub-problem, which is how to merge 2 arrays. Okay, but we can see that this is probably the best thing to do, right? So imagine that we have this same function, but instead of receiving this one here, so just one array, it gets 2. Then if we can merge these 2 arrays into one, then the rest of the logic could stay exactly the same. Okay, and here the problem should actually be just merge 2 arrays. So that is our sub-problem that we will now solve. So let's now do some more research here. So I think we could actually come up with our own solution here, but really I just want in this lecture to use the tools that we have to solve problems on our own with research. So I want to show you how a developer goes about doing these things. So JavaScript merge 2 arrays. So we have here the Mozilla developer network that I told you about in the last lecture. And here we also have, again, a Stack Overflow reply. So let's take a look at the Stack Overflow again. So here we see that apparently there is like a concat method. So here we can also see array.concat. So that seems to be the solution. And I remember that previously on that Google results page, there was also something about that. So this first here, so the MDN page is also about the concat method. So let's now actually explore the MDN website a little bit. Okay, and let's make this a bit wider so I can show you how it really looks like. And so MDN looks like this. And once more, it might have changed by the time you're watching this video, but the core functionality will still be there. So there's always a short description about the functionality and then some quick examples. Then here on the left side, we can actually see all the methods about the array. Okay, and that's because we are right now on the page about an array method. So concat is a method of arrays, so similar to push or shift or includes, right? So concat is just one more of these methods. And again, we can see all of the methods here. And as I told you, there are a lot of them. So push, for example, is the one that we already learned about and used. So we can quickly see that. And so indeed, the push method adds 0 or more elements to the end of an array and returns the new length of the array. So this is kind of what we did ourselves previously. And actually we can add multiple elements, which I didn't tell you by the time, but this here works just as well. But anyway, this was just to show you a familiar method. But let's return to concat here. So here is a long description of the method. Here is the exact syntax, which many times looks a bit intimidating. And so I like to actually stick to the examples here. So whenever you need to know how a certain built-in method or function works in JavaScript, you can always just look it up on MDN. This is really the complete but unofficial JavaScript documentation. And in fact, many of the things that I know about JavaScript come here from MDN. So don't be afraid of doing any research that you need on this page or also on Stack Overflow. Anyway, here from this example, we can understand kind of how the concat method works. So we have array 1 and 2, and then on array 1, we can call the concat method and as an argument pass in the second array. And the result will be array 3. And when we log that to the console, we will get A, B, C, D, E, F. And so that's the array 1, A, B, C, and then followed by array 2, essentially D, E, F. So I will just copy this syntax now and make this smaller again. And I will paste it here, just so we can then use it as a reference. Okay, and now I will get this whole function and not change that one, but instead create a new one. So call temp amplitude new, and then here we also call the new one and call amplitude new. Okay, amplitude new. And now here we need to change the arguments. So remember that now this new function will receive two arrays of temperatures. So I'm just going to call them T1 and T2. Here at the beginning of the function is where we will solve our problem. So this subproblem of merging the two arrays. So let's again just put this here just so that we see it as a reference exactly where we need it. So what we want to do is to create a new array, and I will call it temps. And I'm calling it temps because that's the name of the complete array that we already have here in the function. So that used to be the name of the argument of the previous version of this function. And now I can just say the array1, so array1, which in our case is T1, dot, and then array number 2, which in our case is T2. And that's it. And now let's just log that to the console very quick. Temps, and we no longer need this. Okay. And here then we need to call this new function with two arrays. So let's just create two arrays. So 3, 5, and 1. And then another one, 9, 0, and 5. And now let's see. And here we see that it did actually work. So now we get this one array, which includes all the elements basically of these two arrays that we passed into calc temp amplitude new. So this function. And we can also see that 9 and 0 are the max and the min, and 9 minus 0 gives 9, which is then this new amplitude new. Awesome. So we solved this problem number 2 here successfully as well now. And yeah, so I hope that now you have a better idea of how to solve problems, and especially how to do research using the tools that I just showed you in this video. So that's Google, Stack Overflow, and also the MDN documentation. And this last one is, in my opinion, actually the most important one. I learned so much from MDN. It's incredible. So now in the future, whenever something is not working in your code, and even during the course, you can always try to figure out the solution on your own, for example, using Google or Stack Overflow. And so that will then be very helpful for your developer journey. So we talked about problem solving, which is a very important skill of any software developer. Now, another extremely important developer skill is debugging, which means to find and fix errors. So let's finish this section by talking about debugging to make you ready for the rest of the course ahead. So first of all, as you might already know, a software bug is a defect or a problem in a computer program. So basically, any unexpected or unintended behavior of a program is called a bug. And the actual term bug was coined in the 1940s when this real bug was causing an error in Harvard's computer. Now, there are many reasons for bugs in programs, but what matters here is that bugs are a completely normal part of software development, because we are humans, and humans make mistakes. In fact, every complex application contains bugs, which sometimes go undiscovered for years and can cause security holes or other problems. So really, don't feel bad if you introduce bugs in your own code. We all do it, even the most expert programmers. Now, luckily, not all bugs cause huge security holes. In fact, many bugs are quite small and simple to discover. So let's see a simple example. Remember, in our previous example, the goal was to reverse whatever was passed into the function. So let's say we finished writing the reverse function and call it with this array and get this result. But clearly something is wrong here, right? The returned value looks like scrambled, but not reversed at all. So this means that we must have a bug somewhere in our reverse function. Okay? To fix this, we use a process called debugging, which is essentially finding, fixing, and then preventing bugs. So let's see how that works. So the first step is to actually become aware that there is some kind of bug. Because as I said, in a large application, bugs can actually go undiscovered for years. Now, discovering bugs usually happens during development, using automated testing software, or user reports during production. And bugs that are identified during production are the worst bugs, because it means that they went undiscovered during development and are now affecting real users of our application. So that's why it's really important to identify bugs early, for example, using automated tests. Now, while identifying the bug, sometimes we also need to take into consideration the context in which the bug happened. For example, certain bugs might only happen in a certain browser or only for certain users for some reason. Next, once we know there is a bug, we need to go into our code and find the bug. We need to isolate where exactly it's happening. And we can do that using the developer console that we already know. However, that only works for small bugs in simple code where we have a good idea where the bug might be located. But if the code is more complex and we have no idea where the bug might be, then we need to use a debugger software. And I will show you how that works in the next video because it's really important for the developer to be able to use a debugger. Anyway, once we know where the bug is located, we can finally fix it. So we can correct the bug. And this is probably the easiest part. So essentially, all we need to do is to replace the existing, so the wrong solution, with a new correct solution that actually works. As a final step, we should then prevent this bug from ever happening again in our codebase. For example, we can search our project for the same bug in similar code, like in a similar function. It's totally possible that we did the same mistake twice in our code. And if that's the case, we must fix the bug everywhere. A more advanced way of preventing bugs is to write tests using testing software. And I might add a bonus section on testing to the course at some point, because this is actually an important part of software development. Okay, and that's it. That's a broad overview of debugging in programming. And we really just scratched the surface here, because you're still at the beginning of the journey. And so this is just an introduction. Anyway, let's now fix some bugs in the next video. Welcome back. So let's now put the debugging process actually into practice. And we're going to start really small and just fix a very simple bug using the console. So let's suppose that in our smart thermometer that we were working on before, we need to do some measurements in a unit called Kelvin, which is the absolute temperature. And the conversion to Kelvin is pretty easy. So all we have to do is to add 273 to the temperature in degrees Celsius. So let's very quickly create a function which will perform this measurement. And this is, of course, all completely fictional. And this function will actually take no arguments at all, because we will get the measurement from a command prompt. So we will basically pretend that the command prompt is like the thermometer sensor. And now let's actually create an object here. So an object for the measurement. So we haven't used objects in some time, and so let's remember that. And let's just set some arbitrary properties here. So the type of measurement is going to be temperature, and the unit will be in Celsius. So basically, we will measure temperature in Celsius, and then we return a converted version. And in there somewhere will be a bug. And now, finally, the value of this measurement will come, as I just mentioned, from a prompt. So let's just say degrees Celsius. And so that will then trigger a prompt. And then let's convert that to Kelvin. So as I said, all we need to do is to take the measurement in degrees Celsius and add 273. So that means measurement dot value. So this property here, where that value in degrees Celsius will be stored, plus 273. And now we can return converted value. And then let's run the function and immediately log the result to the console. So that's measure Kelvin. And now I will give it a save, and it will then ask me for the temperature. So let's say it's 10 degrees Celsius. And so now let's wait for the result in Kelvin. And we get this number, 10,273. And that is not what we expected. We wanted 283, but not this number. So there's got to be a bug somewhere. And so let's find it. And by the way, the first stage of the process was already this one. So A was to identify the bug. Remember? And now we're going to stage B, or stage 2, which is to find the bug. And so since the bug appears in the converted value, which is this one, and this one is derived from this measurement value, let's start by inspecting that measurement value in the console to see if something is wrong there. So console.log measurement.value, give it a save. Oh, and of course now we need to input it again. And so it looks okay actually, right? So it is 10, so that's exactly what we inputted. So it looks kind of normal. I just want to show something now to you, which is that we actually do have things beside console.log. So we also have console.warn and console.error. And with this, we can basically generate warnings and errors in the console. So 10 again, and you see that now this first one looks like a warning, and the second one actually looks like an error. So that's just a matter of formatting, but it's still interesting, I think. But let's take them out. And so, yeah, right now it looks like everything is correct. So let's dig a little bit deeper and take a look at the entire object. And actually, if it was myself, I would have done that immediately, but I want to show you the complete thought process here. So anyway, let's say measurement, so that's the entire object and not just the value. Let's turn off this one as well, give it a save, 10, and let's open up. And now we actually see the problem. You see, the value is a string. And that's because, as I told you in the last lecture, the prompt function here always returns a string. No matter what we input into that prompt window, it will always just be a string. And so that's why we get this end result here, because as you remember, the plus operator, when it sees a string, it will convert both operands to a string and then concatenate the strings. Just as another curiosity here, there is also another way of showing objects in a console, which is really handy sometimes. So measurement, and so again 10. And so console.table gives us this nicely formatted table. And especially for bigger objects, that can be quite helpful. And let's actually leave that here so that you can see it. So with this, we completed the second phase, and that was to find the bug. And now all we need to do is to fix the bug. So we need to do that right here where it actually occurs. Yeah, so up here. So let's see, C, fix. And so the solution to this is to convert this string that is returned to a number. So let's use the number function. So we already learned about this one in the last section. And so now we actually expect this to work. And indeed, now we get 283, which is exactly what we were looking for. Great. So this was a very simple example of just using the console in order to hunt down a bug and then fix it. But now let's take it to the next level and learn how to use a debugger in Google Chrome. And let me quickly show that to you with this current function. And for that, we actually need to make this a little bit bigger. And now we go here into sources. So for the first time, we're using the sources tab, and then click here on script.js, which is our current script. Okay, then as we move down, we have our code here. And now here in the debugger, which is basically these two panels here, we can set something called breakpoints. So let's put a breakpoint here in this line of code. So here, and we set a breakpoint by clicking here in this left bar. And so this will set this red point, which means that there is a breakpoint. And now when we reload the page, then the execution will stop exactly at this point. So basically execution will freeze in time and show us exactly what the execution looks like at that moment in time. And that includes all the values of all the defined variables. So let's do that. Let's reload. And so you see, now we are in this function. And now I can click this button here to resume the script execution. And it will then start going over all these lines. But now it can only continue if I input a value here. So that's coming from this prompt. So I put 10 here, hit enter. Then it does all of these lines here. And finally, we reach the line where I set the breakpoint. And so that's this one here marked in green now. And again, at this point, we can then see all the variables. So Kelvin is still undefined because the computation has not yet been done, but we can take a look at measurement here. So the value is 10 as we just inputted. And yeah, this can be very helpful in case that we don't want to mess around with a lot of console.logs or other stuff like that. We can also hover these here. So here we can see the whole object. Here we then can see just the property value. And now we can execute the rest of the function simply by hitting this step button here. So basically this will then go to the next line of code. So now we have Kelvin set at 283 because now the previous line just executed. And here we are in the last line. And so now we can see here return value will be 283. So with this one here, we can execute one line at a time. And for now, just ignore these three buttons here. You can explore them a little bit later. Okay, so we're almost done. Let's just click one more time. And so we're out of the function now. And now processing this next line of code. Let's just continue. And so now we went into some other stuff here, and that's actually coming from the live server. So never mind. We can just close this and now click here on resume script execution. And now we're done. So this is not all super intuitive, I would say. So just experiment around a little bit with these different buttons. Okay, now we just need to get rid of this breakpoint here. Otherwise, the execution will always stop here in the future. So just click this red dot here again, and then it's gone. And that's how we launch and use the debugger in Google Chrome. Now let's quickly introduce a bigger bug here in our code and then fix it using the debugger. And for that, I'm simply going to go back to this function that we created before. So this one here. And let's call this one here bug. So I will replace all the news with bug. So we have here calc temp amplitude bug, and here we're calling that, and then we call the amplitude bug, and here as well bug. Cancel that one. And actually, let's come here and comment out this piece of code so that it doesn't annoy us all the time. And we can just set the value here manually to 10 now. Okay, this way we preserve the code that we have and also keep it running, or actually keep it working. So here let's just say using a debugger. Then down here we are calling this function, and here let's just change this to something else. Let's say 4. Okay, let's just run this now quickly. And so we see that the output at this point is still correct because we didn't introduce any bug yet. So the max is 9, the min is 1, and therefore the amplitude is 8. But now let's say that we did a mistake. And we might have thought intuitively that the max and min values would be good to have a starting point of 0. I think you can maybe see why that would make sense. So for example, we started the sum at 0 before, so why not start the max and the minimum at 0 too, right? It would have been quite reasonable to think that. And so let's pretend that we did think that, but this will actually introduce a bug because with this will not work. So as you see, now here it says that the minimum value is 0, right? So that's coming from this console.log here, which says now that minimum is 0 and that the amplitude therefore is 9 minus 0, which is 9. So we identified the bug here, okay? Let's again write that identify. And so let's now go back here to Chrome and to the debugger to try to find that bug. And the debugger is actually especially useful inside of a loop. And so that's the situation that we have right now. So we are in a loop. And so let's see here now why the maximum and minimum values are not being correctly set. Or actually it's just the minimum. The maximum is fine, but still we need to analyze both of them. So what I'm going to do here is to set a breakpoint right here, because that's where the maximum and the minimum are being computed. Okay, so let's reload, and right away we get to this point in the execution. So at this point, the temps variable has already been computed, so it's already this complete array. Max and min are at 0, and so now we are doing this. So we see that the current temperature is 3, that the maximum is 0, and so next step will end up here. Or let's actually continue. And indeed, now we see that max is 3. And that makes sense, right? According to the rules that we described earlier. Okay, moving on here. Oh, and we already moved on right to the next loop iteration. And that's because we don't have a breakpoint here. So let's just put another one. And so now we're in the second iteration. And so now I is 1, as you can see here. Okay. So the current temperature is 5, max is 3, and so now the new max should become 5. And yes. Oh, and again we jumped over this one, but let's just keep going. All right. So now the current temperature is 1, max is 5, and so this one will now not get executed. So now we can see this one. Current temperature is 1, which is less than 0, and so nothing is going to happen, right? And so here we actually have the bug itself. So we know intuitively that 1 here is supposed to be our lowest number. But the problem is that 0 is even lower, and so it's impossible for any of these numbers here to be set as the minimum. Again, because the initial value that we set is already lower than any of the values that we have in the array. And so now, by analyzing this one by one in the debugger, we can really understand that is what happens. So again, in this situation is where we would like for this 1 to be set at a minimum. But it's not going to happen because 1 is not less than 0 here. And so now there's not even a point to keep going. Well, we can still do that. So now the current temperature is 4, which is this one. And just one more. So I is 5. So we're in the last iteration. And we see that the maximum is already correct. And now here we can actually also see the loop finishing, because we see that temps.length is 6, and I right now is also 6. So 6 is not less than 6, of course, and so the loop will now finish. So you see, now we jumped over the loop and we are finally here in this next line of code. Let's go to the next one. And the value to return is 9, as we already know, because of our bug in the min. Okay, and that's it. Now we stepped over this entire function logic and saw exactly what happened line by line. And again, we're in the live server here. Let's just remove this and resume the script execution. Okay, great. So I hope that got you an idea of how we can use the debugger. Just wanted to tell you that instead of going through the sources tab here, we can actually also call the debugger right from our code. And all we have to do for that is to write debugger right here. So JavaScript has this debugger statement, and then when the browser sees this debugger, it will automatically open up the debugger tool. So when I give it a save now, you see that we are right at this point. So it's like it put a breakpoint here in this point, and then we can do everything as we just saw before. So let's click here on continue. Or actually, let's just get rid of this here, give it a save, or stop this and reload. And yeah, then we exited that debugger. Now this was of course just a small example, but again, this is an extremely powerful tool that you can now use whenever you run into a problem in the future. So take a moment now to go through the steps again, maybe by yourself, and that will then help you make you a better developer, because debugging really is an intrinsic part of the development process. So I showed you some ideas and some tools to solve problems and to debug your applications. And so now it's your turn to put all of that into practice on your own. And so here is your coding challenge for this section. So given an array of forecasted maximum temperatures, the thermometer that we've been working about throughout this section should display a string with these forecasted temperatures. So for example, if we have this array, which is our first test data here, then the string that it will print should be this. So 3 dots, then 17 degrees Celsius in 1 days. So that's the 17 here. Then again, 3 dots, then 21 degrees Celsius in 2 days. So this 21 is this 21, and then 3 dots, 23 degrees in 3 days. So in 1, 2, and 3 days. And then again, 3 dots. Okay, and here you don't need to use this exact sign if you can't find it on your keyboard. I know it was a bit hard to find for me. So what you should do is to create a function called printForecast, which takes in an array called R, and then logs a string just like this one here to the console. Okay, and call this function for these 2 test values. And to solve this, you can use the problem-solving framework that we have just been talking about in this section. So try to understand the problem first by asking the right questions, and then break it into sub-problems. And I'm not saying that this is going to be easy. And for me, the main goal is not even that you achieve the result, but really that you start thinking about the problem and that you try as good as possible to break it up into sub-problems. And of course, there are many ways of asking the right questions and of breaking this up into subproblems. So there's no hard ways of doing this stuff. So just try your best, take all the time that you need, and I will see you here once you're ready. Okay, so let me show you how I would have done it. And let's just close this terminal here, because remember that this live connection actually keeps running without the terminal opened. So let's just grab from up here this here. So as you see, I'm a little bit lazy. I don't like to type so much. So I just keep reusing stuff. So we need to understand the problem first. So let's look at that example string here. And so one part of the problem is definitely that this array here was basically broken up in 3 pieces. And then the separator is these 3 dots. Let's write that here. Array transformed to string separated by 3 dots. Then we can also ask what these numbers here are. So we already know that these here are of course coming from the array. But what is this? So 1 days, 2 days, and 3 days. So what is the x days? And the answer to that is that basically it is the current index of the array plus 1. So it would be weird to say that 17 degrees in 0 days, because this is a forecast. And so this is for the next day, and then in 2 days, and in 3 days. So answer index plus 1. Okay, so I think we understood the problem now, because I think that it's quite simple in this case. So let's now break this up into sub-problems. And I would say that the main problem here will be to transform this array into a string. Because that's essentially what we will have to do. Also, each of these elements here will be transformed to a string with these degrees Celsius. So let's just transform each element to string the Celsius. And I don't even remember where this is, so I'm just copying it here. Then we also need to account for the current day. So string needs to contain day. And again, that is the index plus 1. And finally, we also need to add the 3 dots between elements and start and end of string. So that looks like a lot of work, but actually it is not as hard as it looks from here. So let's start by creating 2 arrays here. So for test data 1 and 2, actually grab all of this in one go. Data 2. All right. And now let's tackle these problems here. Okay. So if the string would always have the same length, so if it would always just be 3 days, then it would be very simple. We could just basically hard code the string, right? We could just do something like data 1 at position 0, and then the degrees Celsius, then dot, 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 and so on and so forth, right? So here I'm missing these, of course. So we could do this, and there's still some value in first actually trying to write this. So this is how it would look like. Data 0 and 1 and 2, and let's indeed log this to the console. Give it a save. And so actually already the string looks exactly what we had here, right? But of course, this is not the way to go, because then here in data 2, we have a longer array. And we want to write one function that works for all the arrays. So that print forecast. And so of course we need a more dynamic way of creating this string. But still, as I said, there is some value in having done that, because it will help us figure out how we can arrive at a solution. So print forecast is a function which takes in an array R. And now let's see what we have to do. So if we have an array and we have to do multiple operations on it, we will, as always, use a loop. So let's start with that baseline. So let I equal 0, and this part is now always the same. So I less than R dot length and I plus plus. Okay, but now what are we gonna do? So how will we basically transform the array into a string? And there are so many ways in which we could achieve this, and actually in which we could solve this whole problem here, especially if you did some research to arrive at the solution here. But I will just go with a solution using the tools that we already used. So remember what we did when we calculated the average of a number. We started by adding all the values of the array using a loop, right? And we kept adding them to an accumulator variable that was called sum, right? So just to illustrate, that sum started at 0, and let's say we had an array of 2, 3, 4. And so in the first iteration, that sum was then updated to 2. Then in the second iteration, it was updated to 2 plus 3 equals 5. And then in the last iteration, it was updated to 5, which was the current sum, plus 4 equal 9. And so that's how we end up with the sum of all of these values. And now with the string, we can actually do the exact same thing. So here we will also have an accumulator variable essentially, which is going to be called string. So let's string, and instead of starting with 0, we will start with the equivalent of 0, but for strings, which is the empty string. So empty string has nothing. And then in each iteration, we will simply add to that string the current value of the array. So let's do that. String equals the current value of string plus array at the current position. And also let's already add this symbol here. And for that, let's wrap this here into a template literal. And so I'm selecting this, and then I can just hit the template literal, the backtick once, and it will wrap all of that. So then this, and then the degrees Celsius. And now all we need to do is to log that string to the console. So just as was asked, which takes and logs the string to the console. So we could have added that actually as one sub problem, even though it's a really, really small one. Log string to console. And so let's give it a try now. I'm saving. And nothing happened. Oh, and that's because we didn't call the function. So let's print forecast with data 1. And here we go. So 17 degrees, 21 degrees, 23 degrees. And that already starts looking like what we have here. So essentially, we already completed the most difficult part, so of transforming the array into a string. And again, this was similar to adding multiple numbers into one bigger number. Here what we did was to add multiple strings to a bigger string that kept growing after each iteration. And if you want to make sure to really understand this, then you can always use the debugger and go through this loop step by step and see this string variable here growing as the loop goes on and on. So we already did this part also, and this part. Now let's tackle this one. So it needs to also contain the day. So what does that look like? So 23 degrees in 3 days. So in 1 day, 2 days, and 3 days. So that's not too hard. So and now we already understood that this had to be the current index plus 1. So the current index is I plus 1. So in 1 days. So in the first iteration, it's going to be 0 plus 1, then 1 plus 1, and then 2 plus 1. Give it a save. And that's starting to look really close to what we need in the end. But now we are missing the separator dots. So how do you think we can achieve those? Well, in fact, these dots are simply something that repeat after each of these strings here, right? So we have this value and then dot, dot, dot. So we have the value dot, dot, dot. We just need one more space here to create this nice separation that we have. And so now we're almost done. Okay. So actually this is not correct here because it's missing the in 1 day, in 2 days, and so on and so forth. But let's just compare it here with the original. And so all that is left is these 3 dots at the beginning. And so we can just add them at the end. So we cannot put them here, right? Because then we would have too many dots. So that's a lot of dots, and that's not what we were looking for. So instead, we keep it like this, and then as we log it to the console, we simply add the dots here at the beginning. So dot, 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 plus the string, give it a save, and yes, that's the solution of our problem. Great. We can just improve this here a little bit again by using the plus equal operator, and then get rid of this part, make it a little bit more short and more efficient maybe. And so, yeah, that's it. That's the result of this coding challenge. And again, you could have done it in so many different ways, but what I really wanted you to achieve was to understand the problem and to break it up into small subproblems. If you did that, well, then my goal with this whole section, I would say, is achieved. So, hope you liked this one, even though it was a little bit more theoretical, but I think it's important to also have a section like this in a big web development course, because soft skills like the ones that I just showed you are also very, very important for your success. These days, everyone seems to be talking about AI tools for programming. Things like ChatGPT, GitHub Copilot, the new Cursor AI code editor, and so on. There's a lot of hype in the industry around AI right now, but there is, in fact, a place for these tools in web development and programming in general. And so I think it's important to learn and to think about this new reality early on and address the questions that you might already have about what this means for the future. So that's what this lecture is all about. Let me just warn you that it's gonna be pretty opinionated, but I believe that this is what a beginner like you should know and do. So, as I already mentioned, we're talking about AI tools like ChatGPT, GitHub Copilot, or the Cursor AI code editor. And by the time you're watching this, I'm sure there are already a million new fancy tools out there. Now, what all of these have in common is that they're powered by an LLM, so a large language model like GPT or Claude, in order to generate code based on a prompt the user gives the model. That's basically all they do, but different tools have different ways of working and a different user experience. So basically, we can ask these tools to write code snippets or function for us, and some tools like Cursor can even generate entire files based on our prompts. Copilot and Cursor also give us a very powerful autocomplete feature that is aware of the code that you're writing, your comments, your clipboard, and also the entire codebase. You can even chat with your codebase, like asking questions about how certain parts of the app work in case you don't understand something. And all of this works pretty well sometimes and not so well in some other times. But more about potential problems later on. Now, when we choose to work with an AI tool in our code, or even just for learning or for writing some simple function, we need to follow a workflow, just like we follow a workflow when we're coding and solving problems ourselves without an AI assistant. And we've already talked about that workflow for solving problems and the different steps involved earlier in this section, right? And so, let's now adapt that workflow for the age of AI in case you decide to adopt any of these technologies. So, just like in our earlier workflow, it all starts with 100% understanding the problem that we need to solve. Don't use an AI tool if you don't even know exactly what you need to solve, because this will just introduce unwanted code. You can also apply the divide and conquer step that we discussed earlier to basically divide the problem into smaller sub-problems, if it's a really big one. Like, you're not going to tell the AI, just write me a social network like Instagram, right? That's way too big and outright impossible. You would have to divide that one into thousands of small sub-problems. But anyway, next up, you're going to choose which AI tool you want to use, and then you need to write a very specific prompt, telling it exactly what you want to get done. For this, it's important to feed the AI the exact context of the problem, like what topic it's about, the exact goal that should be achieved, what language it should write the solution in, what coding style you want, and so on. Then, based on this specific prompt, the AI will do its magic and generate a solution to your problem and output that solution in the form of code and in the language of your choice. So in our case, that's of course gonna be JavaScript, but it could also be HTML, CSS, Python, Java, and so on. And now here comes the most important part, where you as the developer need to very thoroughly inspect and test the generated code. Again, this is extremely important because code generated by AI can contain lots of bugs which are sometimes very well hidden, or it can also suggest a solution that's more complicated or convoluted than necessary. More about that in the next slide, but you can already start to see that these tools should only be used by developers who already know what they are doing, right? But anyway, after reviewing and testing the code, you can use the AI to correct or improve the solution by generating a new, very specific prompt telling the AI assistant what's wrong and what you need fixed. So this is a pretty iterative process until you reach a solution that you're happy with. Sometimes this actually never happens, in which case you need to abandon the idea of using AI for this specific case. But if you are satisfied with the answer and are 100% sure that it's correct, then you can integrate the solution into your code base. So, this is how you would use an AI assistant to help you write some code. But when exactly should you actually use a tool like this and the code that it generates? Well, before you choose to use an AI assistant to solve any task, you first need to make sure that you actually know how to code yourself on your own. So fundamental programming skills are absolutely essential. And so that's what this course is for. Now, I'm giving you this lecture early on because there are so many questions about AI these days. And so I wanted to highlight the need for learning programming right off the gate, instead of relying on AI before you even know how to program. Now, in the same vein, you also need to be able to solve problems on your own and develop very good critical thinking. Critical thinking is especially important when you're dealing with AI-generated code, because many times it contains bugs that are hard to find, or the code is simply not good enough. Always question whether the AI output actually makes sense. Finally, coding should sparkle joy and curiosity. If coding is boring or not exciting anyway, if you lack the passion for writing code, then maybe this isn't the right career anyway. So, in summary, I would advise to not just use AI without knowing what you're doing. Otherwise, AI will turn you into a terrible programmer, or maybe not even a programmer at all. If you rely on AI-generated code all the time, you're gonna grow dependent on it, and you'll just become someone who copy-pastes code left and right until you have some barely working app. An app that you don't understand, can't maintain, and can't fix in case anything breaks, which, let me assure you, will break. So, someone like this is not a programmer in my mind. Now, some people will go ahead and do just this. So they will just copy-paste, and they might have some success with it to a certain degree, but if you want to do things well, again, my advice is to learn the fundamentals from this course and become a real programmer instead. Now, this may all sound a bit negative, but of course, it is fine to use AI in certain situations. I do it myself all the time. But instead of relying on AI to do everything, you should see AI as an assistant. AI is meant to help you, not to replace you. So AI tools can and should be used to help you save time on repetitive or mundane tasks like boilerplate code. So things that don't require you to think much anyway. AI assistants are also great for learning. For example, you can just ask it questions about programming topics, or you can ask for code solutions and then analyze the output step by step in order to learn something new. This way, you're gonna find new tools and techniques that you can learn that maybe otherwise you would have missed. So you wouldn't have known they even existed. And we'll actually do all this in the next lecture. Okay, now assuming that you did decide to use AI and you now have your AI-generated code, when is it actually okay to incorporate this code into your app? Well, I'm gonna start by reiterating on what I said earlier, because it's just so important. You should only incorporate AI code if you could have written that code yourself. The ideal scenario is that before asking the AI to write the code for you, you have already thought of the steps and the JavaScript features that you might need in order to solve the problem, and maybe even imagined the code in your mind. Then all the AI does is to actually write the code you had already imagined, which is gonna be a lot faster than you typing it out by hand. And this actually happens to me many times when I use AI, and it feels pretty magical, to be honest. Now, if you could have written the code yourself, the next guideline is pretty obvious, but it's still important to highlight the fact that you should truly understand the generated code before incorporating it into your codebase. Also, as I already touched on earlier, you need to ensure that the code is 100% correct. All this will ensure that errors made by AI don't make it into your codebase. This is especially important for mission-critical parts of your app, like core business logic. And so I advise you to not even use AI for these crucial tasks at all. So, to recap, it's absolutely okay to incorporate some code that an AI has written for you, if you're only using the AI to be faster at non-crucial tasks, even though you could have done it yourself. Otherwise, you'll never be able to fix the code when it eventually breaks, and maybe even more importantly, you won't grow as a developer. But now it's time to finally tackle these big questions that many beginners have, which go something like, do I even need to grow as a developer now? Won't AI take my job anyway at some point? Or should I even bother learning to code now? Well, answering this type of question is one of the main goals of this lecture. So the short answer to the question, will AI take my job, is no. So case closed, right? Well, maybe not so fast. Maybe you want to understand why I'm so confident that developers will still be needed going forward. Now, I need to preface this by saying that this is of course my personal opinion, and that I, shockingly, cannot see the future. But I've thought about this a lot, and here's what I think. So the first thing that we should address is that there's just a lot of hype around AI these days. And that's true for all industries, not just web development. Many people seem to believe that AI is going to replace us soon. And there are actually companies trying to do just that. But they seem to forget that we've been in this situation before. We've had tools like Dreamweaver or WordPress or site builders like Wix in the past, which were supposed to make web developers obsolete. But did that ever happen? No, it didn't, and I'm sure that it won't happen this time around. Now, I do believe that AI is here to stay, and that it will be very helpful for us developers, but it's clearly overhyped at the moment. But this brings me to the next point, which is that, indeed, things will change in the future. No one knows how much and how fast, but we can say for sure that some portions of applications will be written by AI in the future. This is already happening right now, and this tendency is only gonna increase. But the thing is that this isn't necessarily bad. As we saw before, AI code can be great for automating boring boilerplate stuff that takes up a lot of time or other mundane tasks in software development. This means that for all the other interesting tasks, you will still be needed. You, the developer, will always stay in control of implementing and of adapting the application's architecture and of writing the core business logic. At least that's how it should work. You're also the one who asks the AI for help in the first place, and you're the one who is going to review the code, test it, and finally integrate it into the app. So again, the developers are going to stay in control and can actively decide how much they want to involve the AI in their projects. Because the truth is, software developers do a lot more than just writing code. They're able to maintain an overview and see the bigger picture of complex projects, and they understand and implement design principles. Now, I guess all this is a bit hard for you to imagine as you're just starting out on this programming journey. But there are just things that are too complex for AI to handle, where it's not just writing a few lines of code, but really thinking hard about problems and solutions. And so that's where the human programmers come into play. These humans are also way more creative than AI, and they're able to actually collaborate with other developers and, maybe even more importantly, collaborate with the clients. So it won't be easy to automate all that stuff away with AI, and it won't happen soon. On top of this, as I also already hinted at, from my experience, AI-generated code is still pretty buggy and often doesn't give you the best or most up-to-date solutions. It's especially bad at debugging non-trivial problems that span multiple functions or files, hallucinating solutions that don't solve anything and just make the code worse and worse each time you ask it to improve the solution. I've seen this happening a few times where the most state-of-the-art AI models become completely useless. So yeah, I think we're pretty safe, especially when it comes to debugging. Another aspect that's interesting to consider is the fact that right now the world actually needs more software than can be built by us humans right now. So how many times have you used some terrible website from a local business or used a non-functioning web app to make a restaurant reservation or something like that? I know I have. And if we recruit AI to help us automating the boring parts, maybe we can improve much of the bad or even non-existing software, which is gonna benefit everyone. So maybe if AI makes us like 10 times faster at some distant point in the future, it might enable us to write 10 times more software. So those are the kinds of positive effects that many people don't even think about. And there are probably many more positive effects that we can't even imagine yet. So in conclusion, AI will help us, not replace us. It might take some boring coding tasks away, allowing us to focus on what really matters: building amazing software and building a lot more software faster. This means there won't be fewer jobs in the future, but actually maybe even more. So please keep learning JavaScript or React or whatever it is you're doing right now. And don't stop this whole AI narrative from progressing on your journey of learning web development and building amazing software. Plus, learning programming teaches you foundational skills like logic and reasoning. Basically, it teaches you how to think, and those skills will always be relevant, and maybe even more so in the future. And with this being said, let's now actually try our hand at using AI to solve a challenge, following the process and the guidelines that we just talked about in this video. So in this lecture, we're gonna work on challenge number 2, but this time we're gonna actually solve it using an AI assistant, just so you can see how we could use the process that we just learned about in practice. So let's say that you're building a time tracking application built for freelancers. And at some point in building this application, you need a function that receives daily work hours for a certain week, and then it will return 5 data points. So the total hours worked, the average daily hours, the day with the most hours worked, the number of days, and finally, whether this current week was a full-time week, which means that the freelancer worked 35 hours or more. Now, you could actually try to solve this challenge also on your own before using the AI assistant, but the problem is that this actually needs some JavaScript features that we haven't learned about yet. But still, if you really want to challenge yourself, you can see how far you can take it with the skills that you have already learned up until this point, even though these solutions would not be perfect. But again, it could be worth a try if you want this extra challenge. But in any case, the point of this lecture is to use an AI assistant and to use that 5-step process that we basically learned in the last lecture. And so remember how the first step is to really understand the problem that we are trying to solve using the AI assistant. Now in this case, we have already kind of understood the task because it was given to us here in this very comprehensible format. So pretty much we have everything worked down here, except maybe for some details, which we're going to work out in a minute when we write the prompt. So the next step is to then choose the AI assistant tool, and for that we're going to use the most popular one of all, which is ChatGPT. So let's head over to chatgpt.com, and I'm pretty sure that you have already used this tool in the past at this point. So this is by far the most popular AI tool out there. And so again, I'm sure you already have an account on chatgpt.com. But if you don't, then that's no problem at all. You can just create a free account and then come back here. So this is a pretty basic interface. You can just choose the model up here, and we're just going to use this GPT-4o, which is the best one at this moment. But again, if you're watching this in the future, I'm sure some better model has already come out. So they're releasing these new models here pretty fast. There's also this canvas mode here, which is actually great for writing code. But let's just stick to this more basic one where we can just chat back and forth with this assistant. And so then we can just type our very detailed prompt down here. And so to start, I'm just going to grab these instructions from here, and I'm going to paste them here, and then let's change this a little bit and make it more specific. So here, let's say I'm building a time tracking application for freelancers. Then here we don't need any of this fluff, so we want to be as direct and straightforward here in this prompt as possible. So we just tell the assistant, write a function called, let's say, analyze work week. And then let's say that receives daily work hours for a certain week and returns these 5 here. So let's think about this. How should this function actually receive the data? So I think it would make sense that it actually gets an array of the 7 values of the 7 days that are in a week. So let's say here that receives an array of daily work hours, and then it returns these. Now these should then also be in a data structure, so we could again return an array, but let's actually return an object here, which then makes it a bit easier to understand what each of the data points is all about. So, and returns an object with the following data. So I think that this prompt here is very specific, so the AI will know exactly what it needs to do, and then let's also give it a bit more details on what to actually do here. So here these daily hours, let's say that they should round it. So round to 1 decimal place. Then here let's say, in this case, that it should assume that Monday is the first day of the array. So assume Monday is day 0 in the array. And then here, as for the number of days where the freelancer actually worked, let's say that these are the days with over 0 hours, just to make sure with more than 0 hours. So looking here at our test data, again, we have this array, which is why we said here that this function should receive an array. And so, for example, here we have a 0 and here we have a 0, meaning that out of these 7 days, the freelancer has only worked 5 days. All right, so I think this looks pretty great. So just hit enter, and then ChatGPT will very quickly start working on our solution here. So it takes some time as it's working, and it's still way faster than we are. And then here at the end, it even gives us an explanation of what exactly it did. So let's check this code here. So the function has the name that we gave it. Then it's calculating the total hours. And here it's using this reduce method that we don't know about yet. Then the average hours, also using this function that we also don't know about yet. But for now, that's no problem. So this looks pretty good to me, even though, again, at this point, you don't really know this code yet, so you don't have any way of checking if it is actually correct. So I'll just go ahead and copy the code. And ChatGPT is even smart enough to know that this is code. And so it has this button here where we can just copy and paste that here. And yeah, let's even keep the comments here. We could also remove them, but yeah, let's keep this. Then here, it even generated some test data for us, but let's use the ones that we already have up here. So I will replace all of this. And then let's run our code. And I think it is still running here. So the live server that we set up earlier. And so indeed, here we have our object, just like we asked it to. So we get the average hours, the number of days worked, whether it is full time, then the max day and the total hours. So that's just shy of 35. And so that's why is full time is false. So let's maybe change the 4 here to 5. And so then this should be 35.5, and is full time should become true. So give that a save. And indeed, this worked really great. So just like this, we actually solved the challenge without having to type any code. Just keep in mind that if you were to incorporate this into your own application, you would have to really test this code and inspect if everything is correct. Also, remember that this is supposed to be an iterative process. And so let's try to maybe change something here. So this max day right here is number 4, which is basically the index of the day in which most work happened. So 0, because remember that in arrays, the first element is always the 0. So that's 0, 1, 2, 3, 4. So that is indeed correct. This is the max day, so the day in which the freelancer worked the most. However, this number 4 here is not really a nice readable result. So instead, let's tell ChatGPT that this should actually be a weekday. So let's say change max day to be an actual work day like Monday. And so then it will get back to work. And so now here what's happening is that ChatGPT is creating this array here of these days of the week. And then here it will basically convert the index, like the number 4 that we got earlier, to the actual day name by reading that value here. So let's just copy this function here and replace the one that we already have. So just like this, give it a save. And now we should get Friday. Beautiful. So small tasks like this can easily be automated with AI, as you just saw. But it will always be your task to incorporate code like this into your own application. Again, making sure that it actually works and that there are no bugs in the code. So you'd have to do a lot more analysis and tests than we just did here. And actually, let's do one more test like this. So let me just copy this here again. Let's also remove this comment from here. And let's do weekly hours 2, analysis 2, and analysis 2 here. And now what I'm going to do is to remove 2 days from here. And in this case, we actually don't want this to work. So this analyze work week function should only work if there are actually 7 days given to the function. So if the length of this array here is 7. So let's tell ChatGPT this as well. The function should require the input array to have exactly 7 days. Update the function accordingly. So now it will probably introduce some kind of error here. Yeah. So in case that the length of this array is not 7, then we will get an error here in our browser. And even actually if this is not an array at all. So with this part right here. So let's copy this. Again, replacing our function here. Let's give it a try. Maybe manually reload here. We don't get the error. But that's because I forgot to actually use this array right here. And so now we get exactly that error. So input must be an array of exactly 7 daily work hours. So that's basically the error that is generated up here. And again, we never saw this code. So we had never learned about how to manually create errors. And we never saw this reduce method or this filter method and many of the things here in this function. But don't worry, of course, you will learn about all of this throughout this course. And by the end of it, you would be able to easily write this entire code here on your own. But remember how we also talked about in the last lecture that ChatGPT or any AI assistant is also great for learning. And so let's now use it for that as well. So let's say, for example, that we want to learn more about this filter method here. So let's just ask it that. What does the filter method do? Why is it useful? Give me a few examples. Here's a typo, and ChatGPT would even understand it with these typos, but let's make our text correct here. And so now, if you want, you can just read the explanation that you get here about the filter method. Now, here are still some words that we don't understand, or that we didn't talk about yet. I think, for example, callback. So this callback concept here seems to be essential for the filter method. And so we can drill down even further and ask it, what is a callback? Explain the filter method in simple terms to a JavaScript beginner. So that's basically what you are right now. And so if the explanation is a bit too complex, you can just ask it to make it more simple. And so then you get this explanation right here, which of course will look a little bit different for you because the output for each query in ChatGPT is always different for each time that you ask it. So even if I ask the exact same thing twice, the response will always be a little bit different. But you see, it is pretty detailed here and gives me all of this text, all this explanation. And so, yeah, maybe one day it will even replace me as a teacher, which I hope it won't. But I guess until ChatGPT is able to create videos as I am, I should be safe. Okay. But anyway, this is it for this lecture. This was just a quick walkthrough and a quick demonstration of how we can use an AI tool in order to solve challenges like these. So as you go throughout the course, you can maybe also ask some questions in case anything that you did learn throughout the course was not 100% clear. And so then ChatGPT could help you with that. There's also now an AI assistant integrated right into Udemy, and so you could use that one as well while you're going through the course and something is not 100% clear. Just make sure to not use an AI assistant in order to solve the challenges of the course, because that would obviously be completely counterproductive. You wouldn't learn anything at all. So basically only use these tools after you have already finished the course and after you know exactly what you're doing. But that's exactly what we learned in the last lecture, and so let's not repeat all of that. So anyway, with this we finish up this section, and so let's now move on to the next one and really start learning JavaScript. So see you there very soon. In order to follow the project in the next section, and also the other projects in this course, it's going to be very helpful to be familiar with the basics of HTML and CSS. And so that's what this section is all about. It's a very simple crash course in HTML and CSS just to get you started with these technologies. Now, if you already know HTML and CSS, then please just skip this section. But if not, then let's now move on.